Well, today we are going to start with our first class of circle. I have already completed straight lines, which you people, if you have not seen, you can see the videos in my playlist, in that playlist named Straight Lines. So you can check it there. So today we were going to start with circle. And in this class, we are going to cover the basic things of circle, and they are first the definition, then different forms of circles: center radius form, standard form, general equation, concentric circles, diametric form of circles, and last but not the least for this lecture is the parametric form. So let us start our class with the definition. Now, what is a circle? A circle is basically a moving point moving in a plane in such a way that it always maintains a fixed distance from a fixed point. This we all know from very childhood. We all know from very childhood that a circle is always having two things. One is its center, another one is its radius. And this radius is fixed for a particular circle. So in our higher classes, in class 11, we are defining this in terms of locus. It is basically a moving point moving in a plane in such a way that it always maintains a fixed distance from a fixed point. And this fixed point is what called the center of the circle. And this fixed distance is what called the radius of the circle. So for a circle, whenever we are discussing circles, even in the problems when we will do afterwards, we will only concern about two things. Always remember, we are always concerned about two things. One is its center, another one is its radius. Okay? So now let us come to different forms of circles. First is, which is called your center radius form. Now we are going to find out the equation of the circles, right? Now, when the center and radius is given to us, this is a very basic form of the circle. Whenever your center and your radius is given, how to find out the equation of the circle? Suppose the center given is alpha comma beta, and let us say the radius is say r. So how to find out the equation? We will say let h comma k be any point on the locus. Locus का मतलब क्या है? यहाँ पर we have to find out a relation which contains hk and the given constants. So for this, if I find out what is the distance from the center to that point, it will be under root h minus alpha whole square plus beta minus k whole square, right? This is by using the distance formula. And this is exactly which is equals to your r. Because r is the distance between this center alpha beta and the variable point hk. Therefore, the equation of the locus becomes x minus alpha whole square plus y minus beta whole square, which is equals to your r squared. So this is what is called your center radius form. Again, I'm telling you, this is the very basic form of a circle. Okay, when we know the center and when we know the radius. Okay, and the second form is a standard form. What is the standard form? Standard form is that we always consider the center to be at the origin. And let us say the radius be A or R, whichever way you take. Therefore, the equation of the circle will be x square plus y square equals to a square. That's it. So this is the standard form of any circle. Standard form means we always consider that its center is at the origin and radius is a units. Is it clear to all, everyone? Center radius form and standard form. These are the two forms we have learned so far. Okay, let us take some problems on that. See this question. The question is find the equation of the circle having 1 comma minus 2 as its center. So now you know its center. And as I told you that whenever you are solving circle problems, always remember two things. Always remember two things. One is your center and another one is your radius. Always try to find out these two things. So center we know. And it is saying that it is passing through the point of intersection of these two straight lines. Now quickly, if I solve these two equations, what we are going to have? So if we subtract, so y is coming to 1. And if I put y in the first equation, we are getting, so x is coming to 13/3. Is it clear to all? Oh, I'm sorry. I have done one mistake over here. I'm multiplying this with 3, right? Not 2. I'm multiplying this with 3. So here I have done a little mistake. This calculation mistake. Just 1 second. So if I multiply that with 3, we are getting, because I have multiplied this with 2 to get the first one, and the second one is, right? Now, if I subtract, we are getting minus 13y equals to, we are having minus 26. That gives us y is 2, right? If I put y over there, we are getting 3x as, so x is coming to 4. Therefore, the circle is passing through the point 4, 2, and its center is 1, minus 2. Therefore, its radius will be, root over 4 minus 1 whole square plus, so that gives us 5. So radius is 5 and center is 1, minus 2. So naturally, we will find out the equation of the circle by using our center radius form, x minus 1 whole square plus y plus 2 whole square equals to the radius square, which is your 5 square, which is 25. So if I expand this little bit, so we are getting x square plus y square minus 2x plus 4y minus 20 equals to 0. Is it clear? Pretty simple sum, but very good sum for initial practice. So I hope you have understood this center radius form of a circle. Let me take another problem of this kind. They have said if the two diameters of the circle lie on the line x minus y minus 9 equals to 0 and x minus 2y minus 7 equals to 0. These are what? The equation of the diameters. The equation of the diameters of the circle, right? And we all know that for any circle, diameters means what? It is passing through the center. It is passing through the center. Isn't it so? So these are the two diameters. Now think about it. If I solve these two diameters, I mean the equation of these two diameters, what we get? We get the center of the circle, right? We get the center of the circle. So let me just quickly solve these two equations. I mean the equation of two diameters. So what we are going to have? And x minus 2y minus 7 is 0. So simply subtract. So you are going to have y minus 2 equals to 0 implies y is 2, right? If y is 2, you are getting x as 11. Therefore, the center of this circle is at 11, 2. Okay. Now what we need? We need the radius. We need the radius of the circle. And for that, if you see, we have been given a second condition that the area of the circle is 38.5 square units. We know that area of any circle is pi r square. So pi r square is basically 38.5. Therefore, your r square is coming to 38.5 divided by pi, which can also be written as, okay? So now we can write this. It can be written as 385 over 10 into 7 over 22. Okay. So now if we divide 385 by 11, we are getting 35. So that's 2. This is 35, right? So we are actually having 20 here. 35 into 7, don't multiply this. You can write this thing as 7 into 7 into 5. So cancel this one, again 4. So it's basically 7 over 2 whole square, right? Therefore, our R comes to 7 over 2. Your R is 7 over 2. So two things we need. We got two things. We got the center, which is 11, 2, and we got the radius 7 over 2. Therefore, the equation is the center radius form, which is your whole square. So we are getting what? This right after simplification, you are going to have this. So I'm not doing the calculation. You can do this calculation by yourself. Okay. So that is the equation of this circle. So have you understood this? Have you understood this? What I have done? Here, again, I'm telling you in these two problems, what we have mainly focused on. First of all, find out its center, and then you find out the radius. The moment you get the center and radius, you know the equation of the circle. As simple as that. Throughout this whole circle chapter, we will do exactly this thing. We will try to find out its center and we will find out its radius to get the equation of the circle. Right? That's exactly what I have done here. Again, I'm telling you the calculation I have not done. You can do it by yourself. Okay. So now let us come for another form, which is called your general equation of a circle. We will learn general equation of a circle. Right? See, the general second degree equation, We have already learned this thing in straight line chapters. So there we have learned that general second degree equation is of the form, okay? Those who have not revised straight line, please revise straight line. So this is the general second degree equation, and this general second degree equation will represent a circle. This will represent a circle when A is equals to B. This is the first condition, that your A has to be equals to B. What is A? This is coefficient of x squared must be equals to coefficient of y squared. This is the first condition. And the second condition is that there should not be any term containing xy. There should not be any term containing xy. That is, your h has to be equals to 0. So these are the two conditions we have to remember. First is what? Your coefficient of x square and coefficient of y square, they must be same. And what is the second condition? There should not be any term containing xy. Is it clear? So now, this general second degree equation will transform into, for the simplicity of the problem, let me take A equals to B, because A has to be equals to B if it represents a circle. Let us take A equals to B equals to 1. Okay. So this general second degree equation will transform into x square plus y square plus 2gx plus 2fy plus c equals to 0. And this is what is called the general equation of a circle. This is what is called general equation of a circle. Clear? It is called the general equation of the circle. Now the big question, what is its center and what is its radius? So what I will do here is, I will transform this equation into center radius form. And for that, I'm doing a simple calculation. Please check this one. So let me just add g square and f square in the left hand side. Similarly, g square plus f square in the right hand side. So we are having this as x plus g whole square, y plus f whole square equals to root over g square plus f square minus c whole square. Is it clear? So now this form is your, which form? This is your center radius form. And from this form, we can say that the center of the circle is minus g and minus f. How I'm saying that? You simply put x plus g equals to 0. From here, we are getting x is minus g. And you put y plus f equals to 0. From here, we are getting y as minus f. And that is the reason why I told you the center will be minus g minus f. Let us just refer to the previous slide. Say in this, the equation was this. This is the center radius form. What is its center? Its center is, if you put x minus alpha is 0 and y minus beta is 0, we are getting x as alpha and y as beta. That's exactly what we got here. And what is the radius? Radius is whatever there is in the right hand side, uska jo square. Here r square is there, so radius will be only the r, right? So same thing here also. Same thing in this also. So here we got the center as, by putting x plus g equals to 0, we got minus g and minus f. And what is its radius? Its radius will be whatever there is in the right hand side, uska square. Matlab, your radius is basically root over g square plus f square minus c. That's it. That's it. So whenever this general second degree equation is given, its center will be always at minus g comma minus f, and radius will be root over g square plus f square minus c. Now a question will come, sir, if equation, general equation of a circle is given to us, so every time do I have to go for all this thing to convert that thing in radius, center radius form, and then we can predict about its center and radius? Answer is no. Simply by observing this result, you can find out its center and radius instantly. The moment you see the general equation of the circle is given, you can easily find out its center and radius without converting it in the center radius form. How it is? Please observe this result. What is your G? G is basically the coefficient of x divided by 2. So how we will remember to find out the center? It's coefficient of x, coefficient of x divided by 2, and plus sign was there and here it is minus sign, so change the sign. Remember in this way, the abscissa of the center will be coefficient of x divided by 2, change the sign. Similarly, coefficient for the ordinate of the center, coefficient of y divided by 2, which gives us f, because coefficient of y is 2f, divided by 2 gives us f, and change the sign. So its center will be minus coefficient of x divided by 2 minus coefficient of y divided by 2. But remember one thing, it is only possible when the coefficient of x square and y square is 1. कोफिशिएंट ऑफ एक्स स्क्वायर एंड वाई स्क्वायर जब 1 होगा तभी ये शॉर्टकट फॉर्म हम यूज कर सकते हैं. यू कैन यूज दिस फॉर्म only when the coefficient of x square and y square is 1. Now the question will come, sir, if the coefficient is not 1, then what to do? If you find that the coefficient of x square and y square is not equals to 1, forcefully make it 1. Forcefully make it 1. How I will do that? Suppose if the question was 5x square plus 5y square. What I'm saying is, if the equation would have been in this form. Now here what we can see, the coefficient of x square and y square is not 1. So we cannot find out the center by using this shortcut way. We cannot use this formula. So what I have to do, I have to make the coefficient of x square and y square equals to 1 to use the form. Okay, so what I'm doing here is I'm simply dividing by x square, 5. So if I divide by 5, both sides of the equation, we are going to have okay. Now you can predict about its center. Its center will be coefficient of x, that is 2g by 5, divided by 2, which gives us g by 5, and change the sign. So it will be minus g over 5. Similarly, coefficient of y, which is 2f by 5, divided by 2, which is f, over 5 and change the sign. So it will give us minus f by 5. Is it clear? So what we have learned, we can use this form. We can use this shortcut method of finding out the center if the coefficient of x square and y square both are equals to 1. And if it is not, forcefully, as I shown you here, forcefully you have to make it 1. And then you can find out its center. Now, finding out its radius is pretty simple if you observe it. We see that your center is minus g minus f. So how you will find out radius? Remember in this way. You will simply write whatever coordinate, whatever abscissa you got for the center, uska square, matlab minus g ka square. So that will give us g square only. Then plus ordinate of the center ka square, matlab minus f ka square, which gives us f square. Is it clear? सेंटर जो आया, जो कोऑर्डिनेट आया, उन दोनों का स्क्वायर करके सम करो and minus the constant term given in the equation of the circle. Right? So now we know how to find out the center by using this shortcut form, and then we can easily find out its radius. Two things very clear to us. Okay, let me take a problem based on this, but before that, let me just discuss about the nature of circle. See, for the circle, for the general equation of a circle, we got center at minus g minus f and radius is root over g square plus f square minus c, correct? Now, the moment you see that your radius is coming within something, root sign is coming, right? The moment this root comes, we are having three conditions. We are having three conditions. One is that if your g square plus f square is greater than c, if g square plus f square is greater than c, then we are getting a real circle. Isn't it so? Because under the root sign, you are having something positive value. So that root is defined. So you are getting a real circle whose center is at minus g minus f and radius is root over g square plus f square minus c. Now, if g square plus f square is equals to c, then what happens? Your radius becomes 0. But still you are having your center. Center is there, minus g minus f, but your radius comes to 0. It represents a point circle. So what is a point circle? A point circle is having its center, but it is having no radius. That is, the length of its radius is 0. That is what is called your point circle. Is it clear? So it is possible only when g square plus f square equals to c. And obviously, if g square plus f square is less than c, then under the root sign, you are getting some negative value. So you are not going to have real circle. Then it will be an imaginary circle. Is it clear? So nature of circle is clear. Three things we have to remember. If g square plus f square is greater than c, you are getting a real circle having real radius. If g square plus f square becomes equals to c, you are going to have a circle whose radius will be 0 and it is termed as point circle. And if g square plus f square is less than c, then you will say no such circles are possible. So this kind of circle is what called your imaginary circle. No real circle possible if g square plus f square is less than c. Okay. So now let us find the center and radius of this circle. Look it very carefully. I told you that I can use my shortcut form if your coefficient of x and y, x square and y square, are 1. But here it is not 1. So what I will do, I will simply divide both sides by 36. So we are getting something like this. Yes. Now what will be its center? Apply the formula. Coefficient of x divided by 2, change the sign. Okay. Coefficient of x, which is your 1, divided by 2, which is half, change the sign. Minus was there and I've written plus. Coefficient of y, it is minus half, you can take. Divide by 2, so it's 1 over 4. Change the sign, so minus will get positive plus. So your center is coming to half, comma, 1 over 4. Now what will be its radius? How to find out radius? Root over 1 by 2 whole square, 1 by 4 whole square minus its constant. Constant is 11 over 36. So we are getting under root. Okay. So we can write this thing as, it's, let us say 9. Don't do it in this way. Let me do one thing. Let me take the LCM of this. Let me take LCM of this. What we are getting. From here we are getting 4, 16 and 36. Let me take the LCM of that. 4. It's 1. Then coming to. So I can easily take, okay, 4. Okay. So it's 16 into 9, right? So let me take the LCM. 16 into 9. So this is coming to 36. This is coming to 9. And this is coming to have I done anything mistake? This calculation error, 16 into 9 we are getting now. 16 into 9, yeah. 9 4s are 36, so it's 4. So it's coming to 44, right? And it's complete root. So we are actually having 45. So it's 1 over 4 into 3. That gives us 1 over 12, right? Therefore, the center is half, comma 1 by 4. And your radius is 1 over 12. Is it clear to all? Is this clear to all? Okay. So what we have learned, whenever the general form is given to us, we always check that the coefficient of x square and coefficient of y square should be equals to 1. If it is not, we will forcefully do that. And then we will straight away find out its center and radius, right? By using that formula. Okay. The shortcut form. Okay. Now let us see this question. If the equation this represents a circle. Now, I told you that general second degree equation will represent a circle when it is fulfilling two conditions. One is coefficient of x square must be equals to coefficient of y square. In this case, coefficient of x square is lambda, which is equals to the coefficient of y square, which is 2 lambda minus 3. Right? So first of all, the coefficient of x square must be equals to coefficient of y square. And second was what? There should not be any term containing xy. But in this question, there is no term containing xy. So don't consider this condition right here. So from here we are getting your lambda is coming to 3. Tell me yes or no. Your lambda is coming to 3. Then this general second degree equation will represent a circle. Now, if I put lambda equals to 3 over here, we are getting 3x square plus 3y square minus 4x minus 1 is 0. So simply divide by 3. Okay. Now we have to find out its radius. But before that, we have to find out the center. Where is its center? coefficient of x, which is minus 4 over 3, divided by 2, which is 2 over 3, and change the sign. So it will be plus 2 over 3. And there is no y, so the ordinate of the center will be 0. And what is its radius? Its radius will be root over 2/3 whole square minus of minus 1/3. So you are getting 4 over 9 plus 1 over 3. So it's coming like root 7 over 3. Yes or no? Okay. Hence option C is correct. Have you understood this problem? Absolutely. If you have any doubt, you can write in the comment box. So I will definitely get back to you. So therefore, your option is C. So what we have learned from here is that whenever a general second degree equation is given, as I have mentioned in the previous slide, that you must always see that the coefficient of x square and coefficient of y square, they're same, and there should not be any term containing xy. And after getting this, you can easily, because moment you have the equation of the circle, you can find out its center, you can find out its radius too. Okay, so that's exactly what I have done here. Okay, let us take another problem. See this question, very important question. Let me tell you one thing. I will do this problem. I will find out what is the area of the equilateral triangle inscribed in a circle. But I will request all of you to remember this result. To remember this result, very, very important, because this result will be needed everywhere. Okay, so let me just choose a right angle triangle. Equilateral triangle. So this is our equilateral triangle. And let us consider, already they have given the equation of the circle is x square plus y square plus 2gx, the general form. So from here we can say that my center is at minus g minus f, and its radius is root over g square plus f square minus c. Okay, let us consider this is the center. Okay, now we have to find out the area of this equilateral triangle. We have to find out the area of this equilateral triangle. Now we all know that this angle is 60 degrees since it's an equilateral triangle. Now if I join these two lines, these two vertices with the center, so what we are going to have, this angle is 120 degree, correct? This angle is 120 degree. Now, remember that if you want to find out the area of the equilateral triangle, I will use the formula which we have already know from very childhood, that the area of an equilateral triangle is root 3 over 4 into side square. So the moment you have the side, the moment you know the side, the question is over, right? So how to find out the side? How to find out the side of this equilateral triangle? Think about it. You know the radius, you know the center. How to find out the side of this triangle? Here I will use a pretty simple thing, which is from the properties of triangle. See, in this triangle, let me just give a name. Let me say this is my A, this is B, this is C. Now in the triangle ABC, AB and AC, they are the radius. Let me denote this radius by R. So this is R, this is R. Now if I apply the cosine formula, for this angle BAC, what we are going to have? Cos 120 cos theta is R square plus R square minus BC squared divided by 2 into R. Okay? Those who know the cosine formula, they can understand what I'm doing. Those who don't know, please see properties of triangle chapter in trigonometry. There you will learn how to find out this cosine formula, because as I know that you have already applied this cosine rule in physics also. So you must know this. So from here we can write cos 120 is minus half. 2 goes off. Minus R square is 2R square minus BC square. So your BC square is coming to 3R square. Correct? So what is your BC? Your BC is basically root 3 into R. Clear? Abhi, what will be the area of this triangle now? Root 3 by 4 into side square. And side square is what? It is 3R square. So you are going to have 3 root 3 over 4 R square. R square is G square plus F square minus C. So this is the area of the equilateral triangle circumscribed by the circle given by this equation. Is it clear? So this question, you must know how I got that, and at the same time you must remember this formula. Treat this thing as a formula. Whenever your circle is given and an equilateral triangle is inside the circle, the area of the equilateral triangle will be, remember in this way, equilateral triangle will be, it is 3 root 3 over 4 into radius square. 3 root 3 over 4 into radius square. That's exactly what we got. If you can remember this form, it's okay. If you can't, you can remember in this way also. 3 root 3 by 4 into radius square. That's it. Is it clear? Okay. Now see this question which came in JEE 2019. What they have said, if the area of the equilateral triangle inscribed in a circle this is 23 root 3, then C is equals to what? Now, if you don't know the formula, you can solve this sum. But it will take more time to solve, because if you don't know the formula, you have to do the same method. To get the area of the equilateral triangle is root 3 times root 3 by 4 into radius square. This you have to prove. If you don't know the area of the equilateral triangle inscribed in the circle beforehand. So that is why I told you, please do remember the formula. So area of the equilateral triangle inscribed in the circle, this is this, then find C. See how simple it is if you know the form. What is the area of the equilateral triangle? Area of equilateral triangle. What is that? 3 root 3 over 4 into radius square. Okay, and that exactly what they have said. This is equals to 27 root 3 that they have already given. So from here what you are getting, let me just simplify this. Root 3 goes off. So you are getting a radius square is 36. If radius square is 36, so what is your radius? It's 6. Okay. Now, for this given circle, the center is at -5, -6. And what is its radius? It's root over 25 plus 36 minus c. That's the radius. Yes. So I can write 61 minus c is 36. So your c comes to 61 minus 36. That gives us 25. Right? It gives us 25. Have you understood this or not? See how simple the thing will become if you know the formula. Otherwise, this you have to find out. This you have to prove sitting in the examination hall. That is why people used to say that your paper is lengthy. Right? So remember this and the thing will be easy. So your value of C is 25, hence option D is correct. Okay, understood? So what we have learned? We have learned that area of the triangle inscribed in a circle, okay, is 3 root 3 by 4 into radius square. Okay, remember in this way. Very good. Now, see this question. The question is, if the two vertices of an equilateral triangle, A and B are the two vertices given. Let me just draw the diagram. So what do you want? There are 2 points, A and B, minus A comma 0 and A comma 0. And the third vertex C lies above the x-axis and the equation of the circumcircle. Okay, so let me just draw the circle first. Let me say this is the given circle. Okay, now this is my point A, which is your minus A comma 0. This is your point B, which is your A comma 0, correct? And the third vertex C lies above the x-axis, above the x-axis. So the third vertex will be definitely at this place. Okay? So because it is above the x-axis. Let me just join this 2 points. Okay? So I've joined these 2 points. This point is basically C. So this ABC is an equilateral triangle. Clear? Now, equation of this circle. You have to find out the equation of this circumcircle. Okay. So as I told you, to find out the equation, you need two things. बार बार हम एक ही चीज बोल रहे कि दो चीज तुम्हें चाहिए always. Remember throughout your circle chapter, you need center and you need radius. That's it. If you give me these two things, I can do anything with the circle. Anything. So I need to find out its center. I need to find out its radius. Clear? So how to do that? Let us say the center is here. Now again, the same fund I am using, I am simply adding this. Simply join this one. Okay. Now, this angle is what? This angle is 60. So this angle will be what? This angle will be 120 degree, right? So this angle will be again 60 degree. Correct? Okay. So this is 60 degree. Then what? What is this length? What is this length? It's A. So from here, I can easily find out what is this base. Let me just give a name. I can easily find out what is my dA, which will give us the radius, and we can easily find out what is your dm, so you will know the center. You will know the center. Yes or no? Okay, now how to find out the radius? Now taking the triangle ADM, see the triangle ADM, this angle is 60 degree, this angle is 60 degree, and I need to find out, I know AM, I need to find out AD. So your A by AD is sine 60 degree. So your A over AD comes to root 3 by 2. Therefore, AD gives us 2A over root 3. AD gives us 2A over root 3. That is, the radius of the circle is 2A over root 3. Is it clear? Now, what is your DM? By the way, please do remember this aim is nothing but the origin. This aim is basically the origin, isn't it so? Because this part is A, this part is minus A, comma 0. So definitely those A and B are on the x-axis. So aim is the origin. Please do remember. Aim is what? It is the origin. So you got AD, means you got the radius. Now I have to find out the center. For that, I have to find out what is DM. So again, DM over AM. DM over AM is cot 60 degree, right? So what is DM? It's AM cot 60 degree. And what is AM? The length of the side AM is A. Don't take minus A. It's A. Length cannot be negative. It's A into cot 60 degree. That gives us 1 over root 3. So it is A over root 3. DM is A over root 3. So what is the coordinate of D? It's basically, since it is on the y-axis, the coordinate of D will be 0, comma A over root 3. So now you know the center, you know the radius. So you know the equation of the circle. Center radius form. Open the brackets. So we are having 3x squared plus root 3y minus 9 whole square is equals to 4a squared. So let me open the brackets. We are getting 3x squared plus 3y squared minus 18 root 3y. Yes or no? 18 root 3y, which is equals to, am I doing it? Oh my God, it is not 9. It's basically A. I have written this thing as 9. It's okay. It's A actually. This is my A. So we will write this thing as, I will write this thing as 3y square minus 2 root 3ay plus a square is 4a square. So that gives us 3 times x square plus y square minus 2 root 3ay is 3a square. Is it clear? Hence option A is correct. Is it clear to all? Have you understood? See, again, बार बार हम एक ही चीज बोल रहे हैं, हम क्या कर रहे हैं, ऑब्जर्व करो. Every time my main motto is to find out the center and radius. Center और radius निकल गया, सब कुछ निकल गया of a circle. So whenever you are solving problems on circle, always you should have only one idea, how to find out its center and how to find out its radius. That's it. You will get all your answers. Trust me. Okay. Let us do another problem. Let the mirror image of the circle. So C1 is a circle given to us. C1 is a circle which is given to us, which is our C1. This circle is C1, okay? Now I want to find out the image of this circle with respect to a line, given y is equals to x plus 1, okay? So let us say the image of this circle will be somewhere here. This is the image. This is the image of that circle. Clear work? Right? Okay. So this is my circle C1. This is my circle C2. This is the image. Can you tell me? The image of this circle will have one thing common. What is that? That is its radius. Its radius. Radius of C1 must be equals to radius of C2 because they are the image. So their radius will be same. Their coordinates of the center will change, but not its radius. Okay. Now, what is the center of C1? From this, what you will say? What is its center? Its center is coefficient of x divided by 2, change the sign, it's 1. Coefficient of y divided by 2, change the sign, it's 3. Is it clear? And what about the center of C2? What is the center of C2? Your equation is what? So I will divide by 5. Yes. So what is its center? It's minus G minus F. That is, center of C2 is minus G minus F. Clear work? Is it clear to all? Okay. Equation of the line given to us is x minus y plus 1 equals to 0. Clear? So now, the center of C2 will be the image of the point 1, 3 with respect to this line. So what will be its center? I'm using the image formula to find out the center of C2. Again, I'm telling you, those who have not done straight lines, they will face problem here. That is why I'm requesting all of you to please go through all the videos that I have uploaded in straight lines. Repeatedly, I'm telling you that. Otherwise, you will face problem throughout your coordinate geometry, not only in circle. In parabola, in ellipse, in hyperbola, everywhere you are going to face problem. So x minus 1, I'm not going to explain you how I'm doing this because the students who have already done this one, they can understand it better. Why I'm doing this and how I'm doing this to find out the image of a point with respect to a line. So we are getting 2 goes off and this is only 1. So from here we are getting x is basically 2 and y is basically 2 also. Therefore, the center of C2 is 2, 2. It implies what? Your minus G is 2 implies G is minus 2. Similarly, minus F is 2 implies F is minus 2. Correct? G is minus 2, F is minus 2. So, the given equation, this equation becomes what? This equation becomes, we can write from here only, it is x square plus y square. Your G is minus 2, so it is minus 4x minus 4y plus 38 over 5, which is equals to 0. Clear? Now, what is its radius? Its radius is root over 2 square plus 2 square minus 38 by 5. So that gives us 4 plus 4 is 8 minus 38 by 5. That is root over of 2 by 5. That's it. Is it clear? Now, this radius, this is the radius of C2. This is the radius of C2, which is same as radius of C1. Yes or no? Radius of C1. Now, what is the radius of C1? It is root over. This is radius of C1. What is that? Root over of 1 square plus 3 square minus alpha. Yes? So you are getting what? Under root 10 minus alpha. So this must be equals to root over of 2 over 5. Therefore, 10 minus alpha gives us 2 over 5, implies alpha is 48 over 5. Alpha is 48 over 5. Is it clear? Therefore, we need to find out the value of alpha plus 6r squared. So it will be what? 48 over 5 plus 6. R means this is your R. Because R is the radius of R2, C2. So this is your R. Yes or no? This is your R, which is the radius of your circle C2, which is same as the radius of your circle C1. So your R is root over of 2 by 5. So 6r square will give us. So that gives us 48 plus 12 over 5. That gives us 60 over 5, gives us 12. So the required value of this alpha plus 6r squared is nothing but 12. Is it clear to all? Absolutely? No doubt? Okay. Let's move for the next one. So we have already done 3 forms of circle. One is your center radius form. One is your center radius form. The another one we have done standard form. And then we have learned what is the general equation of the circle. So these 3 forms we have already learned. Now we are going for another form which is called your concentric circles. Concentric circle. What do you mean by concentric circles? Concentric circles are those circles which are having its center same. The center of all concentric circles, their centers are all same. See, these are all concentric circles. They're all centers are same. Their centers are same. So the only thing which is different for all this circle, because there will be infinite number of circles which are concentric to the given circle. Let us say this is our given circle. Let us say this is our given circle. And the equation of this circle is x squared plus y squared plus 2gx plus 2fy plus c equals to 0. Now, any circle which is concentric to this circle, its center will never change. Its center will remain same. Yes or no? Its center will remain same. Only thing that will change is its radius. Think about it. What is its center? Minus g comma minus f. This is not going to change for any concentric circle. And the radius of this circle is root over g square plus f square minus c. Now, as g and f are same for all the concentric circles differ by its radius only. So this C will get changed every time. For different values of C, you are going to have different equation of the circles, which are having their center same as minus D minus F. These circles are what called your concentric circles. Clear to all? Therefore, equation of all concentric circles of one is this one. Any concentric circle of 1 is given by only this constant will differ. For different values of lambda, it is going to represent different concentric circles. Why I'm telling you concentric? Because their center is not getting changed. That is why it is concentric. Okay? Only the radius will differ. Is it clear to all? So now we know how to find out the equation of concentric circle of a given circle. Okay, great. So all we do is we write the same equation, only we change the constant of the given equation. That's it. Let us say this question. Find the equation of the circle concentric with this circle and passes through minus 2 comma minus 7. Okay, any equation concentric to the given circle, equation concentric to the circle is given by x square plus y square. Everything remains same, only this constant will be changed. Correct? Now, as it is passing through the point minus 2 comma minus 7, hence it must satisfy this equation. So put minus 2 in place of x and minus 7 in place of y to get the value of lambda. So how much you are getting? It's 16, 4 plus 16, 20, 69 minus 42 plus lambda equals to 0. So 69 minus 42, that is going to give us 27. So lambda is coming to minus 27. Is it clear? Lambda is coming to minus 27. Therefore, what is its equation? X square plus y square minus 8x plus 6y minus 27 equals to 0. That's it. So that's the equation of the concentric circle of the given circle, which is passing through the point minus 2 comma minus 7. Is it clear? Is this conception clear? It is simply the application of the equation of the concentric circle. Okay? Now, let us come to another important thing, which is called important form of the circles, which is called the diametric form of the circle. What is that? We have been given a circle, and at the same time we have been given the extremities of the diameter. Suppose this is the diameter, and we are having the extremities of the diameter as x1 comma y1 and x2 comma y2. These are the extremities of this diameter. This is a diameter. It is passing through the center. Now the question is, you have to find out the equation of this circle. See, there are two ways of finding out. One, very boring method, and number two, the second method is very interesting method. But first I will tell you the first method. I told you to find out the equation of circle, you need two things. One, it's its center, and another one, its radius. Please try to observe this carefully. So what will be its center? As we know, the center is the midpoint of the extremities of this diameter. Therefore, the center will be x1 plus x2 by 2, y1 plus y2 by 2 by using the midpoint formula. Now you know the center. You know the other points on the circle. So you can easily find out the distance between these two. So there straight away you are going to get the radius. So you know the center, you know the radius, you know the equation. Am I correct? This is one way of doing. This is method one. Okay, to find out the equation. You know the center, you know the radius. So easily by center radius form of the circle, you can find out its equation. Okay, but I will use method 2. Both these methods you have to know. Methods you should know. Okay, so what I will do, I will simply take, let x comma y be any point on this circle. Let x comma y be any point on the circle, and I will simply join these 2 points. This one and this one. Is it clear? Now, how many of you can see that this angle is 90 degrees? How many of you can see that this angle is 90 degrees? Why? Because angle in a semicircle is always a right angle. So now to find out the equation, what I will do, I will simply find out the slope of this line. What is the slope of this line? It will be y minus y2 over x minus x2. And what is the slope of this line? It will be y minus y1 by x minus x1. Now, since the angle between them is 90 degree, so the product of these two slopes will be equals to -1. And you got the equation of this circle straight away. How I will write this? So we are having y minus y1 into y minus y2 equals to 0. That's it. So this is how we find out the equation of a circle when we know the extremities of its diameter. It's x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals to 0. That's it. What is x1, y1 and x2, y2? x1, y1 and x2, y2 are the extremities of the diameter. This is the extremities of a diameter. Is it clear? So the moment you know the extremities of the diameter, you know the equation of the circle. As simple as that. Okay? Good. Now I have written here a special observation. Very special observation. Can you see the equation of this circle when we know the extremities of the diameter? It's x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals to 0. And what is x1 and x2? These are the abscissas of the extremities of the diameter. And what is y1 and y2? These are the ordinates of the extremities of the diameter. Yes or no? Yes or no? So now, can you find a very interesting form? How many of you can see this? You people have all done this kind of things in quadratic equation. X minus x1 into x minus x2, it represents when a quadratic equation are having two roots, x1 and x2. If a quadratic equation, let us say x square, whatever, plus say bx plus c, it equals to 0, it has two roots, let us say x1 and x2. So in that case, we can write x square plus bx plus c is simply as your x minus x1 into x minus x2. Can you remember this form? So this is what we have learned. If in the question, listen it carefully, because JEE people have already given a question based on this. Whenever a quadratic equation is given in x, and we know that two roots are x1 and x2, then we can write this thing as x minus x1 into x minus x2. So the first form of this diametric form will be nothing but x minus x1 into x minus x2, which is same as the quadratic equation given to you in terms of x. Why I'm telling you why it is easier? Because here you don't need to find out what are the values of x1 and x2. I don't need it. Because the moment you have x square plus bx plus c, I know that it will have two roots x1 and x2, which are the abscissas of the given coordinates of the extremities of the diameter. So why to multiply? Why to find out x1 and x2? I will simply straight away write in place of this x squared plus bx plus c. That's it. Similarly, whenever an equation is given to us in y and they have said that these two roots are y1 and y2, where y1 and y2 are the ordinates of the extremities of the diameter, then why to find out y1 and y2? I will simply write in place of this quadratic expression. That's it. Getting my point? So it's a special observation you people must remember. I have written over here. Please see this one. What I have said, that a quadratic equation whose roots are x1 and x2. What is x1 and x2? These are the abscissas of the extremities of the diameter. And what is your y1 and y2? They are the ordinates of the extremities of the diameter. Therefore, the equation will be, the equation of the circle will be the quadratic equation whose two roots are x1 and x2. That is this expression I will write, or the expression which is given to us, I will write it. And a quadratic equation whose roots are y1 and y2, I will simply write that expression to get the complete equation of the circle. Is it clear to you? Let me take one example related to this. Let me take first this example. Let me take this example. No, not this sum. See this sum. This sum actually came in JEE Main 2022. What they have said? What they have said? They have said, let the abscissa of the 2 points P and Q on the circle be the roots of this. Listen it carefully. The abscissa of 2 points P and Q of a circle be the roots of this. And the ordinates of P and Q are the roots of this. If PQ is the diameter of this circle, then find the value of this. This is the question came in JEE 2022. Now, if you have a proper observation on the thing that I taught you right now, where it is, this one, okay? So, what you will write? A quadratic equation whose roots are x1 and x2. What is x1 and x2? Abscissa of the extremities of the diameter. And what is y1 and y2? The ordinates of the extremities of the diameter. So in this question, we have already been given the circle is given, and this diameter is given, whose extremities are, let us say, it is x1, y1, and this is x2, y2. Now, to find out the equation of the circle, because you have to find out the equation of the circle, until unless you get the equation of the circle, you cannot compare with this one to get the values of A, B, and C. So now if you want to solve for x1 and x2, you have to solve this equation to get x1 and x2. You will solve this equation to get y1 and y2. See how lengthy the sum will become. And you can easily see that these values are not very comfortable one. Because here you have to use Sridharacharya's method to get roots of y, which will be an irrational one, isn't it so? So it will make unnecessary the sum complicated. But if we know the basics, what we will do, we will simply write equation of the circle is, I will simply write x square minus 4x minus 6 plus y square plus 2y minus 7 equal. That's it. That much simple it is. So x square plus y square minus 4x plus 2y equals to 0. That's it. So this is the equation of the circle whose extremities of the diameter PQ are x1, y1 and x2, y2. Now, according to the question, they have given that this is the equation of that circle. So I can compare. So I can write 2a is minus 4 implies a is minus 2. And 2b is 2. From there, we are getting b as 1. And comparing, we get c as minus 13. So what will be the value of a plus b minus c? It is minus 2 plus 1 plus 13. That gives us 12. So option A is correct. Yes or no? That much simple it is if you know the basics. That is why I told you, always try to remember the shortcut tricks that I am always give in my lectures. So make a note of it, because this shortcut methods will be highly useful while you will be solving problems, even in the IIT advanced level. Okay? Chalo. So now we have understood the fact that when it is a form given in this diametric form, and if the quadratic equation is given to us, we are not going to solve for x1 and x2, neither for y1 and y2. We will simply write down those equations to get the equation of the circle whose extremities of the diameter is known to us, right? Okay, let us say this. Let us take this question. Find the equation of the circle passing through the points . So what is the question? The question is that a straight line, a circle is passing through the point, this origin 0, 0, and 2 points A, comma 0 and 0, comma B. Okay, now we have to find out its equation. We can easily see one very interesting thing here. We all know that if I join this two, okay, this angle will be what? Angle in a semicircle is always a right angle. So these 2 points actually becomes what? These 2 points become the extremities of the diameter. Therefore, its equation will be x minus x1 into x minus x2 plus y minus y1 into y minus y2. which is equals to 0. So from here we are getting the equation of the circle will become, is it clear to all? Because the angle in a semicircle is a right angle, so this line is basically the diameter of this circle. And these 2 points, 0, B and 0, A, 0, these are the extremities of the diameter. So we got the equation of the circle. Clear? Okay, let us take the next, another problem. See this question. Find the equation of the smallest circle passing through the points -1, 2 and 3, -4. There are 2 points. One is -1, 2. Another one is, let us say, 3, -4. Okay, these are the 2 points. Now, through these 2 points, there are infinite number of circles that can pass. Tell me yes or no. There are infinite number of circles which can pass through these 2 points. Let us say this circle, or it can be like this circle. There are a lot of circles which can pass through these 2 points, isn't it? Okay, so another one can be this circle at the same time. This one, millions of, infinite number of circles can pass. Infinite number of circles can pass. Okay. Now you have to find out the equation of the smallest circle. You have to find out the equation of the smallest circle. Now here, all of you make a note. It is pretty simple thing. Simply by looking the figure, you can understand. The smallest circle will be that circle where these 2 points are the extremities of the diameter. Smallest circle is what? Is that circle whose extremities of the diameter, are -1, 2 and 3, -4. That will be the smallest circle. Otherwise, the area of that circle will be bigger than the circle whose extremities of the diameter are these 2, which is the smallest circle. Smallest circle means its area will be less. That is the smallest one. Are you getting my point? So what will be the equation of that smallest circle? Equation of smallest circle will be what? When these 2 are the extremities of the diameter, therefore its equation will be x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals to 0. That's it. You can leave your answer here or you can expand this. Matter is yours. According to the given option, we will expand this, right? Otherwise, leave the answer here. So this is the equation of the smallest circle. So what we have learned, now whenever different circles are passing through 2 given points, the smallest circle will be that circle whose extremities of the diameter are the given 2 points, right? Remember this, make a note of this. After the class, you can all get this PDF. I will give the link in the description box so you can download the PDF from there. Okay, now let us see. This is again a very, very important question. Very, very important question. Tangents are drawn from point. What do you mean by tangent? Tangent is basically a line which is intersecting the straight line circle at only one point, right? So now what I'm doing, I have drawn two tangents from point P, which is outside the given circle. This is one tangent. This is another tangent. These are the two tangents I have drawn from the point P, which is your 1, 8, right? Now the circle which is given to us, the equation is x squared plus y squared. Now what is its center? Its center is 3, 2. And what is its radius? Its radius is root over 9 plus 4 minus of minus 11. So that gives us, it's coming to 24, right? It's root 24. Is it clear to all? So I know the center of this circle and I know the radius of this circle. Okay, very good. So I have to find out, this is my A and this is my B, let us say. These are the 2 points where the tangents are drawn from point P. Now, all I have to find out is the equation of this circumcircle of the triangle PAB. We have to find out the equation of the circumcircle of the triangle PAB. Is it clear? Okay. Now, what I'm doing here, a very interesting thing. I'm simply joining this point of contact with the center. Is it clear? And let me join this point also. Okay. Now, let us say the point, this is, let us say Q. Q is the center. Now, what about this angle? This is actually the line joined the origin to the point of contact. I mean, the center and the point of contact. So this will be definitely perpendicular on the tangent. Similarly, this will be also perpendicular to the tangent PB. Okay. So now listen it carefully. Now, in the quadrilateral PAQB, observe it. In the quadrilateral PAQB, this angle plus this angle is 180 degree, implies PAQB is a cyclic quadrilateral. Is a cyclic quadrilateral. This all you have done in class 10 level. This is a cyclic quadrilateral. When the sum of two opposite sides, opposite angles is equals to 180 degree, it becomes a cyclic quadrilateral. That is, if you draw a circle which is passing through P, A and B, it is definitely going to pass through Q, as PAQB is a cyclic quadrilateral. Have you understood this? Is this clear to all? Tell me. So your cyclic quadrilateral, just 1 second. So your cyclic quadrilateral PAQB, if I draw a circle which is passing through A and B, it is definitely going to pass through Q also. Bolo bhai, yes or no? Absolutely yes. Why? Because it's a cyclic quadrilateral. Is it clear? It's a cyclic quadrilateral. So it is passing through Q. So this circle is actually the circumcircle of the triangle PAB. But see the interesting thing, this angle is 90 degree. If this angle is 90 degree, so it is a angle in a semicircle is a right angle. So definitely your PQ is nothing but the diameter of the required circle. Tell me yes or no. This is the diameter of the required circle which circumscribes the triangle PAB. Okay, Q is the center of the given circle, which is 3, 2. So what will be the equation of this circumcircle? By using the diametric form, we can find out. As PQ is the diameter now, so the equation of the circle will be, is it clear? Open the brackets. Therefore, the required equation is, that's it. This is the required equation. In coordinate geometry, if you can use your basic geometry which you have learned in class 10, sums will be much, much easier, trust me. When coordinate geometry is mixed with the plane geometry that we have learned in class 10, it becomes a wonderful sum, and you will have that, enjoyment in solving those kind of problems when you can apply your basic plane geometry and coordinate geometry. That's exactly what I have tried to do it here. Okay, so let me reveal the answer. Yes, is it clear now? Chalo, let us move for the next problem. Let us see this one. This is going to solve a lot of problem, lot of doubts, lot of questions will be solved right in this question if you solve this question. See, what is the question given here? It has been said that you have been given a circle. We have been given a circle. Let me just draw the diagram first. We have been given a circle. Okay, very good. We have been given a circle whose equation is x square plus y square plus 6x minus 2y plus 8 is 0. So from here, directly, what is its center? What is its center? Its center is minus 3, 1. Okay. And what is its radius? Its radius is root over of 9 plus 1 minus 8. Clear? So it's root 2. Its radius is how much? It's root 2. Okay. Center is at C. They have already said the center is at C. A pair of tangents are drawn from outside point O, where O is the origin. O is the origin. Okay. So O is the origin. I have drawn two tangents. I have drawn two tangents. This is my origin, O. And this is my A, and this is my B. Correct? Now, what they have said? They have said there are 5 parts of this question. So we have to find out the angle between OA and OB. That is, we have to find out this angle. Right? So for that, let me just join this. Let me just join this. O with C and A with C and C with B. Right? Let me just join this. So just now we have done that this angle is 90 degree. This angle is 90 degree. So OACB, it is basically a cyclic quadrilateral. That is, if we draw a circle, it is going to pass through all these 4 points because they are cyclic. Okay, now we have to find out this angle. Now, one thing we can see that from the triangle OAC and triangle OBC, in these two triangles, this is 90, this is 90, right? This is the radius of the same circle, so they are equal. At the same time, OA and OB, These are the two tangents, length of two tangents drawn from a point outside the circle. So the length of those tangents are equal. Again, we have done this in class 10. So for these two triangles are similar. I'm sorry, congruent. So we can say that this angle is same as this angle. So if this angle is theta, this angle is also theta. Now, let me tell you one very important point over here. That is, whatever thing we are doing here, all the points are very, very important. Here what we have learned, that this angle and this angle, they are same. You must remember this. You must remember that whenever we are drawing a circle circumscribing OAB, it must pass through C. These are the things which we have to remember as a result. Now we have to find out what we have to find out. The angle between OA and OB. That is, we have to find out what is our 2 theta. What is our 2 theta, right? Okay, let me just find out what is my tan theta. Tan theta is perpendicular over the base. Okay, but see one thing, we don't know what is OA, right? But we know the center, which is minus 3, 1. And this is the origin, which is 0, 0. So what is your OC? What is your OC? It will be 9 plus 1. That is your root 10. Isn't it so? OC is root 10. Now, by using Pythagoras theorem, we can find out what is my OA. OA is root over OC square minus AC square. Yes or no? OC square minus AC square. What is OC square? It's 10 minus, what is AC? That is the radius, which is nothing but root 2. So root 2 square gives us 2. That is root 8. That is 2 root 2. Clear? So therefore, your tan theta comes to what? Your tan theta comes to, what is CA? CA is your radius, which is your root 2. And what is OA? Just now we got, it is 2 root 2. So what you are getting? You are getting half. So what is your tan theta? That is your half. So what is theta? That's basically tan inverse half. Clear? Theta is tan inverse half. But we need to find out this whole angle, the angle between OA and OB. That is, we need to find out the angle 2 theta, which is same as 2 tan inverse half. That's it. So that's the angle between OA and OB, which is 2 tan inverse half. Is it clear? Okay. Now we have to find out the length of AB. What is AB? Let me join AB. Let me change the color of the pen. And let me draw AB. Okay, we have drawn AB. So now we have to find out what is our AB. How to find it out? How to find out what is the length AB? Tell me first. Think on it and tell me. I'm giving you 1 minute time. Think on it. See, one thing you can all see, I'm just helping you. I will not give you the solution right now. If you see, let us say this point is, say, M. So if you see the triangle AMC and MCB, you will find that they are congruent. Why? Because this is 90. Okay. This side and this side, they are equal. This is the common side. Yes or no? This is the common side, as well as this angle is also equal to this angle. Why I'm telling you? Because OAC is a right angle triangle. This is 90 degree and this is theta. So obviously this angle is 90 degree minus theta. In the similar way, we will say that this angle is also 90 minus theta. So these two triangles are congruent. So from here we can say that AM and MB, they are equal. Right? AM and MB are equal. So if you want to find out AB, which is same as 2 times of AM, 2 times of AM. So you simply find out what is your AM. What is your AM? Tell me. See, simple thing, simple thing. Take the triangle AMC. Take the triangle AMC. Look it carefully. With respect to this angle, this is 90. With respect to this angle, this is 90 minus theta. So if I take sine 90 degree minus theta, if I take sine 90 minus theta, what you are going to have? This is perpendicular by base. It is perpendicular by base. Yes or no? I'm sorry, I'm doing wrong. Just 1 second. I'm actually thinking something else. Okay, just 1 second. So do one thing, because I know the radius, na? I know the radius. So what I'm trying to do here is sine 90 minus theta will be what? It will be nothing but perpendicular by hypotenuse. So it will be AM over AC. And what is AC? AC is basically the radius of the circle, which is nothing but root 2. So simply write it here. AM by root 2. And sine 90 minus theta gives us cos theta. So AM is what? It's root 2 cos theta. AM is what? Root 2 cos theta. But see here, what is theta? From here we have tan theta is half. So if I draw a right angle triangle, this is 1, this is 2. So this is root 5 actually. So what will be your cos theta? It's 2 root 5. Isn't it so? It's 2 root 5. So what is AM? AM is root 2 into 2 over root 5. Please check it. Is it clear? So AM is coming to 2 root 2 over root 5. Okay. So what will be your AB? It is 2 times AM. So it will be 2 times. So that gives us 4 root over 2 by 5. That's it. So that's the length of AB, which is 4 times root over 2 over 5. I hope it is clear to all. Simply I am applying basic geometry and the thing that we have learned so far in circle. That's it. Okay, now let us come to this. Find the area of the quadrilateral OACB. OACB. Look it carefully. As we have already proved that OAC, triangle OAC, this is number 3. Triangle OAC and triangle OBC, they are congruent. They are congruent. Therefore, area of triangle OAC is same as area of triangle OBC. Therefore, the area of the quadrilateral OACB is 2 times the area of the triangle OAC. 2 times the area of the triangle OAC. Now, how to find out the area of OAC? OAC, half into base into height. Half into base. What is base? Base is OA. Into height. Height is what? AC. Now, OA we have already got. OA we have already got. Where it is? I have calculated that. Where is OA? This one. It's 2 root 2. OA is 2 root 2. So, it's 2 root 2 into AC. AC is the radius. So it is coming to 4 square units. Therefore, the area of the quadrilateral is nothing but 4 square units. Is it clear? Okay. Next question. What is the area of triangle OAB? What is the area of the triangle OAB? Tell me. What is the area of the triangle OAB? How to find it out? Triangle of the area OAB. Jaldi bolo. Write in the chat section how to find out OAB. Area of triangle OAB. There are several ways of finding OAB. Okay? How we can find out? See this one. The area of triangle OAB can be written as, we all know from the properties of triangle. Those who don't know, please listen it carefully. In a triangle, if you want to find out the area, let us say this angle is theta. And this is say A and this is say B. The length of the sides holding this angle theta are A and B. Then area of this triangle will be half AB sine theta. Remember this. It's a very important, though it has been, it has not been included in JEE syllabus, properties of triangle. They have eliminated this portion. But you must remember this one. Properties of triangle is very, very useful chapter. So area of triangle is always half into the product of two sides into sine of the angle between them. So to find out the area of OAB, I can write this thing as half OA into OB into sine of the angle between them, which is 2 theta. So this gives us half OA. OA is 2 root 2. And length of OA and OB, they are same as I have mentioned. So it is basically OA square sine 2 theta. Sine 2 theta can be written as 2 tan theta divided by 1 plus tan square theta. Am I correct? Why I am doing this? Because the value of tan theta we know. We know that tan theta is half. That exactly I will replace this to get the answer quickly. So what will be the answer then? What will be the answer then? Half OA square. OA is how much? It's 2 root 2. So it is 2 root 2 square into 2 tan theta divided by 1 plus tan square theta. So we are basically having what? Half into 8 into, this will get cancelled. So this is 5 over 4 means 4 over 5. Correct? So this is coming like 16 over 5. Is it clear? So the area of triangle OAB is nothing but 16 by 5 square units. Is it clear? Simple application of trigonometry and coordinate geometry. That's it. Here what I think, coordinate geometry is less. Plane geometry and trigonometry is more. So always try to do sums in that way. It will make the sum interesting. You will also feel very good while solving this problem. Now, the last question is find the equation of the circumcircle of OAB. As I told you that OAB, if you draw a circle, it is going to pass through C. So your OC will be the diameter of that circle. The circle which is circumscribing. Let me draw the circle. The circle which is circumscribing OAB is definitely going to pass through C as they are cyclic. I have already mentioned. So OC will become the diameter. So what will be its equation? I'm doing it here. What will be the equation? X minus 0 into x plus 3 plus y minus 0 into y minus 1. That's it. So the equation comes to x square plus y square plus 3x minus y equals to 0. That's it. As simple as that. Is this problem clear to everyone? Is this problem clear to everyone? Absolutely. Okay. Very interesting thing I'm telling you. 2-3 things you must remember. One is whatever points I have discussed here, other than solving this sum, you must remember that. This angle theta, they will be same. Just now I told you. The length of OA and length of OB, they will be same. And how to find out the length of AB. These are the things which you must remember. And the circle which is passing through OAB will definitely pass through C, because they are cyclic quadrilateral. OACB will be the cyclic quadrilateral. So you must remember that way. Okay, all the points I have discussed in this sum, you must remember. Okay, now let us move for the next problem, which actually came in our JEE Mains 2023. Same type of question. See, same type of question. If you know how to solve it, it's easy for you to solve. What is the thing given? O is the origin, OP and OQ are the tangents to the circle. Same circle. Same question. This is the circle. And there are two lines, OA and OB. This is your O. This is your O. This is your A. This is your P. This is your P and this is your Q. These are the two tangents you have drawn from the origin. This is my origin 0, 0. So the center of the circle is from this one. The center of the circle will be what? 3, minus 2. And what will be its radius? What will be its radius? Its radius will be root over 9 plus 4 minus 8. That gives us root 5. So that is the radius. Is it clear? Is it clear to all? Right? Okay. If the circumference of the triangle OPQ, see the same question they have given. They have given you the same question. What they're saying that there is a circle which is passing through OPQ. And we know that any circle which is passing through OPQ, just now we have learned that it is going to pass through its center because they are concyclic. Yes or no? Absolutely right. Like this. Like this. Okay. It is going to pass through the center of the given circle. Okay. Now they are saying that its circumference of the triangle OPQ passes through the point. This means this circle is now passing through a point alpha comma half. Then find the value of alpha. Where is the problem? You tell me. That is why I always say to all of my students that please do practice. More you practice, more these things will be clear to you. And you can retain those things. Otherwise, if you practice once, you will never retain those things till your examination. I'm telling you. So that is why please do revise at least once a month, every chapter. Then only it will be in your mind. Otherwise, you will forget. Simple thing that whenever any circle is passing through OPQ, where OP and OQ are the tangents to the circle and O is a point outside the circle, then that circle is going to pass through the center of the given circle. That's the thing which we have to remember. Because they are cyclic quadrilateral. Yes or no? Therefore, the equation of this circle will be, your OC will be the diameter. Therefore, the equation will be, by using the diametric form, so we are having x square minus 3x plus y square plus 2y is 0. So x square plus y square minus 3x plus 2y equals to 0. Now this is the, see, instantly you got the equation of the circle. And now they're saying that this circle is passing through the point half comma alpha comma half. Hence it must satisfy this. So alpha square plus 1 by 4 minus 3 alpha plus 1 equals to 0. So we are basically having 4 alpha square plus 1 minus 12 alpha plus 4 equals to 0. So we are having 4 alpha square minus 12 alpha plus 5 equals to 0. So 5 fours are 20. So 10 plus 2. So we are having yes or no? I'm sorry. This is, yeah, it's okay. 2 alpha I have taken common. So it will be 2 alpha minus 5. Okay. This is equals to 0. So your alpha can take the value either half or 5 over 2. But since half is not given to us, therefore 5 by 2 is the correct answer. Hence option C is correct. See how much time it takes. How much time it takes to solve this problem? 30 seconds. If you are very slow, then 40 seconds, not more than that. So you have saved, because you know for JEE main sum you can get at least, not at least, it should be 2 minutes every sum. 1.5 minutes. So if you can solve a problem within 30 seconds or 40 seconds, now you are saving so much of time, which you can give in other problem where some vigorous calculation is involved or some logical thing is involved. Then you can give that time. So if you don't practice, if you cannot retain all those points in your mind, how you will solve it? Okay, chalo. Okay, so let us come for the next one, which is your this one. See what they have said. The parabola y squared equals to 4ax. There is a parabola. It is y squared equals to 4ax. And we are having y equals to mx plus c. We are having y is equals to mx plus c. Now they're saying that they are meeting at two distinct points A and B. Find the equation of the circle with AB as diameter. Find the equation of the circle with AB as diameter. So how will do this? See, there is one way. Those who have not practiced, what they will do? They will simply solve these two equations. They will solve these two equations to get the point A and B. Obviously, the values will be very ugly looking. And you will face difficulty in forming the equation. Yes or no? Absolutely. So what is the remedy? What is the remedy? That is why I told you have to remember what I am saying. What I told you, that whenever there is 2 points and taking that line as your diameter, you simply form an equation. Let us say that A is x1, y1 and B is x2, y2. This will be the extremities of the diameter. Now, if you get x1, y1, I'm sorry, x1 and x2, by solving these two equations and to get that x, right? If you solve this equation for x, you are going to have two values of x. One is x1, another one will be x2. Similarly, you have to find out the two values of y, y1 and y2. Why to do so? Why to do so? What I will do? I will simply form an equation, quadratic equation involving x. And I will form a quadratic equation involving y. And we know that I will simply add those two equations to get the equation of the circle whose extremities of the diameter are the point of intersection. In this case, it is A and B. Are you getting it? Let me just refer to the previous page where I've done this. See this one? What is the diametric form? The diametric form is x minus x1 into x minus x2 plus y minus y1 into y minus y2. How I have written that? A quadratic equation whose roots are x1 and x2 and the quadratic equation whose roots are y1 and y2. So this I will use. This I will use. Now see this. What I will try to do here, I will try to find out a quadratic equation in x. I will find out a quadratic equation in x. What is x? Find out. This is y equals to mx plus c. Now let me put this thing over here. What you are going to have? Mx plus c whole square is 4ax. So what you are getting? Plus 2 mcx plus c square minus 4ax equals to 0. So m square x square plus 2mc minus 2ax plus c square equals to 0. Now divide by m square. Now I got this equation. Yes or no? Now I got this equation in x. It's a quadratic equation in x. Now if I solve this quadratic equation, you are going to have two values x1 and x2. But I am not going to solve this. I'm not at all going to solve this. Why should I solve? Because it will create unnecessary problem in the question. I'm not going to solve for x1 and x2. Leave it as it is. Is it clear? Now I will try to find out an equation involving y. So from here we can write x as. Now replace this in this equation. What you are going to have? Divide by m. Again, we got another equation involving a quadratic equation in y. Now, if I solve it, I'm going to get y1 and y2. But again, I will not solve it. Why should I? Now, what will be the equation of that circle with AB as diameter? The equation will be straight away. No need to solve. Simply add this with this. That's it. That's it. So this is the equation of that circle. This is the equation of that circle whose diameter is AB. Are you understanding the fact? Now, if somebody doesn't know this, he will try to solve this equation, which is again a blunder. Is it clear to all? Is this clear to all? This idea is a fantastic idea. I will request all of you to remember this. It's a unique thing, I'm telling you. Okay. So now let us move for the last part of our lecture, which is called your parametric equation of circles. Now, what is parametric equation and why this parametric equation every time it is coming? In the straight line it came, in circle it came, again it will come in parabola, in ellipse, in hyperbola, everywhere parametric equation will come. But what is the use of? Why we should go for parametric equation? We are happy with the thing that we have. Unnecessary, why we are doing parametric form? Now you will understand. Suppose we are solving a problem and we have said that we have to find out a point on the circle. So what do? You say let x comma y be any point on this circle. Tell me yes or no. X comma y is any point on the circle. Let us say the circle is our standard form. I'm taking the standard form. Let us say the equation is x square plus y square is, say, a square. Okay. Now this is the origin. Now if I say find out a point on the circle and some conditions are given. Now think about it. If you want to find out this x and y, you have two unknowns. If you have two unknowns to solve it, you need two equations. You need two equations. And in mathematics, more equations you involve in your sum, more complicated the sum will be. So our main tendency will be always like reducing the variables. Now, parametric form is one way of reducing that variable. How it is? For this, what I'm doing, I'm simply joining this with origin. And let us say this line, this radius is making an angle theta with the positive direction of the x-axis. So if I draw another perpendicular from here to here on the x-axis, so what we are getting? We are getting that this length is your what? This length is your x and this length is your y. And this is your radius a. So what is your x? Your x can be written as a cos theta. And what is your y? Your y will be written as a sin theta. X is a cos theta, y is a sin theta. Now you see, instead of taking let x comma y be any point which involves two variables, if we say that let us say a cos theta comma a sin theta be any point on the circle. Now this has automatically reduced one variable because here the only one parameter is theta. So to solve theta, you need only one equation. But in the previous case, in that case, you will need two equations to solve for x and y. But in this case, I need only one equation to solve for theta. That's it. That's the advantage of parametric equation over the normal equation. Is it clear? So, if the equation is in the form x square plus y square is a square, we will straight away say let x is a cos theta and y is a sin theta. This is the parametric form of the circle. Now the question comes here, ठीक है, ये तो आपका standard equation है. This is your standard equation. But if general equation comes, okay. So your general equation is something like this. Now if I solve it, what we are going to have? This manipulation I have already discussed, so I'm not going to discuss anymore here. So it's your actually root over of g square plus f square minus c whole square, right? So here, what I will try to do, I will take this variable as my x and this variable as my y. And let us say this thing is the radius, let us say r. So now can we say that x is r cos theta and y is r sin theta? Yes, we can write this. Yes, we can write this. But x is not the variable which is given in the question, capital X. So capital X can be replaced by x plus g and capital Y will be replaced by y plus f. So what is your x in that case? It's minus g plus r cos theta. And what is your y in that case? It's minus f plus r sin theta. That's it. And what's your r? R is nothing but the radius of the given circle, which is, in this case, is g square plus f square minus c under root. So this is the parametric equation of the circle. Is this clear? Is it clear? So any equation which is given to us, I can find out. Like I can take an example, like let us say x squared plus y squared minus x minus 3y, let us say minus 4 equals to 0. Now if I ask you find out the parametric equation, so first of all I have to find out what is its center. Its center is basically coefficient of x minus 1 divided by 2, that's half, change the sign, so it's plus half. Similarly, the ordinate is 3 over 2. Is it clear? And what is the radius? Radius is root over 1 over 4, 9 over 4 plus 4. So that gives us what? 10 over 4 plus 4. So that's coming to 16, 10, 26 over 4. So that's coming to root 26 over 2. Okay, that's the radius. So what I will say, what is the parametric form? X equals to minus g. X equals, what is your g over here? What is the coordinate here? You write down here, what is the coordinate? Here, what is the center? It's minus g comma minus f. That exactly what I've simply picked this and put it here. So here also I will do half plus r cos theta. What is r? R is this. And what is y? Y will be 3 by 2 plus r sine theta. That's it. That will be the parametric equation of the circle. Are you getting it? Are you getting it? Please confirm me. Okay. So this is how we find out the parametric equation of any circle. Right? Okay. Let us see this question. Find the center and the radius of this circle. This is the parametric equation which is given to us. X is 2 plus 3 cos theta. Again, I'm telling you, after the class, you can all download this PDF file from the description box. There I will give the link of this PDF. So 2 plus 3 cos theta and y equals to 3 sine theta minus 1. So I have to find out the center and the radius of the circle. So for that, I have to convert this parametric form into your general equation. So how I will find out? I will eliminate theta from these two equations. That's the way how we get rid of parametric equation to the general form. Okay, we have learned in the previous slide, we have learned that if a general form is given to us, how to find out its parametric form. Now we are learning, if a parametric form is given, how to get the general form. So for that, all you do is you simply eliminate the parameter given. Here the parameter is theta. So I will write this thing as x minus 2 over 3 is cos theta. And y plus 1 over 3 is sine theta, right? Now simply square and add the corresponding sides. So we are having, this is what? 1. So it gives us 3 square. Now what is its center? Your center is 2 comma minus 1. And what is your radius? Your radius is 3. That's it. That much simple it is. Is it clear to all? Have you understood? So what we have learned? We have learned that if normal equation is given to us, general equation is given to us, how to find out its parametric form. And next we have learned that if a parametric form is given, how to convert that in the general form. Is it clear? Now we can convert everything within this two. I mean, from one form to other form we can convert. Right. Let us take another example. See this question. This question is what? Now I have said to find out the parametric equation. Pretty simple. So you add 1 here, you add 4 here, same thing in the right hand side. So we are having x minus 1 whole square, y plus 2 whole square is your 9, which is 3 square, right? So what will be the parametric form? X minus 1 is r cos theta, implies x is 1 plus 3 cos theta, and y plus 2 is 3 sine theta, which gives us y equals to minus 2 plus 3 sine theta. That's it. So that's the parametric form which we got from the general form. Is it clear? Is it clear to all of you? Okay. Let us move for the next problem, which is the last problem for this lecture. Is whatever be the value of t, prove that the locus of the point of intersection of these two straight lines is a circle. You have to find out the locus of the point of intersection. That is, we have to solve these two given equations. We have to solve these two given equations to get the point of intersection. Right? So for that, we are finding out the point of intersection, whose locus you have to find out at the end. So let us find the point of intersection by solving these two equations. I'm multiplying the first one with sine t and the second one with cos t. So we are getting now simply subtract. If I subtract what we are going to have, this will go off. So y, if I take common, it will be sine squared t plus cos squared t. And in the right hand side, we are going to have a sine t minus b cos t. Is it clear? So your y is coming to a sine t minus b cos t. Okay? And what about your x? So x cos t from the first equation. So from here we are getting x cos t plus a sine square t minus b sine t cos t is a. So we are having x cos t is a cos square t plus b sine t cos t. Is it clear? Is this clear? So let me take cos t common. So a cos t plus b sine t. So from here we are getting x as a cos t plus b sine t. Is it clear? So what is this x and y? This is the point of intersection. And we have to find out the locus of this point. So let h comma k be any point on the locus. Therefore, your h is this and k is this. Yes or no? So what is h? A cos t plus b sine t. And what is k? A sine t minus b cos t. Yes or no? So now from these two equations, we have to remove t. The moment you remove the parameter t, you are going to get the locus. So how to remove it? How to remove that? How to remove that? How to remove t from these two equations? Tell me. Tell me. I'm not going to do this sum for you. This will be your homework. This will be your homework. I'm not going to solve it for you. You find out how to eliminate t from these two equations to get the equation of the locus. Can you see it? Can you see it? Can you see that? Simply square both sides and add. You are going to get your answer. How? If I do h square plus k square, what we are going to have? I told you that I'm going to give you this thing as homework, but still I have done it. It's okay. So if I open this bracket, what you are going to have? This is a square cos square t. This is a square sine square t. So it will be only a square. From here, we are going to get b square sine square t. From here, it is b square cos square t. So if I take b square common, so again, it will be 1. And from here, you are going to have 2ab sine t cos t. From here, you are going to have sine t cos t, right? So all these two will go off. So we are left with the equation of the locus, which is x square plus y square equals to a square plus b square. That's it. Is it clear? So this is clearly, it's an equation of a circle. It's an equation of a circle. The locus is the equation of a circle whose center is at 0, 0 and radius is root over of a square plus b square. That's it. Is it clear to all? Have you understood this thing clearly? Okay, so this is the end of this lecture. So very soon we will upload the class 2 of this circle. So stay tuned to us and see this complete video. But I will request all of you, while you are starting with the coordinate geometry circle, you must complete your straight line chapters, and which I have already uploaded in my channel in the playlist given straight lines. So you go through all the chapters there. So then you will be comfortable with the whole coordinate geometry, not only with circle, but whole coordinate geometry. Okay. Those who are new to my channel, please do subscribe and share it and like it. Thank you so much and see you in my next video. So today we are going to start with the second class. This is our second class in circle. And this class has been divided into 2 sessions. This is your part 1 and part 2 will come after this. So today we are going to complete intercepts made by circles, power of a point, and length of tangent. This will be our topics that I am going to cover in this lecture. In the next part of this class, we will complete with equation of various tangents and direct a circle, right? So this class is divided into 2 sessions. Today is our first session, which we are going to complete the intercepts by circles, power of a point, and length of tangent. And in the next part, we are going to cover equation of various tangents and direct a circle, right? So let's start by recapping our class 1 lecture. I think all of you have already seen the first video of this circle lecture. So there we have all done with different forms of circles. The first one, which was very, very popular and very important, which is your center radius form. That is, if you know the center of any circle and if you know the radius, we can find out its equation. Is it clear? Right? So what was the form? Suppose if we have a circle, let me just change the color of the pen. If we have a circle and if we know its center, let us say the center be at alpha comma beta, and let us say the radius be r. Let us say the radius be r. Then the equation of this circle will be x minus alpha whole square plus y minus beta whole square equals to r square. This is what is called your center radius form. This we have already done in our first lecture. Next is, what is your standard form? The standard form is x square plus y square is equals to r square. It means that the center of that circle is at 0, 0 and radius is r units. Okay. This is called your standard form. Next, we are coming for general equation of a circle from second degree equation. We all know that a general second degree equation looks like this. Now, this equation will represent, this general second degree equation will represent a circle when the coefficient of x square and coefficient of y square, they are same, and there is no xy containing term, that is your h will be equals to 0. Then this will represent the equation of a circle, and the equation of the circle looks like this. This is what is also called the general form of a circle, and whose center is at minus g comma minus f, and its radius is root over g square plus f square minus c. Okay. Then we are coming for concentric circles. What do you mean by concentric circles? Concentric circles are those circles whose centers are same. If the center of circles are same, only the radius differs, then we call that circles are concentric circles. Center same. So for any equation, let us say this is the equation of a circle. Now any concentric circle to this circle is, everything will remain same. Everything remains same. Only this constant term will differ. Because as we all know that concentric circles, they are having their centers equal. Center same. Only the radius differs. That is why I have added a constant lambda over here. This I have all explained in the first lecture. Then it is diametric form of circles. Diametric form of circles is that if we know the extremities of the diameter, they are x1, y1 and x2, y2, then the equation is x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equals to 0. Clear? So this is what is called your diametric form of a circle. Then the last part that we have done there is what called your parametric equation of a circle. We know that for a circle, standard circle, which is x square plus y square is a square, the parametric form is x equals to a cos theta and y is equals to a sine theta. This I have already explained. Moreover, if we are having a circle in the center radius form like this, then its parametric form will be x minus alpha is a cos theta, implies x is alpha plus a cos theta, and y minus beta is a sine theta. That implies y is equals to beta plus a sine theta. So this is the parametric equation of the circle. Is it clear now? So this we have already done in our lecture 1. Those who have not seen, they can visit the playlist and they can see that lecture. It will be, if you see that lecture before this, it will be helpful for you because I'm not going to repeat the same thing here. Okay, so let us now start with the intercepts made by circles. Intercepts made by circles. What do you mean by that? Let us say let me draw the circle first. Now, so this is a circle which is intersecting the x-axis, which is intersecting the x-axis. So what we want to find here, let us say the equation of the circle be the general equation. Okay. Now we want to find out the intercepted length. That is, we want to find out this length. What will be this length? The circle is intercept. The circle has intercepted the x-axis. Now we want to find out the length of the intercepted portion. Let us say the coordinate of this point be x1, 0 and this point be x2, 0. So basically we want to find out what is our x2 minus x1. Right? So to find out this, we should know the points. So for that, to know these points, we have to solve the equation of this circle and the x-axis. Equation of x-axis is y equals to 0. So now if I solve y equals to 0 and the equation of the circle, what we are going to have? We are going to have a quadratic equation in x. Right? So this equation, it will have two roots. One is x1, another one is x2. So your x1 plus x2, this will be minus 2g. And x1, x2 will be c, sum of two roots and product of two roots. Now we want to find out x2 minus x1. So x2 minus x1 whole square can be written as x2 plus x1 whole square minus 4 x1 x2. So let me just replace that. x1 plus x2 is minus 2g. So it will be 4g square minus 4c. So x2 minus x1 will give us 2 root over g square minus c. So the intercepted portion on the x-axis by the circle this is 2 root over g square minus c. Now similarly, if we draw the same thing when the circle is intercepting the y-axis, in that case, the intercepted portion that is this length, if this point is 0, y1 and this point is 0, y2, then this intercepted length will be 2 root over f square minus c. How I got it? Doing exactly the same way as I have done here. Here I have solved the x-axis with the curve. In this case, we will solve the y-axis with the curve. The equation of y-axis is x equals to 0. So put it and find out the distance between AB. Is it clear? The same way as I have done right now. So two things we have to remember here. That the intercepted portion on the x-axis is 2 root over g square minus c. This you have to remember. As well as the intercepted portion on the y-axis is 2 root over f square minus c. At the same time, you must know the way I am solving to get this answer. Getting my point? Because in some problems, it will be needed the method that I have done here. Okay, so the method, how I'm doing it, is also very important. Now, a very interesting thing is coming, is that we got there's a circle. Now, let us say it is intersecting the x-axis. Okay. Now we got this thing as this is, let us say, just one second. This point, let us say this is x1 comma 0 and this is x2 comma 0. Correct. So this intercepted length is what? Is basically 2 root over g square minus c. And the equation of the circle is the general form. Okay. Now, one thing you must see, that as g square minus c is under the root sign, so naturally 3 cases will come. 3 cases will come. What are they? One is when g square minus c is greater than 0, when g square minus c is equals to 0, and when g square minus c is less than 0. Is it clear? Now, when g square minus c is greater than 0, then we are confirmed that there will be an intercepted length. That is, the circle has intersected the x-axis. Okay? If g square minus c becomes 0, then what happened? The intercepted length becomes 0. It means the circle is only touching the x-axis. Try to understand it. In that case, your circle is simply touching the x-axis, or you can say the x-axis will become the tangent to the circle. When this relation holds true, when you find that your g square minus c is equals to 0. And there will be an intercepted length when g square minus c is greater than 0. But if g square minus c is less than 0, in that case what will happen? It is not going to touch the x-axis, nor it will intersect, nor it will touch. Getting my point? This is that case. Neither it is intersecting the x-axis, nor it is touching the x-axis. In that case, your g square minus c will be less than 0. Is it clear to everyone? Absolutely. Okay. So remember 3 things. When g square minus c is greater than 0, it is intersecting the x-axis. If g square minus c is equals to 0, it is touching the x-axis. That is, your x-axis becomes tangent to this circle. And if g square minus c is less than 0, it means neither it is intersecting the x-axis, nor it is touching the x-axis. Is it clear? So same thing with your y-intercept. Your y-intercept, what we have learned? It is 2 root over f square minus c. In this case also, we are getting 3 conditions. The first condition is that when f square minus c is greater than 0. What do you mean by that? It is intersecting the y-axis. It is intersecting the y-axis. Let me just draw the diagram. This is the case. Okay. In this case, what happened? The circle is intersecting the y-axis. What is the condition? The condition is f square minus c is greater than 0. Now, the second case is f square minus c is equals to 0. It means what? It is simply touching the x-axis. I'm sorry, y-axis. It is simply touching the y-axis. It is simply touching the y-axis. So what is the condition here? The condition here is f square minus c is equals to 0. And what about this? F square minus c is greater than 0. Now, the third case is when f square minus c is less than 0. It means what? It means that it is not touching the y-axis, nor it is intersecting. It is neither intersecting nor touching the y-axis. It is something like this. Is it clear? What is the condition? F square minus c is less than 0. Is it clear to all? So when f square minus c is less than 0, we will say that the circle is neither intersecting the y-axis nor it is touching the y-axis. Clear? So now a very interesting thing is that if we combine those things, we can get different forms of circle, different condition of the circle touching or intersecting the x and y axis. Like if I say that your g square minus c is greater than 0, but f square minus c is equals to 0. What do you mean by that? G square minus c is greater than 0 means it is intersecting the x-axis. F square minus c is equals to 0 means what? It is touching the y-axis. So how your circle will look like in that case? The circle will look something like this. It is intersecting the x-axis and it is touching the y-axis. Are you getting my point? So for this circle, for this condition of the circle, the conditions are g square minus c is greater than 0 and f square minus c is equals to 0. That's it. Now I can take another condition also. Let me just move this thing a little bit so that we can get space to draw. Okay. So let me just draw in this way. Now, tell me one thing. What is the condition? What is the condition that the circle is going to touch both the x and y axis? Tell me. This is very important because this is frequently needed in our problem. What will be the condition? In this case, it is touching the x-axis. It means what? G square minus c is equals to 0. At the same time, it is touching the y-axis. It means what? Your f square minus c is also equals to 0. Tell me yes or no. So these are the conditions for which the circle is going to touch the x and the y-axis. Now, I'm drawing this circle in the first quadrant. It doesn't mean that it will touch always, the circle will lie in the first quadrant. No, it can be in the second quadrant. It can be in the third quadrant. It can be in the fourth quadrant. Getting my point? But the condition is that in every time, in every case, it will be touching the x-axis as well as it is touching the y-axis. So condition is what? G square minus c is equals to 0 and f square minus c is equals to 0. So very interesting thing is that In this case, particularly in this case, if the center is at R comma R, what do you mean by that? From the origin, you move this distance R and then you move this distance R. So the radius of this circle is R, but the center can be of plus minus R comma plus minus R. Why it is so? Because as I told you right now, the circle can be in the first quadrant, it can be in the second, third or fourth quadrant. So when it is in the first quadrant, we will take the center as R comma R. When it is the second quadrant, we will take the center as minus R comma R. In the third quadrant, it will be minus R comma minus R. And in the fourth quadrant, it will be R comma minus R. That's it. Okay. And when it is touching both the axes, the radius R will be the abscissa or ordinate of the center. Because here, when it is touching both the axes, the coordinate of the center is R comma R. And in that case, your radius will be also equals to R. Is it clear to all of you? Is this clear? So it's pretty simple. Simply remember that the intercepted portion on the x-axis is 2 root over g square minus c, and on the y-axis is 2 root over f square minus c. And if g square minus c is greater than 0, it is intersecting the x-axis. If it is equals to 0, it is touching the x-axis. And if g square minus c is less than 0, it is not touching, neither intersecting the x-axis. Same thing with the y-intercept also. So simply remember this, and simply by permuting these 6 conditions, you will get different position of the circle. Okay. So I have simply summarized this thing, whatever I have said so far, that your x-intercept is 2 root over g square minus c, as I told you. Y-intercept is given. Exactly the same thing I have written. When g square minus c is greater than 0, it is intersecting the x-axis at 2 different points. When it is equals to 0, it is touching the x-axis. And when it is less than 0, there is no x-intercept. Similarly, with the y-axis, f square minus c greater than 0, touching at 2 different points. Equals to 0, touching the y-axis means your y-axis now becomes tangent to the circle. And f square minus c is less than 0, there is non-real y-intercept. Okay, so all of you, I'm telling you, after the class, you can download this class PDF from the link given in the description box. Okay, so now, very important note. When the circle touches the x-axis, now tell me one thing. The equation of the circle for all these 3 cases, I am taking this one, the general equation. The general form I have taken. Now, what is its radius? Its radius is root over of g square plus f square minus c. Now, for this condition, for this case, it is, the circle is simply touching the x-axis. It means what? Your g square minus c is equals to 0 implies your g square is equals to c. So what will be its radius? What will be its radius? Radius is root over g square plus f square minus c. So g square minus c is 0, so it becomes root over of f square. And that gives us nothing but mod of f. Is it clear? So for the circle which is touching the x-axis, your radius is modulus of f. Clear? When the circle is touching the y-axis, then your f square minus c, this is the condition, just now we have learned. F square minus c will be equals to 0. So in that case, what will be your radius? Root over of g square plus f square minus c, but f square minus c is 0, that gives us root over of g square, and which gives us nothing but mod of g. Is it clear? So we got mod of g is the radius of the circle when it is touching the y-axis. In all these cases, your center is minus g comma minus f. In all these cases, the center is at minus g comma minus f. Now, in this case, what happens? In this case, what happens? In the third case, when it is touching both the x and y axis, in that case, we have g square is equals to c. At the same time, f square equals to c. Tell me yes or no. So what will be its radius? Its radius will be root over of g square plus f square minus c. So if I take g square equals to c, we are getting the radius is root over of f square, which gives us mod of f. And if we take f square equals to c, then we are getting our radius as root over of f square minus c is 0. So it is coming to root over of g square, which gives us mod of g. Therefore, your mod of g and mod of a, they are all same. Is it clear? That is, the center will be what? It will be minus g comma minus g, or you can write this thing as minus f comma minus f. They are all same. Is it clear? So if we consider for our simplicity, let us say this is nothing but our R. So the center will be, it can be in the first, this condition is satisfied when the circle is in the first, second, third or fourth quadrant. I have already mentioned this. Therefore, your center will be, if this is equals to R, then your center will be plus minus R, comma plus minus R. Because according to the position of the circle, whether it is in the first, second, third or fourth, we will take the center accordingly. Getting my point? But in all these cases, for the third one, your mod G and mod F, they are always same, which is equals to R. That is the radius of the circle. Is it clear? So these three things we have to remember. When the circle is touching the x-axis, your radius will be mod F. When the circle is touching the y-axis, your radius is mod G. And when the circle is touching both the axes, in that case, your mod G, mod F will be same as your R, and the center is plus minus R, comma plus minus R, according to the position of the circle. If it is in the first quadrant, we will choose the center accordingly. If it is in the second, third, and fourth quadrant. Is it clear to all? Absolutely. Okay. So now let me take some problems based on that. Let us start with this first problem. The question is, find the equation of the circle touching the coordinate axis. Touching the coordinate axis. Axis. At a distance of 2 units from the origin. At a distance of 2 units from the origin. So let me just draw the diagram. So this is my circle. This is the coordinate axis. Now, the circle will be, it is touching both the coordinate axis. It is touching both the coordinate axis. Just 1 second. It is touching both the coordinate axis. So it will be something like this. Okay. And what they have said is that it is touching at a distance of 2 units from the origin. That is, this distance is 2 units. Okay. I have taken this circle in the first quadrant. It can be in the second, third, or fourth quadrant also. So your center will be what? When it is touching both the axes and the distance from the origin to the point of contact with the x-axis is 2, it is given in the question. So your center will be nothing but 2, 2. Am I correct? Your center will be nothing but 2, 2, and the radius will be 2 only. Your radius is 2 and center will be, as it can be in the first, second, third or fourth quadrant. So we can write the center will be at plus minus 2, plus minus 2. Therefore, what will be the equation of the circle? It will be x. I am simply using center radius form. Plus y plus minus 2 whole square is your 2 square. Therefore, the equation of the circle will be equals to 4. So how many such circles are possible which are touching both the axis and at a distance of 2 units from the origin? Such circles will be 4. 4 circles are there which will fulfill the given condition in the question. Is it clear? Therefore, our equation is x plus 2 whole square plus y plus minus 2 whole square equals to 2 square. Is it clear to all? Okay. Let us move further. These questions I have selected only because to understand the theory properly. These are pretty simple sums, but these sums will help us to know the theory better. See this question. Find the equation of the circle which touches the positive y-axis. Let me draw the diagram first. Find the equation of the circle which touches the positive y-axis. Okay, positive y-axis. So it is touching the positive y-axis. Okay, fine. So it is touching the positive y-axis at a distance of 4 units from the origin. That is, this distance is 4. This distance is 4. Okay? Okay. So this distance is 4 from the origin and makes an intercept of 6 units. Oh, acha, acha, acha. And makes an intercept of length 6 on the x-axis. It makes an intercept of 6 in the x-axis. Okay, so this distance is not your 4. The distance will be this one. So this distance are 4. Just 1 second. So this distance is 4. And this length is 6. Is it clear? Is this clear to all? Now we have to find out the equation of the circle. So what to do? See, what will be the center? Because one thing you all must remember, that for every time, as I told you many times, that for a circle, we are only concerned about 2 things. Its center, its radius. That's it. So what I will do, let us say this is the center. The center is, let us say, alpha comma beta. Is it clear? Now, can you please tell me what is your beta? Here your beta will be nothing but 4. Why? Because this length is 4 which is given to us. Is it clear? This length is 4 which is given to us. Now, from the center, so what will be the center? The center is basically lambda comma 4. Yes, it is lambda comma 4. Okay. Now, from the center, if we draw a perpendicular on the x-axis, it will definitely bisect the chord. This we all know. So this length is basically what? 3. Now let me join this point with the center. Let me join this point with the center. This is what? This is my radius. But I don't know the radius. Let us say this length is r. Now, if this length is r, from this triangle, from this right angle triangle, we can say that r square equals to 3 square plus 4 square. It means what? Your r is coming to root over of 25, which gives us 5. That is, the radius of this, okay, which this question meaning, see, the question is, find the equation of the circle which touches the positive y-axis at a distance of 4 units from the origin. A circle is touching the y-axis at a distance of 4 units from the origin. Okay, so this length is basically 4. And they have said that it makes an intercept of length 6 on the x-axis. That is, this length is 6. This length is 6. Okay. So from here we got the radius r as 5. Clear? Means this is also the radius. This length is 5. Then can you please tell me what will be its center in that case? Your center alpha means this distance which is same as your 5. Therefore, your center becomes what? Your center becomes 5, 4. Is this conception clear to all? Is this conception clear to all? Since the radius is 5 units, that is this distance is 5. So the center will be, this is 5, this length is 5, and this length is 4. So the center is 5, 4. Okay. Now this circle, the condition that they have given, it can take two places. Either it is in the first quadrant or it can be in the second quadrant. It cannot be in the third or fourth quadrant. Otherwise, this positive y, when the circle touches the positive y-axis, it will not happen. If it is in the third or fourth quadrant, the circle is going to touch the y-axis in the negative direction. Therefore, we will not consider the circle in the third or fourth quadrant. Therefore, your center, as the circle can be either in the first or in the second quadrant, therefore its center will be plus minus 5, 4. Either it is in the first quadrant. When it is in the first quadrant, the center is 5, 4. When it is in the second quadrant, the center will be minus 5, 4. Thus, the equation of the circle will become, again, the radius, center radius form I am doing, plus y square, sorry, y minus 4. So y minus 4 square, which is equals to the radius, and the radius here is 5, which is 5 square. So what is the equation? X square plus minus 10x plus 25. I'm simply opening the brackets. This goes off. So it is x square plus y square plus minus 10x minus 8y plus 16 equals to 0. That's it. So that will be the equation of the circle. Why plus minus sign is coming? Because there are two such possible circles, either in the first quadrant or in the second quadrant. It cannot be in the third or fourth quadrant. The reason I have already explained. Okay, so our answer is this. So I hope you have all understood. If you have not, please do write in the comment section so that I can get back to you. Okay, let us move for the next problem. See this question. The question says, find the locus of the center of a circle touching the x-axis and passing through the point 4, 6. Touching the x-axis. Okay. Let me just draw the circle first. It is touching the x-axis. So the circle will be something like this. It is touching the x-axis. Fine. Then, and passing to the point 4, 6. So there is a point 4, 6. The circle is passing through this point. So find out the locus of the center of the circle. So we have to find out the locus of this point. Let us say the locus of this point be h, k. Is it clear? Let h, k be any point on the locus. Is it clear? Let h comma k be any point on the locus. And we are finding out the locus of the center of this circle, which is touching the x-axis. Now, see, if a circle is touching the x-axis, what will be its radius? From the center, if I join the point of contact, this is called point of contact. What do you mean by point of contact? The circle, if we are having a tangent to a particular point on the circle, we call that point as a point of contact. So if we join this point to this point, the center, so this length is basically k, and which is nothing but the radius of the circle. Radius of the circle, which is your k. Or we can remember in this way also, we know that when a circle is touching the x-axis, the radius is always mod of f. Is it clear? So in this case, your radius is nothing but k. So we got radius as k? Yes. Now I have to find out the locus of the center. It means I have to find out a relation which will contain h, k and any other constants, right? So how to find out that condition? What I will do, I will simply join the center with this point, right? Now, if you join the center with this point, what is its distance? Its distance is, okay? And this distance is nothing but its radius. This is nothing but its radius, which is nothing but k. So if I open the bracket, if I square both sides, squaring both sides, so this is a relation which contains your h, k and constant. So this is the equation of the locus. So what is the equation of the locus? It is x minus 4 whole square, y minus 6 whole square is your y square. So simply open the brackets. Y square goes off. So we are left with x square minus 8x minus 12y 52 equals to 0. That's it. So this is the equation. This is the equation of the required locus of the center of the circle. Is it clear to all? Absolutely. Okay. So let us move for the next problem. See this question. The question states that a circle is drawn to cut a chord of length 2a units along the x-axis and to touch the y-axis. Simple sum. So again, find the locus of the center. Let me just draw the diagram first. So what is happening? A circle is drawn to cut the chord of length 2a units along x-axis and touch the y-axis. That is, your circle will look something like this. Is it clear? Now you have to find out the locus of its center. This length is 2a. Okay? So let me do one thing. From this center, let me draw a perpendicular on the x-axis. If I draw a perpendicular on the x-axis, what will happen? What will happen? It is going to bisect the base. That is, this length will be your A, this length will be also your A. Is it clear? Now, let me join this point with the center, right? So what will be its radius? What will be its radius? Let us say the radius be R. The radius be R. Okay? So if the radius is R, what will be this length? This is also the radius of the circle. So this is also your R. Yes or no? Tell me yes or no. Okay? So, how to find out the equation of the locus? But if I take R, I have to find out the locus of the center. So let me take H comma K be any point on the locus. Let me take H comma K be any point on the locus. Then we cannot take this thing as R. Okay. Why I'm telling you? Because as we have taken HKB and this length is H. And if this length is H, means this length is also H. Right? And this is nothing but the radius of the circle. Therefore, radius of the circle is nothing but H. Okay? And this perpendicular distance is K. So I have to find out the locus of this center. So I have to find out a relation which contains HK and the constant. In the constant in this case is A, which is given in the question. So by taking this right angle triangle, I am applying Pythagoras theorem. So we can say K square plus A square is nothing but H square. Yes. So we are getting H square minus K square is equals to A square. Therefore, the equation of the locus is what? X square minus Y square equals to A square. That's it. As simple as that. Hence, option B is correct. Is it clear? Is this clear to all? Simple thing. Always, whenever it is intersecting the x-axis, you always draw a perpendicular from the center on the x-axis, and it will bisect the intercepted portion. Apply the Pythagoras theorem to solve it. As simple as that. And always remember that if it is touching the y-axis, then, and it is intersecting the x-axis, so in that case, the center will be, if this distance is h, then the center will be h comma k. K is the length where it is intersecting, it is touching the y-axis. K is the distance from the origin where it is, the circle is touching the y-axis. Simply apply this and get your answer. Okay? Chalo. So let us move for another problem. See this question, which came in JEE Mains 2022. It has been said that if the circle is given x square plus y square, the circle is given okay, C belongs to any real value, passes through the point 6, 1. That is, this circle is passing through the point 6, 1, and its center lies on the line x minus 2c y equals to 8. Your center is lying somewhere here on this line. Then the length of intercept made by the circle on the x-axis, that you have to find out. Let me draw the diagram first. Okay. And now the circle passes through the point 6, 1. It's okay. And its center lies on this line. Then the length of the intercepted made by the circle on the x-axis. Clear? Now the center, okay, even if I don't draw, I can do it. The center lies on this. First of all, what is the center of this circle? What is the center of this circle? It is G, comma, minus 3. Okay, this is the center. And they have said that this center is lying on this line. The center is lying on this line. Hence, it must satisfy this equation. So, G 6C equals to 8. This is the first equation that we got. Is it clear to all? This is the first equation we got. And they have already said that it is passing through the point. Which one? The circle is passing through the point 6, 1. Because you observe one thing, only two unknowns are there. One is G and another one is C. So I need two equations to solve for G and C. Is it clear? And then the moment we find that, we can easily find out the length of intercept made by the circle on the x-axis, because we all know that the intercept portion on the x-axis is basically 2 root over G square minus C. That's it. So we will simply apply that formula. So first of all, we have to find out G and C. One equation we got, we need another equation. And for that, they have said that this circle is passing to the point 6, 1. So let me just satisfy that. So we are getting what? It's 12G plus 19C equals to 43, right? So now we have to solve this equation and this equation to get the values of G and C. So let me multiply this equation with 12. So we are having 12G, 72C, 96. So let me subtract. So 72 minus 19, that will give us 53. C equals to 96 minus 43, that will give us minus 53. So we are having C as 1. We are getting C as 1, right? Now, what about G? If I put it here, we are going to have G equals to 8 minus 6C, which gives us 8 minus 6, that is 2. Okay, so G is nothing but 2. We got that. Now see, maximum students will do this mistake. Maximum students. That is why this question has been selected in JEE Mains. What student you will do, हड़बड़ी में क्या करेगा, वो देखेगा कि पहले मुझे C मिल गया and I got my G. Therefore, the intercepted length will be 2 root over G square minus C. So that will give us 2 root 3. And they will mark this. This is absolutely wrong. That will be absolutely wrong. Why it is absolutely wrong? Because we know that the intercepted on the x-axis is 2 root over G square minus C. But this C is basically coming from where? From this general equation of the circle. Look it carefully. What is C? Only C is there. But in our question, the C is not only C. It's minus 19C. Getting my point? So here our C is basically minus 19 of C. That you have to understand. If in the rush, if you write C as 1, you are going to get the wrong answer. This is absolutely wrong answer. So the answer will be 2 root over G square plus 19. That gives us 2 root 23. Getting my point? That will be your answer. The answer is not your B. So option D is correct. Try to understand the logic. That is why I told you that whenever you are memorizing any formula, know the form from where it is coming. Know the form from where it is coming. Otherwise, it will be difficult for us to solve it. We will solve it, but we will get a wrong answer. Okay, here C is not, here C is actually from the, it is coming from the general form of the straight line, I am sorry, circle, and that C is only C. But in our problem, the C is minus 19C. So we have to use that one only. Is it clear? Okay. So let us move for another problem. See this question. What is the question? A variable circle, a circle is a variable, passes through a fixed point P comma Q. You see, there can be lot of circles which are passing through a fixed point. The circle can be this. The circle can be this also because it is passing through this point. The circle can be this also because it is passing through this point, or say, let us say this point. So, see, this is that point through which infinite number of circles can pass. Infinite number of circles can pass, right? Now, they have given that this point, let me remove this. So, this is that circle which is passing to that fixed point. This is that circle which is passing to that fixed point P comma Q. Okay. Now, it's a variable circle, as I just now I have shown you. Now, they have said, and is tangent to the x-axis, and it is tangent to the x-axis. That is, it is touching the x-axis. Okay. And this point y, it has not been said where it is. So let us just assume this is my y-axis. Now it is touching the x-axis. Okay, fine. Then what they have said? Prove that the point diametrically opposite to A, that is, the point which is diametrically opposite to A, that is, it is passing through the center. It is passing through the center, right? This is diametrically opposite end. Okay. So we have to show that this point, let us say this point be B, that this point is lying on this curve. That is, actually we have to find out the locus of point B. We have to find out the locus of point B. And we will show that the locus of point B is nothing but this one. Is it clear? That we will show. So let us say H comma K be any point on the locus. Okay. So what will be its center? Its center will be H plus P by 2, K plus Q by 2. Correct? That is, this, if I join this point with this point of contact, then this distance is nothing but K plus Q by 2. And which is nothing but our radius. Tell me yes or no. It's the radius. Okay. Now, what is the length of AB? It's root over. This is AB, which is nothing but our diameter. This is our diameter. So what will be the radius? The radius is half of AB. So which gives us half of root over h minus p square plus k minus q square. Now by the problem, half root over, this is nothing but your radius, and radius is nothing but, the length of radius is nothing but k plus q by 2. Is it clear? 2 goes off. Now square both sides. Now you see, this is an equation which contains h, k and the constants given. Here the constant is p and q because that's a fixed point. So this will be the equation of the locus. Equation of the locus. Of locus of which point? Of the point B. Okay. So what is the equation of the locus? X minus p whole square equals to y plus q whole square minus y minus q whole square. So simply apply the formula a square minus b square. So you are getting a plus b, a minus b. So we are having x minus p whole square equals to 2y into 2q. So that gives us x minus p whole square is 4qy. Is it clear? So this is the equation of the locus. Locus of which point? Point B. What is point B? It is simply diametrically opposite to the point A. Hence proved. Is it clear now? Absolutely. Okay. So let us move for another problem. So this question came in JEE Advanced 2017. What is the question? For how many values of P? Now, IIT Advanced, they never used to give problems straight away. They will definitely give you problem mixed with something, or they will select problems in such a way that it will be the reverse of the conventional thing. It will be always the reverse of the conventional thing, like this. So far, whatever sums we have done, we are all dealing with this constant term of the general equation of a circle. Now they have said how many such P's are possible. Getting my point? That's your advance. So for how many values of P, the circle, this one, and the coordinate axis have exactly 3 common points. Exactly 3 common points. Now, what are the ways? What are the ways? Let me try to draw the figures first. The first option can be in this. The circle is intersecting the x-axis but touching the y-axis. One option can be this. Because in this case, we are getting that this circle whose center is at -1, -2, though I am taking it in the first quadrant, don't be confused with that, because -1, -2 is basically in the third quadrant. We are going to have the same thing over there. Only thing is that the coordinate of the center will get changed, nothing else. So I'm taking like this point to be -1, -2. Don't treat this thing as your first quadrant. I'm simply drawing a rough diagram to prove it. So now, in this case, when the circle is intersecting the x-axis at 2 points and it is touching the y-axis at only 1 point, this can be one case. Here, exactly there are 3 common points between the coordinate axis and the circle. Yes or no? Yes. What can be the other cases? What can be the other cases? The same thing can be done with the y-axis also. The same thing can be done with the y-axis also. Isn't it so? Now it is intersecting the y-axis at 2 points and touching the x-axis. In this case also we are getting exactly 3 common points. Am I correct? Is there any other possibilities where the circle and the coordinate axis will have exactly 3 points, common points? Is there any other possibility? Please do comment me immediately. Is there any other possibilities? Yes, there is another possibility. What is that? When the circle, like this, when the circle is passing through the center and intersecting the x and y axis in this way. In this case also, if you observe, you will see that there are exactly 3 common points between the circle and the coordinate axis. So these are the 3 cases which are possible. Now again, jaldibaji mein answer mat likho ki your p will be equals to 3. No, because there are 3 cases. So there will be 3 different values of p. Therefore your answer will be 3. No, because we have to check whether it is satisfying the given condition or not. That is very important. In this case, when it is intersecting the x-axis and touching the y-axis, in that case, what is the condition? The condition is g square minus c. Can you remember? G square minus c, it has to be greater than 0. And, not or, and f square minus c, it will be equals to 0. In this case, g square minus c is equals to 0 and f square minus c is greater than 0. And for the third case, your g square minus c is greater than 0. At the same time, your f square minus c, it will be also greater than 0 as it is intersecting the x as well as y axis. Clear? Now let us see whether this equation is satisfied, these conditions are satisfied or not in the given circle. In the circle we are having, I'm writing it here, in the circle we are having, this is at your center where your G is basically 1, F is basically 2 and C is basically minus of P. Okay. So what is this condition? G square minus C is greater than 0. G square minus C is greater than 0. What does it say? It says 1 square plus P is greater than 0 implies your P is greater than minus 1. And F square minus C is equals to 0. It means 2 square minus of minus P equals to 0. That implies your P is equals to 4. I'm sorry, P equals to minus 4. P equals to minus 4. Yes or no? Yes or no? Because here we are getting P plus 4 equals to 0. So P is coming to minus 4. Is it clear? So this condition, both these conditions are to satisfy. But if you observe, you will find that as P should take a value more than minus 1, it is not going to satisfy minus 4. So this condition is not possible. Is it clear? Now let us check whether the second condition fulfills or not. So now you think, initially, if you have written the total number of values of P will be 3, then you will be wrong. You can understand why it is so. Because it is not satisfying the first condition. That is why you should be very careful while solving JEE advanced questions. G square minus C is equals to 0. It means what? 1 minus of minus P equals to 0 implies your P equals to minus 1. And f square minus C is equals to greater than 0, it means what? F square is 4, C is this, greater than 0. So from here we are getting P is greater than minus 4. Is it satisfying this? Is it satisfying this? P is taking minus 1 and P should be greater than minus 4. Yes, it is satisfying. Therefore, we got one value of P as minus 1 for which the given condition in the question will satisfy. Right? Now let us check the third case. This and this. G square minus C is greater than 0. Now, look it carefully. So, it is 1 is greater than 0. That implies what? P is greater than minus 1. From the second one, what we are getting? F square minus C is greater than 0. That gives us P is greater than minus 4. Right? So P is greater than minus 1, P is greater than minus 4. So combining these two, we will say that P is greater than minus 1. Right? So now the question comes. People will be confused here also. Now he will say, sir, P is greater than minus 1. It means P can take infinite values. So is infinite number of circles are possible? That's the big question. P is greater than minus 1 means P can take infinite values, which are all more than minus 1. So does it mean that we are going to have infinite number of circles? No. You should be very careful about one thing. As the circle is passing through the origin, so origin must satisfy this equation. Not all values of P is going to satisfy this origin. So we are not going to have infinite number of values of P. No. So as your origin is satisfying this equation, so we are getting P equals to 0 only. We are going to get P equals to 0 only. That's the only thing that we are getting. And P equals to 0 is satisfying this condition. Hence, the second value of P that we are going to have is 0. So there are only two possible values of P. That is, for the given condition in the question, there are two such possible circles are there. Is it clear to all? Therefore, the required values of how many values of P? There will be two values of P which is going to satisfy our given case. Is it clear to all of you? Absolutely? Okay. Now let me take another problem, which is this one. What they have said? They have said that there are two circles in the first quadrant of radii R1 and R2 touch the coordinate axis. It is touching both the coordinate axis. Each of them cuts and intercepts of 2 units with the line x plus y equals to 2. Now you see, both these circles are doing the same thing. They are touching the coordinate axis as well as it is cutting and intercepts of 2 units with the line x plus y equals to 2. So in this case, don't try to do the problem by taking both the circles. That will completely mess up. I mean, the solution will be messed up. So all you do is, you simply, as we can see that both the circles are doing the same thing, we will treat this thing as they are symmetric circles. So whenever you get some symmetric circles, You consider only one case and automatically that two circles in our case will come. So don't worry about it. You only take one case and solve. You will definitely going to get two options for this one. Okay. So let me take the circle which is touching both the coordinate axis which are touching both the coordinate axis like this. Okay. And there is a line. There is a line which is our, let us say, x plus y equals to 2. Right? This is our x plus y equals to 2. Is it clear? So two circles are in the first quadrant. So naturally, I will take the center to be r comma r. Let us say we are taking the center as r comma r. That is, this length is r, right? Even if we, this is actually the radius of the circle, which is same as r. If I join this center with this point, this will be also equals to r, because as it is the radius of the circle. Yes, this is also r. Now let me draw a perpendicular from the center on this line. So what is the perpendicular length? Let me give a name. This is my A, this is B, let us say. So what is the length of AB? What is the perpendicular length drawn from r comma r on the line x plus y equals to 2? It will be, this is our AB, which gives us, so we are basically having root 2 mod r minus 1. Is it clear? This is the length AB. Now, let us set this point BC. Now, in the triangle ABC, what you are getting? I am applying the Pythagoras theorem because this is your 90 degree. So, if I use the Pythagoras theorem, what you will get? You are going to get AB square plus BC square equals to AC square. Now, observe one thing. This distance, they have already given in the question that this distance is 2 units. So when we drop a perpendicular from the origin on this line, so your BC length will be 1. Okay, BC length will be 1. So AB square, which is your 2r minus 1 whole square plus BC square is 1 square, and AC is nothing but your the radius, which is your r square. Right? So now if we open the brackets, we are going to have, so it's 2r square minus 4r plus 3 minus r square is 0. Now, can you observe one thing? As I told you in the beginning of the question, that there is no need to do this sum by taking the two radius, the two circles. As their symmetry, you will do by taking only one circle, automatically two circles will come. You can see it from this quadratic equation. As this is a quadratic equation in R, so definitely you are going to have two values of R. That is, you are getting two such circles. You are getting two such circles. Is it clear? One on this side and another one will be in the other side. Okay, this side. I cannot draw it right now because here there is a limitation of the space. So from here, we are going to have the two roots as R1 plus R1 and R2. So from here, we can write R1 plus R2 is 4, sum of the two roots, and product of the two roots is 3. Is it clear? So now we have to find out the value of this. So it's easy to solve. 2R1 R2 minus R1 R2. So we are basically getting R1 plus R2 whole square minus 3R1 R2. So simply put the values. So it's 4 square minus 3 into 3. So it's coming to 16 minus 9. That gives us 7. Is it clear? Therefore, the value of the given expression is nothing but 7. But have you understood this problem? The most important part of this problem is that whenever you find that symmetry is there, you don't consider all the figures and do. No, you only consider one figure, not only in circle, but throughout the whole conic section. If you find that the symmetry is there, you always take one figure and solve the problem. You are definitely going to get the other curves also. Okay, if you have 3 such curves, you will definitely get a cubic equation. If you have 2 curves, you are going to have a quadratic equation. So don't worry about it. That will come automatically. All you think is symmetric equation, start with only one figure. That's it. Okay, so we have done a lot of sums. So let us just move for the next conception, which is your maximum and minimum distance of a point from a circle. Okay, there is a circle and we have to find out. There is a circle and we have to find out the maximum and minimum distance of a point from a circle. Now, the point with respect to the circle can be in 3 places. Either the point is inside the circle, or it is outside the circle, or it can be on the circle. These are the only 3 cases possible for this point to lie with respect to this given circle. Is it clear to all? Okay. So here I have considered 3 cases. The first case is that I have considered that the point P is inside the circle. Now we have to find out what is the maximum and minimum distance of this point from this circle. From this circle. Now, directly from this figure, we can see, let me just delete all those. So we will get space to write. Okay. So now, for this first case, when the point is inside, what is the minimum distance? Tell me. The minimum distance is AP. And what is the maximum distance of point P from the circle? It is PB. Is it clear? Now, how to find AP? How to find AP in this case? Your AP is basically radius, or we can write this thing in this way. First, let us write in this way. We are finding out the distance AP. So we are doing in this way, CA minus PC. CA minus PC will give you AP. And PB will give you your PC plus PC plus CB. Is it clear? C is the center of this circle. Is this clear? So from the first one we can write CA is what? It is the radius. So radius minus PC is the minimum distance when the point P is inside the circle. And the maximum distance is PC. and CB is nothing but the radius, so it is PC plus the radius. Is it clear? So to find out the minimum value, you have to simply do radius minus PC. What is PC? P is the given point and C is the center of the circle. And for maximum value, you are simply doing PC plus CB, that is PC plus the radius. Right? This is when the point is inside the circle. Now, let us consider case 2, where the point P is outside the circle. If point P is outside the circle, what is the minimum distance of point P from the circle? It is again your AP, which is nothing but your, how to find AP? It is nothing but PC minus AC. That is PC minus AC is the radius. So it is the radius. And what is the maximum distance? Your maximum distance is PB. And what is PB? How you get that? It's PC plus CB. And what is your PC is there? What is CB? CB is the radius. So have you observed one thing in these two cases? Your maximum value of the point, whether it is inside or outside, the maximum distance we are always getting PC plus radius. C is the center and P is the given point. Okay, so that is the maximum distance. In both the cases, we got the same answer. Yes, for the minimum, it is different. We will come to the conclusion after the third case. What is our third case? First case, we have considered that the point P is inside the circle. Second case, we have considered point P is outside the circle. So now we are left with the third case where your point P is on the circle. So what is the minimum distance? Tell me, what is the minimum distance of point P from the circle? It is 0. Because point P is very much on the circle. So the minimum distance is 0. And what is its maximum distance? Its maximum distance is PC plus CB, which is your actually PB. That is the maximum distance. So which is nothing but, PB is nothing but PC plus CB is the radius. So it's the radius. Is it clear? So now the first conclusion that we are coming, that whenever we are finding out the maximum value, that is the maximum distance of point P with respect to the circle, it is always PC plus the radius. C, again I'm mentioning, C is the center. C is the center of the circle. And P is the given point. Okay, so maximum distance is PC plus its radius, irrespective of the position of P, whether it is outside or inside or on, because in the outside, we got the same answer. In case of inside, when the point is inside the circle, we got the maximum value as same, PC plus radius. Yes or no? In the third case also, we got PC plus radius. So maximum distance of the point from the circle is always PC plus radius. But for the minimum value, in this case, it is coming to 0. And for the previous two cases, one is coming radius minus PC, and another one is coming PC minus radius. So can we combine all these three to write the minimum distance will be always PC minus radius? Modulus of PC minus radius. If it is inside, PC minus radius will give us negative value. Doesn't matter. We are always going, here we are getting PC minus radius. So either this value will be negative or positive. PC minus radius, in this case we are getting a negative value. No problem. The distance will be always positive. Getting my point? the distance, the minimum distance will be always positive. Whether it is radius minus PC or PC minus radius, doesn't matter. You have to take the modulus sign because distance cannot be negative. So whenever the question comes, a point is given and the circle is given, you have to find out the minimum and maximum distance. For minimum distance, you will always find out modulus of PC minus radius, irrespective of the position. Whether the point P is inside, outside, or on the circle, it doesn't matter to you. You are always going to have the value modulus of PC minus radius. And for the maximum value, I mean the maximum distance will be PC plus radius. It will be PC plus radius. Please do remember this too. Okay? So now let's move for a problem. See this question. The question is find the points on the circle, this. So there is a circle. There is a circle. And the center of the circle is where? Which is our C is nothing but 1, minus 2. Okay. And the point given minus 5, 6. Now, first question is, you don't need to find out, still I will find out, but here you don't need to find out the position of the circle. I mean the position of the point with respect to the circle. Because as we have seen there, for finding out the distance, you don't need to find out where the point P lies, outside, inside, or on, because our answer is irrespective of the position of point P. Okay, that is why I've generalized it. But sorry, in this case, we have to find out its position because we have to find out the points on the circle, right? So how to find out the position of this point with respect to this circle? All you simply do, in this circle, you put this point. In this expression, you simply put the point minus 5, 6. So if I put what we are going to have, 25 plus 36 plus 10 plus 24 minus 20. So I'm not calculating this. This is definitely greater than 0. Now, if this is greater than 0, it means the point is outside the circle. The point is outside the circle. Okay? Now, I have to find out. See the question very carefully. I have to find out, if I join this, now we can easily understand that if this is A and this is B, we can easily understand that our minimum length is PA and maximum length is PB. Yes or no? But we are not concerned about the distance because we have to find out the coordinates of A and B. We have to find out the coordinates of A and B. How to do it? Okay, let us do one thing. Let us find out what is my PC. PC is the distance between the point and the center of the circle. That is 516 square plus 8 square. So it is going to have 36 plus 64. That gives us root 100. That is 10, right? So the distance PC is 10. So this distance is how much? This distance is 10. Now, what is the radius of the circle? What is the radius of the circle? The radius of the circle is root over G square plus F square minus C. So we are having this is as 25. So that is 5. Is it clear? So radius is 5. So can you please tell me what is the minimum distance? Minimum distance PA. What I told you. Minimum distance is modulus of PC minus radius. So what is that distance? PC is your 10 minus 5. That gives us 5. So this distance is nothing but 5. And what is the maximum distance? Maximum distance is PB, which is nothing but PC plus radius. So that gives us PC is 10 and radius is 5. So that gives us 15. So this distance is 15. Okay, but we don't need this. What we need is basically the coordinates of point A and B. Now here we can find out the coordinates A in different ways. But the easiest way, which I feel, is that you can use parametric also. You can get the answer. But here we are getting that your PC is 10. That is given. We have seen that PC is 10. And the radius is 5. So this distance is also 5. And this PA, this distance is also 5. So I can say that A is which is the nearest point, that A is the midpoint of P and C. Therefore, the coordinate of A will be -5 plus 1 by 2. I'm using the midpoint formula. So we are getting -2, 2. Therefore, the nearest point A is nothing but -2, 2. Is it clear? Now, we know A, we know C. So we can easily find out what is the coordinate of B. Because again, C is the midpoint of AB, as C is the center and AB is the diameter. So C is the center of AB. So this length is also 5. So now we can find out what is my B. How to find out that? We all know a shortcut form. Let me just tell you, because this you have to remember. If let us say this is alpha, this is beta, this is A comma B, and we have to find out this coordinate. If this is the midpoint, always remember your X will be 2A minus alpha and Y will be 2B minus beta. This is the shortcut way of remembering, of doing the sum quickly. Okay, otherwise you have to take this thing as XY and then apply the midpoint formula and solve for X and Y. So I'm not doing that. I'm simply applying that formula. So your coordinates of B will be 2 times the center abscissa 2 minus alpha. That is, okay, comma, 2 times -2 minus 2. So your answer will be 2 plus 4. And this is -4 minus 2. So it is coming like 6 comma minus 6. Is it clear? Therefore, your coordinate B will be 6 comma minus 6. Right? Therefore, the nearest point is -2 comma 2. Nearest point is -2 comma 2. And the furthest point is 6 comma. Oh, why I'm getting 4? Have I done something? Yes. I'm doing a wrong thing here. There is a calculation mistake. This is actually 2 plus 2. Isn't it so? There's a silly mistake. So this is basically 4 comma minus 6, right? This is 4 comma minus 6. So the farthest point is what? 4 comma minus 6. Have you got the answer? Is it clear to you? So we can find out the nearest as well as we can find out the farthest point also. Before that, we have learned how to find out the minimum and maximum distance. Now we got how to find out the coordinates of that shortest and the farthest point with respect to the circle. Okay, so we have learned this. Now let us come to a new conception, which is our position of a point with respect to a circle. This we have already discussed. Suppose there is a circle. Now there is a point. Let us say the point is x1 comma y1. Okay. Now this point can be either outside the circle or on the circle or inside the circle. So how do you know that this point is whether outside, on or inside the circle? So for that, what I will do, in the given equation of the circle, the given equation is the general form, which is already written there. In that general form, you simply put, in this expression, you simply put this x1, y1, which I have denoted by S1. Throughout the coordinate geometry, I am going to use this notation. Please do remember, S1 means in the given curve, I have put the point. Now, if you find that your S1 is greater than 0, you will say the point x1, y1 is outside the circle. If it is equals to 0, you will say that this point is on the circle. And if it is less than 0, you will say this point is inside the circle. Is it clear? Okay. So please do remember this notation. S1 means in the given curve, I am putting the point given. That is your S1. Throughout your coordinate geometry, I will use this. I am doing circle. Here I am writing S1 as putting x1, y1 in the circle equation. When I will do parabola, I will use x1, y1. I will put x1, y1 in the given equation to get S1. So S1 is the notation I am going to use throughout your coordinate geometry. So please do remember what is S1. What is S1? Simply putting the point in the given curve. That's it. So now we have understood that how to find out the position of a point with respect to a circle. Okay. Now, let us take this problem. The question is, the circle, this one, this is given, does not touch or intersect the coordinate axis. Does not touch or intersect. Can you remember? For a circle, this, the center is minus g minus f. And when it is not touching or intersecting the coordinate axis, then your g square minus c is greater than 0 and f square minus c is greater than 0. These are the two conditions in which the circle is not going to touch nor intersect the coordinate axis. Okay, here your g is minus 3 and your f is minus 5 and your c is lambda. Am I correct? Okay. And they have said that the point 1, 4, it lies inside the circle. What do you mean by that? If I put this point, that is, if we find out S1, what is our S1? 1, 16, minus 6, minus 40, plus lambda. This is your S1. Just 1 second. So since this point is inside the circle, so what we will write? We will write this is less than 0. So what you are getting basically? This is coming like 17 minus 6 is 11 minus 40 plus lambda is less than 0. So your lambda is less than 40 minus 11. That gives us 29, right? So lambda is less than 29. Lambda is less than 29. This is the first case we got. Now there are two other conditions. One is 9 minus lambda is greater than 0, implies lambda is less than 9. And from here, from the second one, we are getting your f square, that is 25 minus lambda. This is greater than 0. So that implies lambda is less than 25. Is it clear? Have I done everything correctly? Please check it. Lambda is less than 9, lambda is less than 25, lambda is less than 29. Is it clear? Please check this one. Please check it. Yes, I think I have done all correctly. Oh, I'm sorry. I'm sorry. Oh my God. I have done one major mistake. They are saying that it is not touching or intersecting the coordinate axis. That is, this is not your, I'm so sorry. This is actually, when it is not touching the x-axis, what will happen? What will be the condition? The condition will be, very sorry, g square minus c is less than 0 and f square minus c is less than 0. Can you remember that? Let me just refer to that slide. See this one. When it is not touching, when it is not intersecting or touching the x-axis, then your g square minus c is less than 0. And when it is not touching or intersecting the y-axis, f square minus c is less than 0. Right? So in this case, our condition is g square minus c is less than 0, f square minus c is less than 0. And, okay? So in this case, I'm very sorry. Really sorry. So in this case, what we are getting? 9 minus lambda is less than 0. And from here we are getting lambda is greater than 9. And from the second one, we are getting 25 minus lambda is less than 0 implies lambda is greater than 25. Okay? This and this, as well as and this. So we have to find out the common region. Your lambda is greater than 9, lambda is greater than 25, and lambda is less than 29. If we combine this, we will say that your lambda is greater than 25 and less than 29. And that is the range of lambda for which the given circle will neither touch nor intersect the coordinate axis, and the point 1, 4 is inside the circle. Is it right? Okay, now let us reveal the answer. Is it clear to all? Absolutely? Okay. So let me take another problem. Now see this question. Same question. The point, this is not your normal bracket. I have already mentioned here that this is the greatest integer function. So box of lambda plus 1, box of lambda. This point is lying inside the circle this. Then find the set of all values of lambda. Okay? Now, the point which is given to us can also be written as lambda, box of lambda, or greatest integer function lambda plus 1, comma, greatest integer function lambda. Can you remember this property? We all done in the basic mathematics. That is, greatest integer function of x plus any integer can be written as greatest integer function x plus the integer. So that's exactly what I have written here. Okay. Now, for a time being, let me take box of lambda is, let us say, A. Okay. Therefore, our point has been transformed into A plus 1 and A. And they have said that this point is lying inside this circle. Hence, it must satisfy. I mean, not satisfied, I will find out what is my S1. What is that S1 here? S1 is in place of X, I'm going to put A plus 1. And in place of Y, I'm going to put A. So what we are getting? So that gives us so we are having 2s square and we are having 2s square minus 16, right? So 2s square minus 16 as this I can write s square minus 8 as they have said that the point is inside the circle. Hence your S1 will be definitely less than 0. Just now I have explained what I have explained. If S1 is less than 0, then what you say? The point is inside the circle. That's exactly what I have done here. S1, this is our S1. This S1 is inside the circle. Therefore, it has to be less than 0. It implies what? S square minus 8 is less than 0 implies what? S square is less than 8. So from here we can write your A is lying between 2 root 2 and minus 2 root 2. Can you remember this? If we have written x square is less than a square, that implies what? Your x is lying between, your x is lying between minus a and a. Okay? So that's exactly what I have done here. And what is your a? A is nothing but box of lambda. So box of lambda is lying between minus 2 root 2. Root 2 is 1.414 into 2 will give us minus 2.8 and this is less than 2.8. Now here it is box. So in this range, we have to find out what are the integers because box x is always an integer. So your box lambda can take the value minus 2, minus 1, 0, 1, yeah, 2. So when box of lambda is minus 2, your lambda is lying between minus 2, minus 1. When box lambda is minus 1, your lambda is lying between minus 1 and 0. When box lambda is equals to 0, your lambda is lying between 0 and 1. When box lambda is 2, your lambda is lying between, box lambda is 1, it is lying between 1 and 2. And when it is 2, your lambda is lying between 2 and 3. So from this, we can easily see that your lambda is lying between closed minus 2 till 3 open. Yes or no? Therefore, your option A is correct. It's a very nice question. This special function has been involved in this coordinate geometry. So in that way, it's a nice sum. Okay. Therefore, your option A is correct. Is it clear to all of you? If you have any doubt, please do write in the chat section so that I can explain it once again. Okay. Then let us move for the next part, which is called power of a point and length of tangent. These two things we will learn simultaneously. Simple thing, power of a point. It's a new thing that we have to remember. What is power of a point? Suppose a circle is given. I'm taking the general equation. This circle is given. And just now I taught you what is your S1. What is S1? Simply there is a point x1, y1. There is a point x1, y1. And now this S1 is basically putting this x1, y1 in this expression. So it is x1 square, y1 square, 2gx1 plus 2fy1 plus c. This is the expression. This is the value. And as we all know that if this is S1, I taught you, S1 is greater than 0, it means the point, which point? X1, Y1 is outside the circle. If it is equals to 0, inside the circle. And if it is less than 0, it is, equals to 0, it is on the circle. And less than 0, it is inside the circle. This I already taught you. Now, this S1 is what called your power of a point. Which point? In this case, x1, y1. That is why I was telling you repeatedly that this S1 is very important. S1 is basically called power of a point. So now onwards, I'm not going to tell you in this way that this point is outside, inside. No, I will say in this way that if the power of a point is greater than 0, the point lies outside. If the power of a point with respect to a point is equals to 0, the point is on the circle. And if the power of a point with respect to a circle is less than 0, then the point lies inside the circle. In this way, we will say. Is it clear? Absolutely. Okay, so S1 is nothing but, now onwards we will remember this S1 is nothing but power of a point. Power of a point. Power of a point not only valid for your circle, it is valid for parabola, ellipse, hyperbola, everywhere. So whenever we are saying that the point is whether outside, inside or on, we will talk with respect to power of a point. Every time I will say in that way. Whether this point is outside, I check the power of the point. If the power of the point is greater than 0, definitely it is outside. If it is equals to 0, definitely it is on the curve. And if it is less than 0, it is inside the curve. Okay, so please do remember this power of a point. So now we are going to do how to find out the length of a tangent. How to find the length of a tangent. Okay. So let me draw a tangent over here from a point outside the circle. Definitely the point cannot be inside the circle, because if the point is inside the circle, you cannot draw a tangent. So this is the tangent and this is the center. Let us say this is the center C and this is the point A, which is x1, y1. And let us say the point where the tangent is touching the curve or the circle in this case is B, right? So now my task is to find out what is the length of AB. Very, very interesting. Very, very interesting. So how to find out this length AB? The equation of the circle is x square plus y square plus 2gx plus 2fy plus c equals to 0. Therefore, its center will be what? Minus g comma minus f. Right? Now, what I'm doing is I'm simply joining the point A with C and B with C. Okay? The moment I've joined this, you people all know that when I'm joining the point of contact with the center, B is the point of contact. This is what? Point of contact. What is point of contact? The point where the tangent is intersecting the curve. So now your CB is basically the radius, and which is nothing but root over of g square plus f square minus c. Yes. Now what is your AC? By using the distance formula, I can find out the distance AC, which is nothing but x1 plus g whole square, y1 plus f whole square. Okay. Now, since this is 90 degree, so I can apply the Pythagoras theorem. So here we can write that AB square plus BC square is basically AC square. AB, I need to find out that. What is BC? It is nothing but the radius square, which gives us, minus C. And what is AC? AC we got here, square of it gives us okay. So if we expand this, right? Now g square f square will get cancelled with this one. So AB square is coming to x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. Look it carefully. And root over of that. AB is what? It's root over x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. Oh my God. What is this? What is this? This is nothing but the power of the point. So what is the length of the tangent? It is nothing but root over of power of a point, power of the point. Tell me yes or no. So AB is nothing but root over of S1. So interesting thing. So if there is a point outside the circle, and if we draw a tangent, then the length of the tangent will be nothing but root over of power of the point. Or you will remember in this way that the length of the tangent is root over of S1. That's it. Root over of S1. Simple. Is it clear? Is this clear to all of you? So we have learned power of a point. What is power of a point? Simply in the given expression or the equation given, put that point over there. That is the power of the point. And the length of tangent, indeed, it's no use of saying that it's point x1, y1 when you are finding out the length of the tangent. The point is outside the curve. Why? Because if it is on the curve, the length of the tangent will be 0. And if it is inside the curve, no tangents can be formed. So whenever you are finding out the length of the tangent, definitely the point is outside the circle in this case. So what is the length of the tangent? It is nothing but root over of S1. What is S1? Power of the point. As simple as that. Okay. So two things we have learned, power of the point and length of tangent. Please do remember. So now let us move for a problem. See this question. The question is, if the length of the tangent drawn from the point 5, 3 to the circle this. This is the given circle. And we are drawing a tangent to this circle from a point outside the circle. Now, in this case, you can ask me, sir, how do you know that the point is outside the circle? Here, at least trust the examiner who has given this question. Otherwise, they will never give you to find out the length of the tangent. Common sense. Because here you cannot find out now the point whether it is on, in, or outside the circle. Because there is an unknown variable k. So you cannot find out the power of point, whether it is less, greater, or equal to 0. So that is why I'm telling you, trust the examiner. So we have to find out the length of the tangent. The point is here. The point is outside the circle, which is your 5,3. Okay. And they have said that the length of this tangent AB is 7. So find the value of K. Direct application of the length of tangent. So what I will do, I will simply put this point in the given equation, right? So what you are getting, 5 square, 3 square, 10, 3K plus 17. Yes. So this is what? This is the power of the point. So what is the length of the tangent? Root over of the power of the point, which is given to be 7. So what will be the answer? 25 plus 9 plus 10 plus 17 plus 3K is 49. Okay. So how much you are getting? This is your 35, 44. 44 goes that side. So 3K is 5 minus 17, right? So it's coming like minus 12. So K is coming like minus 4. Straight away. So option B is correct. Have you understood this? This is the simple application of finding out the length of the tangent. Okay. So length of the tangent is what? It is the square root. Again, I'm telling you, it is the square root of the power of the point. That's it. Okay. Chalo. Next problem. Let us come to this. Read the question carefully. If the length of the tangents drawn from the point 1, 2 to the circles, these two are different circles. These two are different circles. Be in the ratio 4:3. If the length of the tangents drawn from this point to the circles, this and this, be in the ratio 4:3, 7. 7 means the length of the tangent is 7. Okay. Then K equals to what? Then K will be equals to what? Simple sum. Length of the tangents drawn from the point 1, 2 is this, and this being the ratio 4:3 is 7. Okay. So what will be the value of K? Can you do this? Can you do this? This will be your homework. This sum will be your homework. You must try this sum before I start my second class. I will definitely do this sum and then I will start the next session of this class. Okay, but be very careful. One thing I'm telling you, please do observe the equation. जल्दीबाजी मत करो, धीरे धीरे. Okay, please try this sum. This will be your homework. Okay, so see you in my next class tomorrow. And you must try this sum before I start the next session. So we will be meeting tomorrow with the next session of this class. So stay tuned to us and don't forget to subscribe and like and share this video. Thank you. See you tomorrow. In the previous session, we have already completed what? We have completed the intercepts by the circles, power of a point, and length of tangent. This we have already completed today in the morning. So now in this class, what we will do, we will start with the two left portion, which is equation of various tangents, Mainly we will learn tangents and then we will go for director circle. Okay. So before starting the class, as I have promised that I have given you one sum as your homework, and that sum I'm going to complete first and then we will move for the rest portion. If the length of the tangents drawn from the point 1, 2 to the circles this and this, these are the two circles given to you. So let me just draw the circle first. So these are the two circles. One circle is here, the another one is here. Let us say there is a point. There is a point somewhere here and the point is 1, 2. Now what I'm doing from this point, I'm drawing two tangents. One on the first circle and the second one is in the second circle. So if I draw those two tangents, this is the first tangent and in the second circle I have drawn this tangent, right? Now they have said that the length are in the ratio 4:3. The length are in the ratio 4:3. So what to do, as we all know how to find out the power of a point, and root of power of point is nothing but the length of the tangent. As we have learned the power of point. Power of point means if the equation, I'm just revising, if the equation is this is the general equation of the circle, and there is a point, say x1, y1, which is outside the circle. From there, if we draw the tangents, the length of the tangent will be root of S1. This we have learned. What is S1? S1 is the power of the point x1, y1 with respect to the given circle. Now, S1 will be here what? It is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c equals. So the length of the tangent will be root over of this power of the point. So from this point 1, 2, if we draw the tangent, this tangent, the length of this tangent will be what? It will be root over of 1 square plus 2 square. I'm putting this point in this equation. So 1 square plus 2 square plus 1 plus 2 minus 4. So that gives us 2 plus 1, 3. So it's coming like 4, 5, 8, 4. So it is basically coming to 2, right? This is the length of the tangent. Let me just name it. It's A, B, and C. So AB is your 2. And what about your AC? Now, the common mistake that students used to do is that they straight away put this this point to this equation. That will be absolutely wrong. If you want to find out the length of the tangent, the form should be in this. It should be in the form like x square plus y square plus 2gx plus 2fy plus c equals to 0. That form should be there. In this case, your 3x square and 3y square, 3x square plus 3y square is there. So here you cannot directly put, the value to get the power of the point until and unless it is of this form. So what I have to do first is the given equation, I have to write this thing in this way. X square plus y square minus x over 3 minus y over 3 plus k by 3 equals to 0. So I have divided both sides by 3. Now I can find out what is the length of the tangent by simply putting this 1 and 2 in this expression, right? And after that taking the root sign. So the length of the tangent now it will be 1 square plus 2 square. Okay. So this length is coming to what?
1 plus 4 minus 1 plus k over 3. So that gives us under root 4 plus k over 3. Now by the problem they have said that 2 over root 4 plus k by 3, this is equals to the given ratio 4 over 3, right? So we are having now square both sides, so it gives us 9 4 4 plus k over 3. So from here we can find out the value of k. It is coming like 9 minus 16 equals to 4k over 3. So this is coming like minus 7 into 3 over 4 is nothing but k. Therefore, your k is coming to minus 21 over 4. That's it. Is it clear? Hence, option D is correct. Is it clear to all? Is this clear to all?
Yes, sir.
Okay. So
Yes.
it was a pretty simple sum. Why I have chosen this sum? Because sometimes students used to do this mistake. Please do remember this, that whenever you are finding out the length of the tangent, that is, you are finding out the power of the point, the equation of the circle should be always in this form: x square plus y square plus 2gx plus 2fy plus c equals to 0. Please do remember this. Until and unless the form is this, you cannot find out the power of the point, that is s1, hence the length of the tangent, which is root over of s1. Okay, so now let us move for our next portion, which is equation of tangent to a circle. Now you see, one thing we know, that if there is a circle and if there is a line, this line and this circle, it has three kinds of relation. What are they? If this line doesn't touch the circle, this is one condition. Or this line is touching the circle at only one point, this can be another condition. Or this line is touching this circle or intersecting the circle at 2 points. So these are the three conditions that a line and a circle can hold. Now, the line which is not touching the circle, I don't have any relation with that. I don't have any relation with that line which does not touching the circle or intersecting the circle. The line which is touching the circle at only one point is what called your tangent. And the point where it is touching is what called your point of contact. Okay, so when the line is touching the circle at only one point, we call that line a tangent, and the point where it is touching the circle is what called your point of contact. And this line which is intersecting the circle at 2 points is what called your secant. So I'm going to discuss here about the tangent as well as secant. Throughout our circle chapter, we will discuss not only in circle, in all the conic sections, we are interested about these two lines, the tangent and the secant. I'm not at all interested for that line which is not touching or intersecting the circle. Okay, now my question is very simple, that we are having a line y equals to mx plus c. Now my question is, what is the condition? What is the condition? What is the condition such that this y equals to mx plus c is a tangent to the circle x square plus y square equals to a square, which is the standard form of any circle. So now, if this line is a tangent to this circle, listen it very carefully. if this line is a tangent to this circle, so let me try to solve these two equations to get the point of intersection, which is nothing but the point of contact. So if I solve these two equations, what we are going to have? Let me expand this. So we are actually getting, right? Now the question is, it is a quadratic equation in X. So definitely if I solve this, I am going to get two values of X, let us say X1 and X2. But since y equals to mx plus c is a tangent to this circle, as it is a tangent to this circle, it means it is going to touch the circle at only one point. It is going to touch the circle at only one point. That is, we are not going to get x1 and x2 differently. We are going to have the values of x which is equal because it is touching the curve at only one point. So only one value of x you must get. That is, the roots of this equation must be equal. Are you getting my point? The roots of this equation must be equal, because if the roots are equal, then you are going to find out one value of x. Why? Because the line is touching the circle at only one point. Okay, so when we are going to have only one value of x, actually we are getting two values of x, but they are equal. It is possible only when the discriminant of this quadratic equation is equals to 0. So discriminant means b square minus 4ac. So let me just write it that. Minus 4ac, which is equals to 0. So 4 goes off. Let me open the brackets. So we are getting m square c square minus c square plus s square m square equals to 0. And this will go off. So we are having actually c square equals to a square into 1 plus m square. And that is the condition. That is because in the beginning of this question, I told you that I want to find out the condition for which the line y equals to mx plus c is a tangent to this circle. And we all know that to find out the equation of the to find out the condition, we need to find out a relation between the constants. Here the constants are m, c and a. So we got a relation which is nothing but c square equals to a square into 1 plus m square. Now a question can come, said, do I have to remember the method of finding out this condition? My answer is yes. You must remember the method, because in some questions we cannot use this formula. We will come across those questions afterward. But remember this, when we are unable to find it, because you look very carefully, we have taken a standard form. I haven't taken the general form of the circle, and from there I haven't got the condition. But how to find out that condition in that case? In that case, you have to follow the method that I have done. What I have done? You will simply assume that y equals to mx plus c will be a tangent to the circle when it is touching the circle at only one point. So for that, while you are solving these two equations, you are going to have both the roots equal. Both the roots equal. So in that case, you will simply put the discriminant equals to 0 to find out the condition. So now we got that for a standard form x square plus y square equals to a square, y equals to mx plus c will be a tangent when c square equals to a square into 1 plus m square. That's it. We have to remember this, as well as we have to remember the method, how I got this one. So what will be the equation of the tangent? If c square equals to a square into 1 plus m square, then c can be written as plus minus a root over 1 plus m square. So the equation of the tangent is y equals to mx plus minus a, because here I am putting the value of c, root over of 1 plus m square. That's it. That's it. So this is the equation of the tangent. And the condition that y equals to mx plus c will be a tangent to the circle x square plus y square equals to a square is c square equals to a square into 1 plus m square. That's it. Is it clear to all? Is this clear to all? If you have any question,
Yes,
you can
sir.
ask me. Let me take one problem. Okay. So now the question is, find the condition for which the line, this one, find the condition for which the line Lx plus my, Lx plus my plus n equals to 0 will be a tangent to the circle x square plus y square equals to a square. This is the line and this is the circle. What is the condition for which this line will be a tangent to this? Now, if you want to do it by the normal method, the method that I told you, suppose I have forgotten this condition that c square will be equals to a square into 1 plus m square. Though it is not desirable, but let us say that we have forgotten this formula. So in that case, how to find out that condition? Now you have to follow the same method I have done. So right now I'm not doing that. You can do it by yourself. Here we will directly apply the formula c square. The condition is c square equals to a square into 1 plus m square. That is the condition that we have learned. But when this condition is applied, when we are having the equation of the tangent in this form, be very careful about it. The form of the line was y equals to mx plus c. So in this case, we have been given Lx plus my plus n equals to 0. So if we really want to use this formula, we have to convert this line in terms of y equals to mx plus c. So that's exactly what I'm trying to do. Okay. So now in this case, we can easily see that our m is basically L over m minus, and our c is basically minus n over m. Okay. So what is the condition? The condition will be c square equals to a square into 1 plus m square. That is, c square means minus n over m whole square is equals to a square into 1 plus m square. M square means this square. So what we are getting? N square over m square equals to a square m square plus l square. That's it. So just cancel this one. So we are having n square equals to a square into m square plus l square. See, this is the advantage if we remember the formula. That is the advantage if we remember the formula. Otherwise, what we have to do? We have to do it again. We have to use this method to find out this condition. That's the reason why I told you to remember that as a formula. So let me just revise once more. Y equals to mx plus c will be a tangent. Y equals to mx plus c will be a tangent to the circle x square plus y square equals to a square. The condition is c square which will be equals to a square into 1 plus m square. Please do remember this to solve the problem quickly. Okay, let us see this question. A very interesting sum. The question is, find the range of values of the constant c. Find the range of values of constant c such that the solution set of the system x square plus y square less than equals to 25 and 3x plus 4y equals to c, c is a constant, is infinite. What should be the value of c or the values of c such that the solution set of x square plus y square is less than equals to 25 and 3x plus 4y equals to c will have infinite number of solutions? That's the question. Now you have to understand one thing before doing the sum, that what do you mean by, see, if we have been given only x square plus y square is 25, we know what it is. It's a circle whose center is at the origin and radius is 5 units. This we know. So where does this x and y lies? X and y lies on the circumference of this circle. X and y lies on the circumference of this circle. And this is what is called your ring. Ring means the points are always on the circumference of that circle. It's a ring. But the moment you say x square plus y square is less than equals to 25, it means what? We are talking about all the points inside this circle as well as on the circle. Because any point you take inside the circle, it is going to satisfy this inequation. So x square plus y square is less than equals to 25. It means we are talking about all the points inside the circle as well as on the circumference of the circle. And this is what is called your disk. The disk is, what is a disk? Now every point, if you consider a disk, you have seen the CD disk, isn't it so? So in that CD disk, every point inside as well as on the circumference are considered. It is a disk. And when the points are on the circumference of the circle, that's a ring. So here the question is x square plus y square. Let me just erase those. So in this case, we have been said about the disk, that is everywhere inside as well as on the circumference of the circle. I mean, your x and y is lying anywhere in the circle, inside or on the circle. Now we are having a straight line there. Let us say the line is this. Now suppose if the line is this, please tell me, will you ever get any solution? If the line
No,
is
sir.
this, will you ever get any solution?
No, sir.
No.
No, sir.
Okay. Now, let me just do one thing. Let me just take this line at this point. Please tell me, are you going to get infinite solution for this too?
No, sir.
No,
sir.
No, sir. We will
because
get
in this
only
case, you are
one
going to have
solution.
only one solution.
One solution.
Okay. But what is the question? We want infinite solution. So it's very clear to us, it is very, very clear to us that this line should definitely be a secant to this circle. Because if this line is a second, you see, every point on this line, which are infinite points, are going to satisfy the equation of the disk. Because in the disk, your xy is lying inside the circle or on the circle. So if you want to find out the common points, the common point is going to satisfy this equation as well as the equation of the disk. So one thing is clear to us, that this straight line is neither a tangent nor a line which is not intersecting the line, I mean the circle. It is the line which is basically the second to the circle. That's for sure, to get infinite solutions. Now, what should be the range of C for this? Okay, so this is the equation of the circle, which is x square plus y square equals to 5 square. So the center is where? The center is at origin, and radius is 5 units. Radius is 5 units. Now, the equation of this line is 3x plus 4y minus c equals to 0. So now, from this point, listen it very carefully. If this line is a second to this circle, then if I draw a perpendicular from the center on this line, if I draw a perpendicular from the center to this line, then this distance has to be less than the radius of the circle. Then only you can say that yes, sir, this line is a second to this circle. Tell me yes or no.
Yes, sir.
Yes,
Yes.
sir.
Yes, sir.
Yes, sir.
So, what is the perpendicular distance drawn from the origin on this line? It will be 3 into 0 plus 4 into 0 minus c divided by root over of 3 square plus 4 square. This is the perpendicular distance. And this has to be less than the radius of the circle, which is nothing but 5. So we are getting modulus of c over 5 is less than 5. So that implies what? Mod of c is less than 25. So from here what you can say, your c is lying between minus 25 and 25. That's it. Now one question you can ask me, sir, why you have not taken an equal sign over here? No, I am not going to take an equal sign, because the moment this distance becomes a radius, this line then becomes the tangent. And tangent is intersecting the circle at only one point. There we are not going to get infinite solution. That is the reason why I have not given an equal sign over here. Is it clear to all? Have you understood what I want to say?
Yes, sir.
Yes.
Yes. Can you explain this once more?
Okay, so the range of C here is nothing but from minus 25 to 25. That's it. Okay? Okay, so now let us move for another conception, which is various forms of tangents. See, these three forms we have to remember. All these three forms we have to remember. There is no choice, because in the question, as the question demands, I will use different forms of tangent. But anyways, I'm not going to tell you to memorize blindly. I'm definitely prove all those equation of tangents. Then only I will say to memorize. And definitely I'm going to give you some shortcut tricks to remember this equation of tangents. The first one, I think I don't need to prove it, because I have already proved this one. This is what is called your slope form of tangent. I've already done this. I've already done this here. You can see this. See, y equals to mx plus minus a root over 1 plus m squared. That exactly which is known as your slope form of the tangent to the standard circle x squared plus y squared equals to a squared. So this we have to remember, and we have already proved it. Now the second form is what called your Cartesian form of tangent. What is that? Okay, let me just draw a circle first. Now this is a circle, and there is a point. The equation of the circle is the standard one, x squared plus y squared equals to a squared. And we are having a point x1, y1 on the circle. Be very careful. Here the x1, y1 is on the circle. And I want to find out the equation of the tangent at this point. I want to find out the equation of the tangent at this point. That's the question. Okay, so how to do that? Well, this is our center, which is 0, 0. And if I join the center with the point of contact, then we all know that this one will be your 90 degrees. This we all know. Okay, in class 10 only you people have all learned this, that whenever the point of contact is joined with the origin, it is always perpendicular. Afterwards, we will learn that this is nothing but the normal of a circle. That we will learn later on, not now. So now we have to find out the equation of this circle. I'm sorry, of this tangent. So what to do? Simple thing. You see, to know the equation of any straight line, as I have mentioned repeatedly, you need two things. One is through which the line is passing, I mean the point through which the line is passing, and number two, what is its slope? That's it. So I know that this tangent is passing through the point x1, y1. This we know. The only thing that we don't know is the slope of this line. So to find out the slope, let me find out the slope of this line. Let me just give a name. What is the slope of AC? 2-point form? It's y1 over x1. Now, if the slope of AC is y1 over x1, then definitely the slope of the tangent is minus x1 over y1. Why? Because this line AC and the tangent, they are perpendicular to each other. Therefore, the product of their slopes will be equals to minus 1. So the slope of the tangent is minus x1 over y1, and the point is x1 comma y1. Therefore, the equation of the tangent will be what? Y minus y1 equals to minus x1 over y1 into x minus x1, point slope form. So it comes to y1 minus y1 square equals to, so from here we are getting x1 plus y1 equals to x1 square plus y1 square. Now, x1, y1 is a point which is lying on the circle. Hence, it must satisfy it. That is, x1 square plus y1 square will be equals to a square. Therefore, I can replace this by a square. So, we are getting the equation of the tangent as a square. That's it. That's exactly what I have written over here. The Cartesian form of the tangent is x1 plus y1 equals to a square. What is x1, y1? x1, y1 is a point. Repeatedly, I am telling you this. x1, y1 is a point. Why you will understand this later on. Why I am telling you that x1, y1 is on the circle. That you will understand afterwards. So x1, y1 is a point on the circle, and at that point only you are going to find out the equation of the tangent, which is nothing but x1 plus y1 equals to a square. That's it. So is it now clear to everyone? Is this clear to everyone?
Yes, sir.
Okay.
Yes, sir.
So two forms we have learned. One is the slope form of the tangent. The another one is the Cartesian form of the tangent. At the same time, I have shown you how to find these equations. Now, the last form is what called your parametric form. We all know, we have already learned this, x square plus y square equals to a square. The parametric form is what? It's any point on the circle. In the parametric form, we write in this way, a cos theta, comma, a sin theta. Right? X equals to a cos theta and y equals to a sin theta is basically the parametric form of a circle. This we have already learned. So instead of saying x1, y1 is any point on the circle, we can say any point on the circle be a cos theta and a sin theta. So in that case, what will be your this equation transform to? In place of x1, I am simply writing a cos theta, and in place of y1, I am writing a sin theta, which is your a square. So if you cancel a from both sides, we are going to have what? We are going to have a cos theta plus y sin theta equals to a. That's it. And that's exactly what I have written here. This is the parametric form of tangent. Okay? Is it clear to all? Is it clear to all?
Yes, sir.
So these three forms you people have to remember. Slope form of the tangent, Cartesian form of the tangent, as well as the parametric form of the tangent. Now, as I told you in the beginning of starting this slide, that I'm going to tell you a shortcut method. Suppose if I ask you, though we will do this one, let me just do it in another page. Suppose if I give you, say, equation of a circle is the general form. And if I ask you to find out the equation of the tangent at the point x1, y1. x1, y1 is very much on the circle. Be careful. Again, I'm telling you. So find out its equation of its tangent, which is also called your, what we have learned here, Cartesian form of tangent. So in this case, what you will do? We are having a circle. The equation of this circle is this one. And this is a point, let us say x1, comma y1. Now I have to find out the equation of this tangent over here. The center is where? Minus g, comma minus f. Now exactly the same way I taught you right now, you do it and you are going to get. How you will do it? You will simply find out the slope of this line. That is the line joining the point of contact and the center. You will get the slope of this line. So automatically you are going to get the slope of this line. That is the slope of the tangent. So now you know the slope of the tangent and it is passing to the point x1, y1. So you can easily find out the equation of the tangent. And the equation of the tangent will come like this. X1 plus y1 plus g times x plus x1 plus f times y plus y1 plus c equals to 0. That's it. Now you will say, sir, it is very difficult to remember. No, it's not difficult. The method that I'm going to teach you, it will be no more difficult. Remember one thing, not only in circle, but for all the conic sections. Remember in this way. If you really want to find out the Cartesian form of tangent, all you do is for any curve, Remember this. You replace x square by xx1. You replace y square by yy1. You replace 2x by x plus x1. You replace 2y by y plus y1. And other thing of that curve will remain same. And that will be the equation of the tangent. Look it carefully what I have done. Here there was x square. So I have replaced that with xx1, y square, yy1. It was 2gx. It means what? G into 2x. So this 2x is written as x plus x1. Similarly, 2fy means f into 2y. This 2y will be written as y plus y1. And don't touch the other thing which is there. That is here, it is c. So your c will be here. That's it. That will be the equation of the tangent. You see the previous one? You see the previous one? What was the equation? Now you will understand. What was the equation? Your circle is x square plus y square is a square. So what will be the equation of the tangent at the point x1, y1? It will be xx1 plus yy1. There is no 2x, there is no 2y. And don't change any other constant. So that will be the equation of the tangent. That's it. Okay. Now, if I give you, let me just go little out of the track and let me ask you, let me take an equation of a, say, parabola. Let me take. Suppose we have been given y square equals to 4x. Now you will listen, you will learn this immediately. Now if I ask you what is the equation of the tangent at the point x1, y1, you can easily give me the answer. No need to remember. This y square will be replaced by yy1 and there is 4ax. 4ax means it's 2a into 2x. This 2x will be replaced by x plus x1. So it will be x plus x1. That's it. That is the equation of the tangent to the parabola y square equals to 4ax. Any curve you take, any curve. Suppose if I take, let me take equation of a circle like this. X square plus y square minus x minus say 3y, let us say minus 5 equals to 0. Let me take this. And if I ask you what is the equation of the tangent at the point x1, y1, listen it very carefully. How you can do it instantly. Here it is x square. So I will write xx1. Then it is y square. So I will write yy1. Then we are having minus x. Minus x. But I need, when there is 2x, you have to replace by x plus x1. So x will be replaced by x plus x1 over 2. Here there is minus 3 and y is there. So y will be replaced by y plus y1 by 2. Are you getting my point?
Yes,
Are you
sir.
all?
Yes, sir.
Yes.
Yes, sir.
And
Yes, sir.
don't touch the other constant. That's it. That's the equation of the tangent. Instantly you can find out. Okay. So now we have learned the equation of the tangents. At the same time, we have learned how to find out the Cartesian form of a tangent in shortcut way. Okay. So let's take some problem right now. So we will be comfortable with that. Okay. Let us see this question. Find the equation of the tangent to the circle x square plus y square. X square, the first one I'm doing. For the circle x square plus y square equals to 4. And the point is root 3 plus 1. So how to find out this? Now we can easily see that root 3 comma 1 is lying very much on the circle, isn't it so? If you put root 3 and 1 in this equation, it is going to satisfy. So this point is very much on the circle. This point is very much on the circle. It is on the circle. So what will be the equation of the tangent? Just now we have learned It is what? X1 plus Y1 equals to 4. So in place of x1, I will write root 3x. In place of y1, I will write 1. So it will give you y equals to 4. That's it. That's the equation of the tangent. How we know? Because we know that this point is lying on the circle. That is why we have used this form, because this form will be applied only when your x1, y1 is on the circle. Again, I'm telling you, on the circle. If this point is somewhere here, this formula will not be applied. Until and unless your x1, y1 is on the circle, you cannot use this form. Be very, very careful. Okay, what about question number 2? Find out the equation of the circle to this circle, x square plus y square equals to 4 from the point 1, 1. Now, 1, 1, if I put in this minus 4, let me say this is my s, and if we find out the power of the point, what we are getting? What is our
Sir, it will
s1?
be inside the circle.
It's 1 plus 1 minus 4. That gives us minus 2, which is less than 0. Less than 0 means the point is somewhere inside the circle. And if the point is inside the circle, you won't be able to draw any tangent. Hello? If the point is inside the circle, can you draw a tangent? Tell me.
No, sir.
No, sir.
No.
No,
So
sir.
for the second one, no tangent possible. No tangent possible. Now let us see the point 2, 3. What is the power of the point? It's 2 square plus 3 square minus 4. So the power of the point is 9, which is greater than 0. So I'm sure that this point 2, 3 is lying somewhere outside the circle. Yes or no? Please tell me.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes. So the point is somewhere here. This point is 2, 3. Now I want to find out the equation of the tangent drawn from this point. Now listen it carefully. Can you use that form? X1 plus y1 equals to 4. Can I use this form to find out this equation?
No, No, sir. sir.
No. No. Why no? Because this point 2, 3 is not on the circle. It is somewhere outside the circle. So we cannot use this form. So now my question is, how to find out this equation? How to find out this equation? You see, the center of this circle is 0, 0. The center of this circle is 0, 0. And this line is passing through the point 2, 3. So how to find out this equation? How to find out this equation? Let us say the equation of the straight line be y equals to mx plus c. Let us say the equation is y equals to mx plus c. Okay. So from the center, if I draw a perpendicular or I join the point of contact, both are same, then this one will be perpendicular to this line. And this length will be nothing but the radius. And radius in this case is 2. Radius in this case is 2. So what I will try to do here, I will simply put, in this equation, I will simply put this is 0. This is the equation of the line. Now let me draw a perpendicular from the origin. So what will be the perpendicular distance? The perpendicular distance will be this is nothing but 2. So you are basically getting C equals to, you are basically getting modulus of C divided by root over of 1 plus m square is 2. So we can say it is C square is nothing but 4 times 1 plus m square. That's okay. Now how to find out the value of m and c? You see, This line is passing to the point 2, 3. Hence, it must satisfy this. This line is passing, the equation of this line, we have assumed this thing as y equals to mx plus c. As it is passing to the point 2, 3, hence it must satisfy this. So what I'm saying is, it's 3 equals to 2m plus c. So what is your c? C is nothing but 3 minus 2m. So let me just replace this. 3 minus 2m whole square is 4 into 1 plus m square. So from here we can get 9 minus, which is equals to 4 plus 4m square. Is it clear? 4 plus 4m square. Now this 4m
Yes,
square and
sir.
4m square will go off. So we are left with what? 9 minus, let me do it in the next, or okay, let me do it in the next page. So 9 minus 12m, 9 minus 12m, 9 minus 12m is equals to 9 minus 12m equals to 4. Right? So 12m is coming to what? 9 minus 4, which is 5. So m is coming to what? 5 over 12. Am I correct or not? Have I written it correctly or not? Please tell me. Is it
Sir,
correct?
one more slope should come, na, sir?
Very good. That's exactly what I was expecting from you people. Because it is an equation involving a quadratic in m. Quadratic in m. And we got only one value of m. How it is possible? It's not possible. So I must get another value. And what is that value? As I told you, as I repeatedly
Sir,
told you in
infinity.
straight line, your aim will be infinity.
Infinity.
Another value aim will be infinity. So one value is 5 over 12, another value is infinity. Now, if aim is infinity, that means what? The line is perpendicular on the x-axis. That is, it is parallel to the y-axis. And if it is parallel to the y-axis, then the equation of this line will be x equals to constant. And we know that the tangent is passing through the point 2, 3. X is constant. So one equation of the tangent is x equals to 2. Are you getting my point or not? If
Yes,
aim
sir.
is infinity, it means what? It is perpendicular on the x-axis, means it is parallel to the y-axis. And as it is parallel to the y-axis, the equation of that line will become x equals to constant. The tangent is passing through the point 2, 3. The tangent is passing through the point 2, 3. Therefore, the equation of this line will be definitely x equals to 2. And what about the other one? We got m as 5 over 12. And we know that c is 3 minus 2m. So what is c? So it's coming like 13 over 6. Therefore, the other equation will become y equals to mx plus c. That's it. This is one equation, and another equation is x equals to 2. Because we can easily see one thing, that from a point, we can easily see from the diagram itself why the equation of two tangents are coming. Because from this point, we can draw two tangents, isn't it so? From any point outside the circle, we can draw two tangents. That is why we are getting two equations of the tangents. One is this, and another one is x equals to 2. Is it clear to all? Is this clear to all?
Yes,
Yes.
sir.
Okay, great. So let me take the next problem. See this question. This came in JEE 2019. What is the question? If a tangent to the circle, side by side, you must try this sum by your own right now. The question is, there is a circle. If the tangent to the circle x square plus y square, the equation of this circle is x square plus y square is your 1. So this is the tangent. This is the tangent. This is the tangent actually. And it is intersecting. And if we draw a tangent over here, it is intersecting the coordinate axis at two distinct points P and Q. Is it clear? The circle is x square plus y square equals to 1. That is, its center is at the origin and radius is 1 unit. Now this tangent is intersecting the coordinate axis at P and Q. We have to find out the locus of its midpoint. Now see, there are several tangents which can be drawn. Which are touching this circle and intersecting x and y at different places. Okay, I can draw a tangent over here. So what I want to do, I want to find out the locus of all those tangents, which is the midpoint of P and Q. Is it clear? So how to do that? Let us say h comma k be any point on the locus. And let us say this point of contact where this tangent is touching the circle, let us say this point be x1 comma y1. Then what is the equation of PQ? What will be the equation of the PQ? That is the equation of the tangent will be what? Tell me. Xx1 plus yy1 equals to 1. Am I correct or not? Please tell me.
Yes, sir.
Okay, so this is the equation of the tangent. Now, where it is intersecting the x-axis, put y equals to 0. So we are getting, it is intersecting the x-axis at 1 by x1 comma 0. And it is intersecting the y-axis, put x equals to 0. So we are getting 0 comma 1 over y1. Therefore, the coordinate of P is 1 over x1 comma 0 and coordinate of Q is 0 comma 1 over y1. Now I want to find out the locus of their middle point hk. That is, what is h? It is 1 over x1 plus 0 divided by 2, which states h is 1 over 2x1. Similarly, what is k? K is 0 plus 1 over y1 by 2. So that gives us k is 1 over 2y1. Okay. Now, what is x1? x1 is 1 over 2h. What is y1? It's 1 over 2k. Now, you have to find out the locus. Means I have to find out a condition which will involve h, k and constants. We can easily see that x1 comma y1 is a point which is lying on the circle. Hence, it must satisfy this equation. That is, x1 square plus y1 square must be equals to 1. In place of x1 now, I am putting 1 over 2h. So that gives us what? 1 over 4h square. 1 over 4k square, which is equals to 1. Now, this is the equation of the locus. What is the equation of the locus? this one. So if we simplify, what we are going to have? So x square plus y square is 4x square y square. So from here we are getting x square plus y square minus 4x square y square is 0. Hence option C is correct. Pretty simple sum. As I told you, if you are neglecting this coded geometry, you are missing a lot of marks. You will definitely miss a lot of marks in in this competitive examinations. So that is why I told you, please do the sum properly. Try to remember the shortcut thing that I am telling you and the tips and tricks I am giving you in between. And definitely you have to remember the formula. That's the only criteria to score good marks in coordinate geometry. Sure. So let us move for the next problem. See this question. In this question, they have said that there is a circle C of radius 5 which lies below the x-axis. So let me just draw that diagram first. So there is a circle C which lies below the x-axis. So let us say the circle is this. And then what they have said, the line L1, 4x plus 3y plus 2 equals to 0, this passes through the center P of the circle C. So this circle is C and its center is at P. Okay. Now the line 4x plus 3y plus 2 equals to 0 is passing through the center of this circle. So the line will be something like this, which is passing through the center of this circle. Okay. And L2 is a line which is intersected by L1 at the point Q, and Q is the point on the circle. Q is the point on the circle. That is, this is that line, and the point of intersection of L1 and L2 is Q. Is it clear or not? Now we can all see that L1 and L2, they are perpendicular to each other. Okay. So now we have to find out the distance of point P from the line. A separate line is given. The equation of this line is 5x minus 12y plus 51 equals to 0. So now we have to find out the perpendicular distance from the point P on this straight line. This distance we have to find out. That's the question. So this distance can be easily found if you know the center of this circle. Okay. So now how to find out the center of the circle? To get the coordinate of Q, let me solve these two equations. So the two equations are this one and L2 is this one. Okay. So now let me solve it very quickly. And the second one is coming to, so if we subtract, we are going to have, so we are getting y as minus 2. Okay. So y as minus 2. Now if I put it in the first equation, we are going to have, so x is coming to 1. Okay. Therefore, the coordinate of Q is nothing but 1 comma minus 2. Is it clear? Now, what is the slope of, now my main task is to find out the center of this circle. Let the center of the circle be alpha comma beta. Okay. So now what is the slope of? What is the slope of L1 equals to 0? So from here we can write, so y is coming to, so what is the slope of this line tan theta? It's minus 4 over 3. So if I draw a right angle, this is going to come 5. Therefore, my sine theta will be 4 over 5 and cos theta will be minus 3 over 5, right? Now, why I am finding out this? Because I want to find out the point P. We know the coordinate of Q and we know that this PQ distance is 5. So if I use the parametric form, we can easily get the coordinate of P. Okay, so let me just apply the parametric form here. It's alpha minus 1 over cos theta equals to beta plus 2 by sine theta, which is your 4 over 5. This is equals to your R, which is nothing but your 5. Okay, rather it should be plus minus 5. This I have already explained in straight line chapter. Why I am giving plus minus sign there. So your alpha minus 1 is coming to, and beta plus 2 is coming to, clear? So alpha minus 1 is minus plus 3 and your beta plus 2 is plus minus 4. So we are having alpha as minus 3 plus 1 or alpha as plus 3 plus 1, right? So that is minus 2 and this is 4. And what about your beta? Beta is coming to plus minus 4, just 1 minute, plus minus 4 minus 2. So we are having either 2 or minus 6. Okay. But since they have said that the circle C is lying below the x-axis, therefore your beta has to be negative. Your beta has to be negative. The ordinate of the center will be negative. Therefore, the center will be 4 comma minus 6. That is the center. Is it clear? Now you got the point. Now you know the center P. Now, if you know the center, what will be the perpendicular distance from point P on this line? I'm using the perpendicular distance formula. So we are having divided by root over of 5 square plus 12 square. Okay. So we are basically getting what? 20, 72 plus 51 divided by 13. So it is coming like 92 plus 51, 13. So that gives us 3, 143 over 13. So that gives us 11 only. Is it clear? Therefore, the perpendicular distance of the point P, which is the center of the circle, from the line 5x minus 12y plus 51 is nothing but 11. Is it clear to all? Is this clear to everyone? Okay. Okay. So let us move for the next problem. What is the question? L1 is given, L2 is given. The circle C1, which is of radius 3, touches L1 and L2 and has its center in the first quadrant. Be careful. The center is in the first quadrant. What do you mean by that? The center is in the first quadrant. It means that your alpha beta, if alpha beta is the coordinate of the center, both alpha and beta are greater than 0. Okay, so now the circle C2 is concentric with C1 and cuts of intercepts of length 8 on the lines. Find the equation of C2. Okay, take it. Chalo. Let me just draw this first. Okay, there is one circle. The circle is there. What happened to this circle? Now, in this case, there are L1 and L2 touches L1 and L2. So there are two lines, L1 and L2. This is L1 and let us say this is my L2. Okay. So this is L1, this is L2. And what happened? And the center is at alpha comma beta, which is in the first quadrant. The circle C2 is concentric with C1. This is my C1. There is another circle which is concentric to this. Okay, concentric to this. Concentric means it is having
Same center.
same center.
Same center.
Only the radius will differ. That's it. Yes. Now what happened? Just 1 second. Let me just extend this. Okay. Then what happened? What they have said? The circle C2 is concentric with C1 and cuts of intercepts of length 8 on the lines. Okay. So this C2 is basically intersecting this length. This length is nothing but 8. This length is 8. Both this is 8, this is also 8. This is 8, this is also 8. Okay. So now what happened? Find the equation of C2. I have to find out this equation C2. See, one thing for sure. To find out the equation of C2, every time for finding out any equation of a circle, we need two things. One is the center, another one is the radius. That's it. That's it. C1 has its radius 3. So what I will do, how to find out its center? All I will do is I will simply join this point with the center. And what I will do, I will simply again join this with this point. Now observe carefully this, let me just give a name, A, B, this is C. Now observe carefully, your AB is basically the radius of C2. Now the question is how to find out C2? How to find out AB? Simple thing. This length, AC is 3. It is given. And how many of you can see that the length of BC will be 4? Am I correct or not? The length of BC will be 4. How many of you can see that? The length of BC is 4. Am I correct or not?
Yes, sir.
Okay. If it is
Yes, sir.
4, this is 90 degree because we have joined the point of contact with the center. So by using Pythagoras theorem, what we can say, 3 square plus 4 square is nothing but AB square. So AB square gives us 25, implies AB is 5. So immediately we got the radius of C2. We got radius of C2, which is nothing but 5. Now the only thing that is left with us, you have to find out this alpha and beta. The only thing is that you have to find out alpha and beta. How to find out this alpha and beta? We know the equation of L1. 5x plus
5x
12y
plus
minus
12.
10 equals to 0. And what is the center? Center is alpha comma beta. Now what is the perpendicular distance? That is, what is AC? 5 alpha
Root over
plus
5
12
square
beta minus 10 divided by root over of 5 square plus 12
plus
square.
5.
This is the radius. Again at the same time, if we draw a perpendicular from A on this line, this is also the radius of the same circle. So what will be the radius then? In that case, 5 alpha minus 12 beta minus 40 divided by root over of 5 square plus 12 square. and these two are equal. These two are equal. So from here we are getting this goes off. So we are having, actually I'm writing it here. So we are having modulus of 5 alpha plus 12 beta minus 10, which is equals to plus minus 5 alpha minus 12 beta minus 40. So let me take the plus sign. 5 alpha plus 12 beta minus 10 equals to 5 alpha minus 12 beta minus 40. So from here your alpha alpha goes off. So we are having 24 beta equals to minus 30, and beta is coming to minus 30 over 24. Okay. So can we take the value of this beta? Can we take the value of this beta? No. Why? Because I have already said that alpha beta is greater than 0. Your beta cannot be negative. So plus sign is not accepted. So I have to take the minus sign. So if I open the bracket, what you are going to have? So now 12 beta goes off. So we are having here 10 alpha is 50. So what is alpha? Alpha is 5. Hello? Yes or no?
Yes, sir.
Yes.
Yes, sir.
So we got alpha as 5. Now what about beta? How to find out beta now? How to find out beta now? The perpendicular distance 5 alpha plus 12 beta minus 10 divided by 13 is basically equals to 3. So if alpha is 5, what you are getting? 25 minus 10, that is 15, whole by 13 is plus minus 3. So from here we are getting 12 beta plus 15 is plus minus 39. So 12 beta is plus minus 39 minus 15. So 12 beta is basically what? 39 minus 15, or it will be minus 39 minus 15. This value is rejected because from here we are going to get the value of beta as negative, which is not accepted. So we got 12 beta is nothing but 39 minus 15, that is 24. So beta is nothing but 2. So what is alpha? Alpha is 5 and beta is 2. Hello? Yes or no?
Yes, sir.
Yes, sir.
Have you understood
Yes,
why I
sir.
have rejected the second value? Because your beta is greater than 0. It cannot be less than 0. That's why I have rejected the second part. So now you know the center. You know the center. At the same time, you know the radius. What is the radius? Radius is 5. So what will be the equation? X minus 5 whole square plus y minus 2 whole square is nothing but your 5 square. That's it. That's your answer. So what is the answer? Let me just check it. Let us verify this. The answer is, yeah, I've opened that one. Okay, no problem. If you open, you are going to get the same answer. Let us check. X square minus 10x plus 25 plus y square minus 4y plus 4 is 25. So 25 goes off. So we are left with x square plus y square minus 10x minus 4y plus 4 equals to 0. That's it. So can you observe one thing? What I am doing? I'm trying to find out the center. I'm trying to find out the radius. Everything you know in circle. As same case in your straight line. If you know the slope and if you know the point through which it is passing, you know everything about the straight line. In circle also, always try to find out its center and radius. Center, radius. That's it. Your focus should be on that. And whenever tangent question is given, always try to join the point of contact from the origin such that this line will be perpendicular to the tangent, and then try to manipulate and get the answer, as I am doing in all these sums. Okay, Let us move for the next problem. So in this question, they have said that the center of the circle C is a circle whose center is at alpha and beta and whose radius is less than 8. And let these two lines are the tangents to the given circle C, and the line 4x plus 3y equals to 1 is a normal to C. Okay? So let me just draw the diagram first and then I will explain the question. Coordinate axis. So this is the circle and we are having two tangents. One is 3x plus 4y is 24 and the other tangent is, let us say, this one. Okay, the equation of this line is 3x minus 4y is 32 and the equation of this tangent is 3x plus 4y equals to 24. Okay, now we can see that they have already said that 4x plus 3y equals to 1 is normal to this circle C. Normal to a circle which is actually perpendicular on the tangent at the point of contact always passes through the center of the circle. Therefore, the normal here is this line, which is actually perpendicular to this tangent. Am I correct? And the equation of this normal is 4x plus 3y equals to 1. And we can easily see that this will be the normal to this point of contact other than this point of contact. Why? Because this line and this line, they are perpendicular to each other. Getting my point? Normal is always perpendicular to the tangent at the point of contact, right? So this point is, let us say, the center B, P. Okay. So now we have to find out the coordinates of the center is alpha and beta and the radius of this circle is R. Now we have to find out what is the value of alpha minus beta plus R. So for that, we have to find out what is the value of alpha beta. At the same time, we have to find out what is the radius of this circle. So what to do? How to approach this sum? Very simple. The same funda I am using. From the center, you join the point of contact of the first line, and this is the point of contact from the center, the point of contact on this line. Let me just give a name of this. Let us say this is A, this is B. So PB is perpendicular on this line and PA is perpendicular on this line, and both of them are equals to its radius of the circle C. Okay, so what is the perpendicular distance PA? It is 3 alpha plus 4 beta minus 24 divided by root over 3 square plus 4 square. And what is the perpendicular distance of P on the line 3x minus 4y equals to 32? It will be 3 alpha minus 4 beta minus 32 divided by root over of 3 square plus 4 square, right? And these two are nothing but the radius of the same circle, hence they are equal. So now let me cancel this. So we can write 3 alpha plus 4 beta minus 24 is plus minus 3 alpha minus 4 beta minus 32. Okay, at the same time, remember this alpha beta, which is actually the center of the circle, lies on the normal, which is 4x plus 3y equals to 1. Hence, it must satisfy that. Let me write it here. So 4 alpha plus 3 beta is basically 1. Okay. Now, in this equation, if we take the plus sign, we are going to have 3 alpha plus 4 beta minus 24 is, and if we take the minus sign, we are getting, right? So from the first one, we are having this goes off. So it is 8 beta equals to minus 32 plus 24. So that gives us minus 8. So from here we are getting beta as minus 1. Okay. And from the second one we are getting 4 beta goes off. So it's 6 alpha is 24 plus 32. So that gives us 56. So alpha is coming to 56 over 6. That gives you 28 over 3, right? Now, if beta is minus 1 and if we put it here, 4 alpha plus 3 beta is 1. So we are having the value of alpha. In this case, it will be alpha is coming to 1. And if I put alpha equals to 28 over 3 in this equation, we are going to have, so your 3 beta is coming to 1 minus, it's coming like divided by 3. So it's 3 minus 112 divided by 3. That gives us 109 divided by 3. Correct? Therefore, your beta is coming to minus 109 over 9. Okay? So, your center is either 1 comma minus 1 or the center is 28 over 3 minus 109 over 9. Is it clear? Let me consider your alpha and beta to be 1 and minus 1. Therefore, what will be its radius? The radius is the perpendicular distance from the origin on the tangents. So, if I consider this PA is the radius, or you can consider PB also, doesn't matter. You will get the same answer. So, if I consider PA, so the perpendicular distance will be what? 3 alpha plus 4 beta minus 24 divided by root over of 25. Okay. So now if I put alpha beta as 1 and minus 1, we are going to have, so in this case we are getting minus 25 over 5, that is 5. And we can easily see that the condition which is given to us, that your R is less than 8, is satisfied by this value of R. I'm not finding out the value of R for the second coordinate because definitely it will be more than 8. You can do this calculation, no problem. But since I got my radius which is less than 8 and it is a single option correct question, so definitely this part which is coming here will definitely not be less than 8. Otherwise, we would have got two answers. Are you getting my point? So I'm not checking with this. You can check this thing with at home. You will definitely get the radius of this circle more than 8. So this value is rejected. So we got your alpha as 1, beta as minus 1, and your radius is 5. Therefore, the value alpha minus beta plus r will give us 1 minus 1 plus 5. That gives us 7. Is it clear? Hence, option A is correct. Have you got it? Is it clear to all? Okay, let me reveal the answer. Yes, it's A. Okay, so now let's move for the next part. This is various form of tangents. We have already done various form of tangents in case of the standard circle. X square plus y square equals to a square. Now, suppose if standard circle is not given to us, but we have been given the general form of the circle. In that case, what will be the equation of the tangents? Now, again, I'm telling you, I don't want to create unnecessary burden of remembering all those formulas. If you see any standard book, they have already given you a formula for this general equation of the circle, but I will suggest you not to remember that because so much of things you cannot remember. So To find out the slope form of the tangent, always use the conception that the perpendicular distance drawn from the center on a tangent is always equals to its radius. Simply use this conception to gauge the slope form of tangent. I will come with a question. I will take an example. Don't worry about it. But only remember that whenever it's a slope form of tangent and a general equation of the circle is given to us, even in the standard form, we will always use the conception that the perpendicular drawn from the center on the tangent is always equals to its radius. Only by using this conception you can find out the slope form of the tangent, right? Cartesian form of the tangent, I have already explained to you that if the point x1, y on the circle, again on the circle, then the equation of the tangent will be xx1 plus yy1 plus this thing plus c equals to 0. How I told you, you will simply replace x square by xx1, y square by yy1, 2x by x plus x1, 2y by y plus y1 without changing any other constant term which is there in the equation of the curve. Is it clear? So in that way, you are going to have the Cartesian form of the tangents. So again, in this case also, there is no need to memorize anything. Only remember the working rule, how to find out the tangent. One thing you must remember, that for Cartesian form of the tangents, the point must lie on the circle. Otherwise, you cannot use this formula. Now, the last part is what called your parametric form of the tangent. We know the parametric form of any standard form of a circle, as well as we know the parametric form of general equation of a circle. Can you remember that? It's x plus g whole square. I can convert this general form of the equation in this way. Y plus f whole square is equals to root over of g square plus f square minus c whole square, which is actually your r square. So in that case, we will write the parametric form as minus g plus r cos theta and minus f plus r sin theta. This I have already explained in the previous lecture. Okay, so I'm not going to explain this anymore. Now, the moment you have x1 and y1, there is no problem of finding out the parametric form of the tangent simply by replacing this x1 and y1 in this equation. Again, x1, y1 is which point? It is the point on the circle. So you simply replace x1, y1 in this equation, in the Cartesian form of the tangent to get the form of the tangent which is in the parametric. Is it clear to all? So this form of tangents to the general circle, you have to remember this procedure. Don't try to memorize the formula. Okay? Let us take a problem on this. Let us see this. Find the equation of the tangent to the circle. Just 1 minute. Yeah. So find the equation of the tangent to the circle. X square, what is given? The equation of the circle is this. Right? And it is passing through the point 8, 1. Which one is passing? The tangent is passing. Now my first question is this point on the circle? If it is on the circle, it will take few seconds to find out the equation of the tangent. But first of all, we have to check whether this point is on the circle or outside the circle or inside the circle. So for that, we have to find out the power of this point with respect to this circle. So what will be the power of that point? It's 8 square plus 1 square minus 16 minus 4 minus 20. So we are getting 65 minus 40. So 25 greater than 0. It means since the power of the point is greater than 0, it means the point is outside the circle. The point is outside the circle. Hence, we cannot use our Cartesian form. Okay, in Cartesian form, what was the criteria? The point has to be on the circle, but it is not on the circle. Okay, so this is the tangent. So we have to find out the equation of this tangent, and they have said that this tangent is passing to the point 8, 1. Okay, what is the center of this circle? The center of the circle will be 1, 2. And what is its radius? Its radius is root over 1 square plus 2 square plus 20. That gives us root 25, which gives us 5. Is it clear? Now, let us assume that the equation of the tangent is y equals to mx plus c. As the line is passing to the point 8, 1, hence it must satisfy this equation. Therefore, 1 is equals to 8m plus c, or from here you can write c is nothing but 1 minus 8m. Is it clear? So, c is nothing but 1 minus 8m. Keep it in your hand. Now, what I will do, as I told you, I will use that conception of drawing a perpendicular from the center on the tangent, which will be nothing but the radius of that circle. Okay, so let me just draw a perpendicular from the center on the tangent, which is nothing but your radius, which is equals to 5. But what is the perpendicular distance? The equation of the tangent, we have assumed this one. So the equation, I mean the distance of the line from the center on this line will be m minus 2 plus c divided by root over of m square plus 1. Okay, so this is the perpendicular length, and which is nothing but your radius 5. So from here we are getting m minus 2, and let me just replace this c by 1 minus 8m. So we are actually having minus 1 minus 7m by root m square plus 1, which is equals to 5. So let me square both sides. We are having let us open the brackets. So what we are having, I'm writing it here. So what we are having, 49m square minus 25m square, that is 24m square, plus 14m minus 24 equals to 0. So let me divide by 2. So we are having right. So 12 into 12 is 144, 19, 16 into 7, 16 into 9, I'm sorry. So it's 12m square plus 16m minus 9m minus 12 equals to 0. 3m plus 4 minus 3. So we are having 3m plus 4 and 4m minus 3, correct? So the value of m is coming to minus 4 over 3 and 3 over 4. So when m is minus 4 over 3, from this equation we are going to have the value of c as 1 minus 8 times minus 4 over 3. So that gives us 1 plus 35 over 3, correct? And when m is 3 by 4, then the value of c will be, 1 minus, so it's coming like minus 5. Is it clear? Therefore, the equation of the tangents will be y equals to mx plus c, and the other one will be y equals to mx plus c. Is it clear? Hence, the equation of the tangents are this or, okay, so we can write this thing as 3x minus 4y equals to 20. So these are the two equations of the tangents to this circle from the point 8, 1. Now it's very easy to understand that from any point outside the circle, you are going to have two tangents. Yes or no? That is why we are getting the equation of two tangents here. Is it clear to all? Absolutely. Now you have understood when the point is not on the circle, we have to follow this method to find out the equation of the tangent. But if the point is on the circle, then there is no problem of finding out the equation of the tangent to a circle because we know the shortcut method of finding out its equation. Is it clear to all? Okay, let's move for the next problem. Let's see this question. So there are 3 points P, Q and R which lie on the circle. Let me draw the diagram first. This is a circle and the points are P, Q and R. So, and PR is the diameter. So let me write this point is my P, this is R, which is alpha comma 4, and this is Q, which is 9 comma 10, right? Now PR is the diameter. PR is the diameter. This is the diameter. The tangents to C at the point Q and R. At the point Q and R, they intersect at the point S. So if I draw two tangents at Q and at R, they are going to intersect at the point which is your S. Is it clear? This point is S. Now they have said that this point S lies on the line 2x minus ky is 1. What has been said? That this point S lies on this line. So you have to find out the value of k. So how to approach this sum? If you want to know the value of k, I must know what is my point S. Because the moment I get the coordinate of S, I will put those abscissa and ordinate, that is the value of x and y in this equation, because it will satisfy the equation. And from there, eventually, we are going to get the value of k. So our main task in this problem is to find out the coordinate of the point S. Is it clear? Now, PR is the diameter. So let me do one thing. Let me join the points. Let me join the points PQ and QR. So definitely this angle is the angle in the semicircle. As PR is the diameter, PQR is the angle in the semicircle. Hence this angle will be nothing but 90 degree. And if it is 90 degree, what I will do, the product of this slope, that is the product of the slope PQ and QR will be equals to -1. What is the slope of PQ? The slope of PQ is, it's coming to 8 over 12. It's 2 over 3. And what is the slope of QR? It's our 10 minus 4 divided by 9 minus alpha. So that gives us 6 over 9 minus alpha, right? As they are perpendicular to each other, so I will say the product of their slopes will be equals to -1. So from here we can write 4 over 9 minus alpha is -1 implies 4 is -9 plus alpha. So from here we are getting alpha is 13. So if alpha is 13, the coordinate of the point R is nothing but 13, 4. Is it clear to all? So the first task, which is unknown, that is the value of alpha, we got it. Okay, so now to find out the coordinate of S, we must know the equation of SR. At the same time, we must know the equation of SQ. Because the moment we know these two equations, we can solve these two equations to get the value of S. Now, QS is basically the tangent to this circle, whose P and R are the extremities of the diameter. So what will be the equation of the circle? Equation of the circle is, by using the diametric form, we can write plus, this is equals to 0. So we are getting basically x square minus 10x minus 39 plus y square minus 6y plus 8 equals to 0. That gives us x square plus y square minus 10x minus 6y minus 31 equals to 0. So this is the equation of the circle. So what will be the equation of the tangent? What will be the equation of the tangent QS? As Q is a point which is on the circle, and we are going to find out the equation of the tangent passing through the point Q. Hence, the equation will be x into x1, the Cartesian form we will use. So it is x into x1 plus y into y1 minus 5x plus x1 y plus y1 minus 31 equals to 0. What I've done, I have used the Cartesian form. Why? Because the Cartesian form of the tangent you can find out if you know that the point is on the circle, and here the point Q is on the circle. That is why I have found the equation of the tangent QS by using the Cartesian form. So the equation of QS will be, let me just simplify, 9x and 5x minus, so it is 4x, 10y and minus 3y, so it will be plus 7y minus 45 minus 30 minus 31 equals to 0, implies it's 4x plus 7y. This one will give you 75, my 75 and 31. How much it is coming? 606, right? So minus 106 equals to 0. So this is the equation of the line of the tangent QS. Is it clear to all? Now we are going to find out the equation of, the tangent RS. Again, the point R is on the circle, so we are using the Cartesian form. So what will be the Cartesian form of the tangent RS? X x1 plus y y1 minus 5x plus x1, that is x plus 13, minus y plus y1, that is 4, minus 31 equals to 0. So let me open the brackets. So we are getting 8x plus y minus 65, 12, 31. So it's basically 8x plus y, and this is coming to 65, 31, that is 96, 96 and 12. So 108, which is equals to 0. Okay. So this is the equation of your tangent RS. Clear? Now, to find out the coordinate of S, what I will do, I will simply solve these two equations, because these are the two equations of two tangents QS and RS respectively. And if we solve it, we are going to get the value of, the coordinate of S. So let me just quickly do, let me multiply the equation 1 with 2. So we are getting 8x plus 14y minus 212 equals to 0. So let me just subtract 13y and 212 minus 108 will give us 104. So your y is coming to 104 over 13. So it's coming to 8, right? So y is your 8. So what about your x? From this second equation, 8x plus 8 minus 108 equals to 0 implies 8x is 100. So x is coming to 100 over 8. So 25 over 2. Is it clear? Therefore, the coordinate of AC is 25 over 2, 8. Now, this point is on the line 2x minus ky equals to 1. Hence, it must satisfy this. So, we are getting 25 minus 8k is 1. That implies 24 is 8k. That implies k is 3. Is it clear to all? Pretty simple sum. Pretty simple sum. Only know the basic funda, only know the formula and the tips and tricks, what I am saying every time in my lecture. So remember that and do it easily. That is why I always say that coordinate geometry part is the easiest part among all the chapters in our syllabus. Okay. So our answer is the value of k is 3. Is it clear to all? Okay. Now see, two things we are going to discuss over here. It is that the area of the quadrilateral formed by the pair of tangents drawn from a point x1, y1. Let me just draw it what they have said. There is a circle. So there is a circle and there is a point outside this circle which is your x1, y1. Clear? And what they have given you? The area of the quadrilateral formed by the pair of tangents drawn from the point x1, y1 and the radii of the circle is equals to whatever. That we will prove. So from here, from the point x1, y1, we are drawing two tangents. This is one tangent and this is another tangent. Okay, I have drawn these two tangents. Let me say this tangent, this, let us denote this point be P, and this is, let us say A, and this point is B. Okay. Now, if I join the point of contact A with the center of this circle, this will be definitely the radius. This will be definitely the radius, and this is perpendicular. Okay. We join this point also. So, what is that quadrilateral we are getting? Let the center be, let us say this is R. So we are getting the quadrilateral as PARB. Now we have to find out the area of this quadrilateral. Okay, let us say the equation of the circle be S, which is x square plus y square, 2gx plus 2fy plus c. Okay, so what is the power of the point x1, y1 with respect to this circle? It is x1 square, y1 square, 2gx1 2fy1 plus c, and the length of the tangent, which is your PA, which is same as your PB, is nothing but root over of S1. That we all know. Now let me do one thing. Let me join P and R. So we have to find out the area of the quadrilateral. We have to find out the area of the quadrilateral PARB, which is same as area of the quadrilateral PARB is same as twice the area of the triangle PAR, because these two triangles are congruent. This is 90, this is 90, this side is equals to this side, and this is the common side. So these two triangles are congruent, hence their areas are also equal. Therefore, the area of the quadrilateral PARB is same as twice the area of the triangle PAR. Now, PAR is a right angle triangle whose radius RA, this side RA is basically the radius which is R, and the length of the tangent which is PA is root over of S1. Therefore, the area of the triangle PAR is half base into height. So we are getting this thing as half r root S1. So what will be the area of PARB? It is 2 times the area of PAR, which is 2 times half r root S1. So that gives us r root S1. That's it. Is it clear? So r root S1 is basically the area of the quadrilateral formed by the tangents PA and PB and the radius r of the given circle. That's exactly what it is written over here. Okay. Now, the second part that we must remember this. Again, I'm telling you, if possible, remember. If possible, try to remember this formula. If not, then all you have to do is you have to do by the same way as I have done right now. You have to do all this workout. So that will consume your time. So it's better to remember this particular result as a formula. Okay, it's r root over S1. What is r? The radius of the given circle. What is S1? This is the power of the point x1, y1, a point which is outside the circle with respect to the given circle. Okay, so the area of the quadrilateral is r root over S1. Now, what is the second point to be noted? That the angle between the tangents drawn from the external point x1, y1 to the circle is given by this. Okay. So all we will do is we will find out, let us say this angle is theta. If this angle is theta, we will show that your tan theta, that is the angle between these two tangents, is 2r root S1 divided by S1 minus r square. And I will definitely prove this, but it is always better to remember this as a formula. Remember this result as a formula. Now see how I'm doing. I have to find out this theta. Okay, your tan theta will be this. How to do this one? You see, your this angle will be nothing but theta by 2 because your PR is going to divide the angle APB in equal half. So the angle APR is nothing but theta by 2. And please tell me, what is your tan theta by 2? From the triangle PAR, look it carefully. From the triangle PAR, your tan theta by 2 is perpendicular by base. So your tan theta by 2 is r over root S1. Is it clear? Now, what is tan theta? Tan theta is basically 2 tan theta by 2 divided by 1 minus tan square theta by 2. So simply replace the value of tan theta by 2. It's r over root S1 divided by 1 minus r square by S1. So if I simplify, we are going to have 2r s root of S1 divided by S1 minus r square. So that gives us 2r root S1 divided by S1 minus r square. And that is your tan theta. That's exactly what we have proved. Okay. So the angle between the two tangents drawn from a point outside the circle is nothing but 2r root S1 divided by S1 minus r square. That is the angle between the tangents drawn from the external point x1, y1. Is it clear? What is r? R is the radius of the circle. What is S1? It is the power of the point x1, y1 with respect to the circle given. Okay, so treat these two results as a formula. Treat these two results as a formula. If it is required, I will use this to short our time in the examination hall. Okay, so now let us take some problems on this. See this question, it's a straightforward question. Find out the angle between two tangents from origin to a circle. So I'm drawing a circle which is whose center is at 7 comma minus 1, whose center is at 7 comma minus 1, and whose radius is 5 units. Radius is what? 5 units. Okay. Now what they have said, what is the angle between the two tangents drawn from the origin? Now your origin is outside the circle. Your origin is outside the circle, and from this origin you are drawing two tangents. Is it clear? This is our origin. How we know that the origin is outside the circle? Simply find out what is the power of the point 0, 0 with respect to this circle. You are going to have 7 square plus 1 square minus 25, which is greater than 0. That is why I told you the origin is outside the circle. Clear? Now you have to find out the angle between them. What we know? We know that tan theta, if theta is the angle between these two tangents, the formula is 2r root s1 divided by s1 minus r square. So what is the radius of this circle? It is 5. And what is the length of the tangent drawn from 0, 0? So we can find out that it is under root 7 square plus 1 square minus 25. Is it clear? How I got this? 7 square plus 1 square minus 25 is the power of the point origin with respect to the circle. So root over of that power of point will give us the length of the tangent. So here we are getting it's equals to 49 plus 150 minus 25 is 25. That is 5. Okay. So what will be your tan theta? The angle between the two tangents is 2 times r root of s1, which is again your 5 divided by s1 5 minus r square. R square is 25. I'm sorry, here s1 is 25. S1 is the power of the point, which is your 25. Okay, so you can see that your denominator is coming to 0. So it is infinity. So tan theta is infinity. It implies your theta is coming to 90 degree. Okay, so the angle between these two tangents is nothing but 90 degree. Hence option D is correct. Is it clear? That is why I told you it is better to remember the formula. In this kind of problem, we can directly use the formula to get the answer very quickly. Okay, let me take another problem. See this question. In this question, they have said that the angle between a pair of tangents from a point P to the circle is given. So this is the circle, and there is a point P outside the circle. There is a point P outside the circle, and from this point P, we have drawn two tangents. We have drawn two tangents, this one, and let us say this one. Okay. So now this point, let us say this is A and this is B. And they have said that the angle between these two tangents is 2 alpha. The center of the circle, let us say C, is minus 2 comma 3, and its radius R is root over minus 2 whole square plus 3 square minus 13 cos square alpha. Okay. So we are getting actually root over minus 13 cos square alpha. So we are basically having 13 1 minus cos square alpha minus 9 sin square alpha. So this is under root 13 sin square alpha minus 9 sin square alpha. So that gives us 4 sin square alpha. So that is 2 mod sin alpha. Is it clear? So that is the radius of the given circle. Now we have been said to find out the equation of the locus of the point P. Let us say the h comma k be any point on the locus. That is the coordinate of P we are assuming at h comma k. Now we have to find out the locus of this point. How to do it? Let me join P and C, okay, as well as PA and PB. Clear? Now we can easily see that this angle, since this whole angle is 2 alpha, therefore this angle will be alpha. The radius CA is same as your radius CB, which is your 2 mod sine alpha, right? And what is your PA? PA is basically the power of the point P with respect to the given circle, which is your PA is actually the length of the tangent. So the length of the tangent is basically the square root of the power of the point P with respect to the given circle, right? The center C is minus 2 comma 3. We have to find out the locus of point P. That is, we have to find out a relation between H, K and constants. Now, if we consider the triangle PAC, then we will say that your sine alpha is basically CA over CP, because this angle is 90 degree. Yes or no? Now, what is your CP? CP is the distance between these 2 points, which is nothing but h plus 2 whole square plus k minus 3 whole square. And what is your CA? CA is nothing but 2 mod sine alpha. Is it clear? So now, in the triangle PAC, sine alpha is CA by CP. So we can write this thing as sine alpha equals to CA, which is the radius, divided by CP. Your CP is root over h plus 2 whole square plus k minus 3 whole square, correct? Now, if I square both sides, we are going to have h plus 2 whole square plus k minus 3 whole square into sine square alpha, which is equals to 4 sine square alpha. So sine square alpha goes off. So we are left with h plus 2 whole square plus k minus 3 whole square is equals to 4. So this is the equation of the locus, because this contains your h, k and the constants. So this is the equation of the locus of the point P. Thus the equation of the locus will be x plus 2 whole square plus y minus 3 whole square, which is equals to 4. Is it clear? So this is the equation of the required locus. Understood? Okay, so let us move for the next problem. The question is, a circle touches the line x equals to 0 and y equals to 0. X equals to 0 is the y-axis and y equals to 0 is the x-axis. And this is the equation of a straight line. The circle is touching both the x-axis, y-axis as well as this line. And the center is in the first quadrant. The center is in the first quadrant. Okay. So let me just draw this diagram first. The line, which is your 3x plus 4y equals to 3x plus 4y equals to 120. Okay. So now you see, you have to find out the center of this circle. We have to find out the center of this circle. Okay. Now, as it is touching the both x and y axis, let us say the center is r comma r. If the center is r comma r, then its radius is also r. As it is touching the both x and y axis, it means what? The radius will be nothing but r. Okay. Now, If I draw a perpendicular from the origin on this line, again the same funda I am using. If I draw a perpendicular from the origin on this line, it is going to intersect the circle at the point of contact, because 3x plus 4y equals to 120 is basically the equation of the tangent to the circle. And if I draw the perpendicular from the origin to this line, to this tangent, it is going to intersect the circle at the point of contact. And this distance will be nothing but the radius of the circle. So what is the perpendicular distance drawn from the center on the given line? Minus 120 divided by root over of 3 square plus 4 square, and which is equals to the radius of the circle. So from here we are getting 7r minus 120 divided by 5 is equal, modulus of this is equals to r. Okay, so from here we are getting 7r minus 120, which is equals to, if you square both sides, you are going to have 25 r square, right? So which can also be, don't expand it, don't expand it, do some smart work. So it's 5r square is 0. So if I use the formula a square minus b square, we are going to have a plus b, a minus b, which is equals to 0. So from here we are getting 12r minus 120 into 2r minus 120 is 0. So either your r is, or your r is 120 over 2, that gives us 60. Is it clear? Therefore, the center of this circle will be at either 10, 10, or it can be at 60, 60, because two values of r we are getting. And we can easily see from the diagram also that fulfilling this condition, that it is touching the x and y axis as well as this line, we are going to have two such circles. One is the circle which is shown here, and another circle will be somewhere here, which is touching the y-axis as well as, my diagram is not perfect, but you can understand. It is going to touch this line as well as it is going to touch this line, and that circle will be formed. So that circle will have its center at 60, 60, and this circle is having its center at 10, 10. So two such circles in the first quadrant are possible. Is it clear? Hence option A and B are correct. Okay. So let me just check. Yeah. Is this question clear to all of you? Absolutely? Okay. Now, see this question. The question is, let the tangents at 2 points A and B on the circle this. So there is a circle. There is a circle. Let me draw it first. A circle is there, whose equation is x square plus y square minus 4x plus 3 equals to 0. Okay. So before doing anything else, first of all, I will find out what is its center and what is its radius. The center we can easily find out. It is basically 2, 0, and the radius will be root over 2 square plus 0 square minus 3. So that gives us 1. So radius is 1, center is at 2, 0. Now, there are two tangents drawn at the points A and B to this circle, which meet at the origin. Now, my question is this origin on the circle or outside the circle or in the circle? So we have to find out the power of this point. So we can easily see that the power of this point, the origin, is coming to what? Which is 3 greater than 0. It means that the origin is outside the circle. Okay, so origin is somewhere outside the circle, and let me draw two tangents which are intersecting at the origin. Is it clear? So this is my origin 0, 0, right? Now we have to find out the area of the triangle OAB. We have to find out the area of the triangle OAB. What is A and B? A and B are the two point of contacts on the circle. So now we have to find out the area of OAB. How to do that? Okay, so for that, let me do one thing. This is my center. So from the center, again, the same rule I am doing. I'm joining the center with the point of contact. So they will be the radius. And let me join the center of the circle. Let me denote the center of the circle with C and the origin. Okay. So now you have to find out the area of OAB. Now, one thing for sure, that your triangle OA, let me give a name of this point. Let us say this is P. Now, let us say the angle between the tangents be 2 alpha. Okay. So, this angle will be alpha because we all know that the line joining the point which is outside the circle and the center of the circle is going to divide the angle between the tangents into 2 half. So this angle will be your alpha, right? What is your OA? What is your OA? OA is basically the length of the tangent, which is nothing but root over of S1. So that is root of 3. So OA, which is same as your OB, OA is root 3. So this length is root 3. And the radius of the circle we have calculated, that is 1. Therefore, if we consider the triangle OAC, you are getting your tan alpha is nothing but 1 over root 3, perpendicular by base. So from here we can write that your alpha is nothing but 30 degree, right? If alpha is 30 degree, then 2 alpha will become 60 degree. That is, the angle between these two tangents is 30 degree. Is it clear? Now, if you consider the triangle OAB, we can easily see that this angle, the angle between them, between the tangents, is 60 degree, and OA and OB, they are of equal length, which is of root 3. Therefore, area of the triangle will be half into the product of the two sides, which is your root 3 into root 3, that is OA into OB, into sine of the angle between them. From the properties of triangle, we know that for any triangle, if you know two sides, suppose if I know AB and BC, then the area of the triangle, and if you know that the angle between these two sides is theta, then the area of the triangle is always half into the product of two sides into sine of the angle between them. So that's exactly what I have done for the triangle OAB. OA and OB we know, and we know the angle between OA and OB, which is pi by 3. So we have applied this formula for finding out the area of the triangle OAB. So it is coming to 3 over 2 sine 60 degree. It's root 3 by 2. So answer is 3 root 3 over 4. Is it clear to all? So the area of the triangle OAB is 3 root 3 over 4. Hence option B is correct. Is it clear now? Option B is correct. Okay, let us move for the next problem. See this question. The question says that from a point P on the line 2x plus y plus 4 means there is a line. There is a line, and on this line there is a point P. Okay, the equation of this line is 2x plus y plus 4 equals to 0. Which is nearest to the circle? Okay. Oh, one circle is given to us. One circle is given to us, and they have said P is such a point which is nearest to this circle. Now, where does this P lies? Can you tell me? If this P is nearest to the circle, then where should this point P lies? Point P is such a point that if you join that point with the center of the circle, if you join the center of the circle with that point, this line will be perpendicular to the given line. If it is so, then you will say that this point P is nearest to the circle, right? So your CP is perpendicular on the line given, right? And the equation of the given circle is, so what is its center? Because the moment I get the equation of the circle without thinking anything else, I find out two things. One is what is the center and what is the radius. So you people will also do that. So what is the center? Center is 0,6, and what is its radius? I don't know whether it will be required or not, but yeah, I always find out that thing first. Minus c. So it's coming to 1. So radius is 1 and the center of this circle is 0,6. Now let us read the question. Now, which is nearest to the circle? Okay. Tangents are drawn to the given circle. So from the point P, you are drawing the tangents. This is one tangent and this is another tangent. Is it clear? These are the two tangents I have drawn. Let us say these 2 points are A and B, which is also given to us. Okay. Now you have to find out the area of the triangle PACB. Okay. So we have to find out the area of the quadrilateral PACB. That's it. Is it clear to all? Is this question clear to all of us? Okay. Now the question comes, how to do it? What is this point P? Let us say this point P is lying on this line. Point P is lying on this line. So from this line we can say y is minus 2x plus, minus 4. So if your x is alpha, then your y will be minus 2 alpha minus 4. This is any point on this line. Let us assume this is my point P. Yes or no? This is my point P. Now what is the slope of PC? 6 minus 2 alpha y2 minus y1 divided by x2 minus x1. So it is coming like 2 alpha plus 10 over minus alpha. Is it clear? So this is the slope of PC. Now what is the slope of the given line? The slope of the given line is minus 2. And as we all know that they are perpendicular to each other, so we will say that 2 alpha plus 10 over minus alpha into minus 2 is basically minus 1. Okay, since PC and this line, they are perpendicular to each other, so product of their slopes will be equals to minus 1. So what we are getting? 4 alpha plus 20 is minus alpha. So that gives us 5 alpha is minus 20. Alpha is minus 4. So what is the point? The point is nothing but minus 4, 8 minus 4, which is nothing but our minus 4 comma 4. So what is the required point P? P is nothing but your minus 4 comma 4. Is it clear? So one task is over. We found what is that point P lying on the given line which is nearest to the circle. That we found. But we have to find out the area of the quadrilateral. And we all know that the area of the quadrilateral, just now we have learned the formula is R root S1. Can you remember? What is the area of the quadrilateral formed? It is R into root S1. What is R? R is the radius of the circle. What is root of S1? This is the length of the tangent, where S1 is the power of the point with respect to the circle. So in this case, in our problem, please see, we have to find out the area of the quadrilateral PACB, which is nothing but your R into root S1. So what is R? R I got, which is equals to 1. So the area will be 1 into root S1, which is nothing but root of S1. That is, we have to find out the length of the tangent PA or PB. It's all same. So what is the length of the tangent PA? The point outside the circle is -4, 4. So find out the power of the point S1, which is nothing but S1 equals to 16 plus 16 minus 48 plus 35. So we are actually having 16 plus 16 is 32 minus 48 plus 35. So we are having actually minus 16 plus 35. That gives us 19. Okay. So this is the power of the point P with respect to the given circle. Therefore, what is the length of the tangent? It's root 19, and which is nothing but the area of the quadrilateral PACB. Am I correct? Hence, option C is correct. Have you understood? If you remember the formula, how easily you can solve a problem. Directly use that property, because several times in JEE Mains, the questions based on the area of this quadrilateral came. That is why I told you to remember this as a formula. R root over of S1. Two things you have to remember: the area of this quadrilateral formed and the angle between these two tangents, which we have already learned. What is that? 2R root S1 divided by S1 minus R squared. That is your tan theta. And theta is the angle between these two tangents. So these two results, please do remember. Area of the quadrilateral is R into root S1 and the angle between the tangents is this one. Okay. So our answer is option C. Yes. Clear? Now, let us come to the last part of this lecture, which is called your director circle. What is your director circle? We have already done a lot of sums on tangents. I hope you people are clear with this conception of tangents, not only the definition, but also how I'm approaching to solve a problem given in tangents, right? Now we are coming for the director circle. What is the director circle? Now don't read this, I'm telling you. The thing is that suppose there is a circle, and from a point outside this circle, you have drawn two tangents. Suppose this is one tangent, and let us say this is one tangent. Okay. So from this point outside the circle, you have drawn two tangents. Now the question is, if the angle between these two tangents is 90 degrees, that is, they are perpendicular to each other, then what will be the locus? What will be the locus of this point? The locus of the point P is what called your director circle. Is it clear? So in a circle, you have drawn two tangents and the angle between the tangent is 90 degrees. If it is so, then what is the locus of the point P? The locus of point P will be nothing but a director circle. It is called director circle. What will be the equation of the locus? That I will be coming. But first you understand the definition. When the locus of the point through which if you draw two tangents, the angle between the two tangents is 90 degrees. Then the locus of point P is what called your director's circle. And this director's circle you will find out the same definition is applied for parabola, for ellipse, for hyperbola, for everyone. So remember the definition. Clear? So now I will find out what is the locus of point P. The angle between them is 90 degrees. Let us say the equation of this circle be x square plus y square equals to a square. I am taking the standard one. You can take the general form also. Doesn't matter. So now this is the equation of the circle. And we know that from a point P, let us say the point be h comma k. H comma k is any point on the locus. From any point P outside the circle, if you draw the tangents, the angle between these two tangents will be, just now we have learned, tan theta. If this angle is theta, then this angle is theta. Then tan theta is, we have learned the formula, 2r root s1 over s1 minus r squared. Now they have said that this, according to the definition, this angle theta is 90 degree. If it is 90 degree, so tan 90 is coming to undefined. So which is true only when the denominator is equals to 0. Then only this result will give us undefined. So s1 minus r square is 0. What is s1? S1 is the power of the point P with respect to the circle, which in this case is nothing but h square plus k square minus a square. And what is r? R is the radius of this circle, which is nothing but your a over here. So it is a square equals to 0. So the equation of the locus is h square plus k square equals to 2a square. Thus, the equation of the locus is what? X square plus y square equals to 2a square. And that's the equation of the director circle. Is it clear? This is the equation of the director circle. Right? Now, can you observe one thing? The given equation was x square plus y square equals to a square, and the director circle we got it as x square plus y square equals to 2a square. Yes or no? So now we can easily see that the given circle and the director circle, they are concentric. That is why I have written director circle is always concentric with the given circle. And the radius of the circle, of the given circle, is a. But the radius of the director circle, look at carefully. The radius of the director circle is what? It's root 2 times the radius of the given circle. That's exactly what I've written. Its radius is, it means the radius of the director circle is root 2 times the radius of the given circle. Is it clear or not? So if I tell you that, suppose we have taken, let us say, x square plus y square is say 100. So if I ask you, okay, find out the equation of the director circle. So what I will do, it is the concentric circle with this circle, right? Concentric circle. But the radius will be root 2 times the radius of this circle. The radius of this circle is 10. Is it clear? Therefore, the equation of the director circle will be what? It will be x square plus y square equals to root 2 times the radius of the given circle. So it will be x square plus y square is 200. That's it. This is the equation of the director circle. So what we have learned? What is the director circle? The locus of the point of intersection of perpendicular tangents to a circle is called a director circle. And the equation of the director circle is It is always concentric with the given circle, and its radius will be root 2 times the radius of the given circle. That much you have to remember. Okay, let me take a problem. See this question, what they have said. They have said find the locus of the point of intersection of two perpendicular tangents. The locus of the point of intersection of two perpendicular tangents to the circle x square plus y square equals to 25. Now, how the tangents will be? These two tangents will be perpendicular to each other. Means the locus of the point of intersection is guaranteed is going to give us the director circle. And the director circle will be concentric with this circle. So its locus will be x square plus y square equals to root 2 times the radius of the given circle. The radius of the given circle is 5. So it will be root 2 times 5 whole square. This is what? This is the locus of the given point. Or we can say this is nothing but the equation of the director circle. Why it will be a director circle? Because the tangents are at right angles. That is why it will be a director circle. So its equation will be x square plus y square equals to 50. That's it. One line sum. If you know that two perpendicular tangents, the locus of the point where the two perpendicular tangents are meeting is nothing but the director circle, and the equation of the director circle is same as the equation of the given circle because it is concentric with that circle, and its radius will be root 2 times the radius of the given circle. That's it. Okay, so the locus of the required locus is nothing but the director circle whose center is whose equation is x square plus y square equals to 50. Let me take another example. The question is the tangents are drawn from any point on x square plus y square equals to 20. Okay, let me draw a circle first. So there is a circle whose center is at the origin and radius is root 20. Okay, its radius is root 20. Now there is another circle x square plus y square equals to 10. So again it will be a concentric circle. So it is going to come somewhere here, right? Okay. So this equation is x square plus y square equals to 20, and this equation is x square plus y square equals to 10. Now we can see that the radius of this circle is root 10. Okay. Now what they have said, now tangents, you take any point on this circle, on the outer circle, and draw tangents to the inner circle. Draw tangents to the inner circle. So I have drawn tangents to the inner circle, right? And the question is, what is the angle between these two tangents? That's the question. Now here I don't need to do anything. Only by inspection you can say what will be this angle. The radius of the outer circle is basically root 20 whole square, which can also be written as root 2 into root 10 whole square. And the radius is nothing but root 2 times the radius of the given circle. Getting my point? So this circle is nothing but, this is basically the equation of the director circle. And this is the given circle. Okay. Now, as this is a director circle, so I'm sure that the angle between these two tangents will be nothing but 90 degree. See, I have done nothing. Only by inspection, you can say what will be the angle between these two tangents. Is it clear? If it is root 2 times the radius of the previous circle, I mean the given circle, then this locus is the director circle. That is the angle between the tangents is 90 degree. That's it. That's exactly what we have done here. Therefore, the required angle between the tangents is 90 degree. Is it clear to all? So I hope you have all understood this class. If not, please do replay this video and see this one, so you will be comfortable with the theory part that we have gone through, mainly the conception of tangents that we have covered here. So see you in my next class. Till then, stay tuned to us, and if you have not subscribed my channel, please do subscribe and share it and like it. Thank you so much. I'm going to start with the third class on circle. I hope you have all seen my previous two lectures, which is in the playlist circle in my channel. So I hope you people are now comfortable with the basic part of circle. So now let us advance our journey, and in this session we are going to cover the following subtopics. First, we will discuss about the conceptions that we have already discussed in our previous two lectures. After that, we are going to start with normal to the circle, then chord of contact, then all this relation I'm not going to explain you right now. The moment it comes, I will explain in detail. So ready for the journey? Okay, so let me just give you a little glimpse of the previous class that we have done. Here we have done the intercepts made on the coordinate axis. I told you that all these things I have discussed in detail in the previous videos. Those who have not seen those lectures, you are advised to please see those lectures first, and then you come to this. So the x-intercept of the circle and the y-intercept of the circle are respectively 2 root over g square minus c and 2 root over f square minus c. Here we are actually considering the general equation of a circle. So in this general equation, the circle, when intersecting the x-axis, the intercepted length, suppose this is the circle, the intercepted length on the x-axis is basically 2 root over g square minus c. And at the same time, the intercepted portion on the y-axis is 2 root over f square minus c. Now, when g square minus c is greater than 0, then the circle is intersecting the x-axis at two different points. If g square minus c is equals to 0, then it is touching the x-axis. It is touching the x-axis. There is no intercepted portion of the circle with the x-axis. And when g square minus c is less than 0, then it is not intersecting the x-axis. Neither it is not touching. Okay, how this formula came, these two formula came, I have already discussed in the previous lecture. So I'm not going to discuss anymore here. So now the same thing with the y-axis intercept. If f square minus c is greater than 0, it is intersecting the y-axis at two different points. If it is equals to 0, it is touching the y-axis. And if f square minus c is less than 0, then it is not intersecting nor touching the y-axis, right? And we have already discussed about the combination of those 6 results. Again, I'm mentioning, if you have not seen that video, you are advised to see that lecture first. Then you come to this lecture, you will be comfortable with this one. Okay, so next thing that we have covered is that when the circle is touching the x-axis, this is again for the for the general equation of the circle, 2fy plus c equals to 0. So in this case, the radius is root over g square plus f square minus c. Now, when the circle is touching the x-axis, just now we have said that in that case, your g square minus c will be equals to 0. So from here we can get the radius in that case will become g square minus c is 0. So it will be only f square. So which gives us only mod of f. So that exactly what is written over here. The same thing with the y-axis. In that case, when the circle is touching the y-axis, its radius will be mod of g. And when the circle touches both the axes, then your radius will be either mod of g or mod of f. And its center will be always plus minus r comma plus minus r. Why it is so? Because this case can occur in 4 cases. This situation can occur in 4 cases depending on where the circle is. If it is in the first quadrant, the center will be r comma r. If it is in the second quadrant, the center will be minus r comma r, and so on so forth. That is why I have written this situation will occur in, this situation will occur in 4 cases. That is why your center is to be considered like plus minus r comma plus minus r. Until and unless they mention whether it is in the first, second, third or fourth quadrant. Accordingly, we will take the center. If nothing is said, we will take the center as plus minus r and plus minus r. Is it clear to all? Okay, so the next thing that we have already covered in lecture 2 is maximum and minimum distance of a point from a circle. The point is P. The point is P. I have already considered 3 cases. These are the 2 cases in this slide. And in the next slide, we are having that P is on the circle. In the previous 2 classes, cases, your P is inside for the first case and P is outside for the second case. And for the third case, your P is on the circle. So in all these 3 cases, your minimum distance is always equals to modulus of Cp minus radius, and your maximum distance is always Cp plus radius. Please do remember this. Okay. So irrespective of the point P, the position of point P, the minimum distance of the point from the circle is always Cp minus radius. Now what is C? C is the center of the circle and P is the given point. Okay. So minimum distance is modulus of Cp minus radius and maximum distance is Cp plus radius, irrespective of the position of the point P. And this all proof I have already done. Okay, so next thing that we have covered there is the position of a point with respect to a circle. So when there is a circle, the equation of the circle is this. And what is S1? I have given you one point x1, y1. Now I am simply putting this point in this given expression of the circle equation. Now we got that thing, we denote it by S1. And this S1, if greater than 0, we say that the point x1, y1 is lying outside the circle. If S1 is equals to 0, then we say that the point is lying on the circle. And if S1 is less than 0, we say that the point is inside the circle. Okay. Now this S1, it has a special name which is called power of a point. Power of a point x1, y1 with respect to the given circle, in this case S equals to 0. So in that case we write S1 is nothing but the power of a point. So in the previous thing that we have done right now is of finding out whether the position of a point given is outside, on or inside the circle. We will say in this way that when the power of the point is greater than 0, it is outside. The point is outside. If the power of the point is equals to 0, it is on the circle. And if the power of the point is less than 0, it is inside the circle. Is it clear? So this S1 is nothing but the power of a point. And what is the length of the tangent drawn from this point on this circle? what is the length of the tangent drawn from this external point to this circle? The length of the tangent is square root of the power of the point. Again, I have proved this, how it is coming in the previous lecture. So the length of the tangent is nothing but root over of the power of the point. Is it clear? So this is the length of the tangent. Next, we have learned the various forms of tangents. For the slope form of the tangent, I have already shown you that when y equals to mx plus c is a tangent to a circle x square plus y square equals to a square, in that case the condition is c square equals to a square into 1 plus m square. So c can be written as plus minus a into root over 1 plus m square. Therefore, the equation of the tangent in slope form is written as y equals to mx plus minus a root over 1 plus m square. This is the Cartesian form of the tangent. The standard circle is x square plus y square equals to a square. As I told you that to find out the Cartesian form of the tangent, you simply write this x square as, replace x square as x1 plus y1, y square as y1 equals to a square. And this will be the equation of the tangent. But here one thing you must remember, repeatedly I told you in the previous lecture, that the point x1, y1 is on the circle. Then only you can find out the equation of the tangent by using Cartesian form. If the point is not on the circle, then you cannot use Cartesian form of tangent. Is it clear? Okay. Next is the parametric form. We know that for the standard circle, any point on the circle is a cos theta, a sin theta. As this is any point on the circle, hence, if you want to find out the equation of the parametric form of the tangent, I can simply replace this x1 and y1 by these 2 points a cos theta and a sin theta. So in that case, we are going to have the parametric form as this, right? Okay, now let us consider the general circle. It is x square plus y square plus 2gx plus 2fy plus c equals to 0. As I mentioned in the previous lecture again, for this case, you don't have to remember any formula. To find out the slope form of the tangent, use the conception that the perpendicular distance from the center of the circle is always equal to its radius. And I have already done a lot of sums based on this in my previous class. Again, what is the Cartesian form of the tangent? The Cartesian form will be this. Again, you don't have to remember this. The best way to remember is you replace x square by x1. Just now I told you. Y square by y1. 2x you will replace by x plus x1. 2y will be replaced by y plus y1. And you will get the equation of the circle. The equation of the circle is the general circle. So for that, the Cartesian form will be x1 plus y1 plus g times x plus x1 plus f times y plus y1 plus c equals to 0. Don't touch other constant in the given equation. Right? So this is the way of remembering the Cartesian form of the tangent. Again, x1, y1 is a point which is lying on the circle. Otherwise, you cannot use Cartesian form of tangent. Remember that. Now, for the parametric form, for any general circle, we know that the parametric form is any point on the circle is minus g plus r cos theta and minus f plus r sin theta, where r is root over g square plus f square minus c. So now, as these 2 points are on the circle, so to find out the parametric form of tangent, I will simply replace x1, y1 by these 2 values. Okay, so I will directly get the parametric form of tangent. So again, I'm telling you, for the general circle, you don't have to remember any formula. You simply remember that tips and tricks that I told you, you can find out the tangent instantly. Okay, and at the same time, we have done a lot of sums in the previous class based on tangents. Okay, so the next thing is that we have shown this one. Again, I have proved this. I have proved this. There is a circle. Now there is a point outside the circle and we have drawn two tangents. So if this is the center, let me just join these two. So the quadrilateral that is forming, let us say the ABCD be the quadrilateral. The area of the quadrilateral is R into root over of S1. R into root over of S1. What is R? R is the radius of this circle. And what is S1? S1 is the power of the point A with respect to the circle. So that will be the area of the quadrilateral ABCD. Please do remember this. Okay, as I told you, it will make the problem easier. And if you don't remember, then the method that I've shown to prove this one, you have to adopt that method to solve that question. But it will take a long time. Okay, and the angle between these two tangents is nothing but tan theta equals to 2r root S1, 2r root S1 divided by S1 minus r square. Again, r is the radius of the circle and S1 is the power of the point A with respect to the circle. Is it clear now? So we have to remember these two things I have already mentioned. So next thing that we have done in the previous class was the director circle. What is the director circle? If you have a circle, and by the way, let me just tell you, after the class, you will get this PDF. The link will be given in the description box. So now, the locus of the point of intersection, from the point outside this circle, I can draw two tangents. Now, if the angle between these two tangents is 90 degrees, that is, they are orthogonal, then the locus of this point is nothing but the director circle of the given circle. Okay? And we have learned that the director circle is always concentric with the given circle and its radius is always root 2 times the radius of this given circle. If the radius of this circle is A, then the equation of the, suppose the equation of this circle is x square plus y square is a square. So the radius is A. So the equation of the director circle will be x square plus y square equals to 2a square. Why it is so? Because it is the radius of the director circle will be root 2a whole square. That is, the radius of the circle is root 2 times the radius of the given circle. This already I have discussed. Okay. So now let's start with our new topic for today's class is what called your normal to circle. What is normal to circle? Suppose if I take a circle, let me just draw the circle first. Okay. Now this is the circle and let us say this is a tangent. Okay. So now what I'm doing is the definition of normal is if you draw perpendicular on the tangent, that is not a normal. Hello? That is not a normal. Don't say in this way that the normal is always perpendicular to the tangent. No, this is wrong. Wrong definition. The definition is the line which is perpendicular to the tangent. That's true. But at the point of contact, if you draw a line which is perpendicular to the tangent, then this line is what called your normal to the circle. This is the normal to the circle. And remember one thing, that only for the circle, not for the other conic section, only for the circle, the normal always passes through the center of the circle. Is it clear? So what is a normal? A normal is a line which is perpendicular to the tangent at the point of contact, and the normal always passes through the center of the circle. Right? Absolutely clear to all? Okay. So now let us just take some problems based on that. See this question. The question is, find out the equation of a circle whose two normals are represented by this equation. Whose two normals are represented by this equation. Okay? Means this is a combined equation of two normals. This is the combined equation of two normals. Okay? And they have said that their circumference is, the circumference of the circle is 14 pi. Okay. Now what we have to find out? We have to find out the equation of the circle. Now we all know that to find out the equation of circle, we need two things. बार बार ये चीज हमने बोला है, for any circle to find out its equation, you need two things. One is its center. Find out its center, and then you find out its radius. Everything is over. The moment you know the center and radius of a circle, you know the equation of the circle by using center radius form. Is it clear? So whenever they are asking for to find out the equation of the circle, you simply try to find out its center and radius. Nothing else should come in your mind. Okay, so first of all, what is given? That this is the combined equation of two normals. So let me just simplify this. Let me just factorize this to get the equation of the normals. So we got something like this. Now observe one thing. These are the two equations of the normals. One is this and the other one is this. Now tell me one thing. When two normals, where two normals of a circle intersect, where two normals of a circle intersect. Now, just now I told you that all the normals passes through the center of the circle. So, if these are the two normals of the same circle, then definitely they are going to meet at the center of the circle. So, what will be the coordinate of the center of this circle? It's nothing but the point of intersection of these two normals. So if I solve these two equations, we are going to get the center of the circle. Am I correct? Okay, so now if I solve this, we are getting x as 5. And from here we are getting x as 5y. So that implies y as 1. Is it clear? Therefore, the center is at 5, 1. Now the question comes, what is its radius? Because I want to find out the radius also to find out its equation. Now for that they have given the second condition that the circumference of the circle is 14 pi. It means if I say that the radius is r, then we will write the circumference of the circle is 2 pi r, which is equals to 14 pi. So from here we can write that your r is nothing but 7. Am I correct? R is nothing but 7. So now you know the center, you know the radius, so you know the equation of the circle by using the center radius form. So the equation becomes, is it clear now? You can open the bracket, that's a separate question. But the thing is that this will be the equation of the circle. Now, how I have done this sum? Again, first I got its center because I have to find out the equation of the circle. So for that I need two things. One is center, another one is its radius. And they have given us two normals. We know that normals always intersect at the origin. At the center. Normals always intersect at the center of the circle. So I have solved these two normals to get the center. And to find out the radius, they have given us a second condition, that its circumference is 14 pi. So from there, I got its radius. And right after getting its radius, I got its equation by using center radius form. Is it clear? Okay, so the answer is this. Clear to all? Let's move for the next problem. The question is, if the straight line ax plus by plus 2, okay, a and b are not equals to 0, that they have said, touches the circle this and is normal to the circle this, then the question is find the value of a and b. Okay. So this line, this given line is tangent to this circle and normal to this circle. So for that, let me draw two circles first. One is this circle, let us say, and another one is, let us say, this circle. Okay. Now, this line, the line which is given with a and b unknown, this is the tangent for the first circle and is normal to the second circle. Try to understand it. Okay. So this is what? This is tangent to this circle. Which circle? X square plus y square minus 2x minus 3 is 0. So what is its center? Its center is 1, 0. And what is its radius? Is root over of 1 square plus 0 square plus 3. So that gives us 2. Right? Now, this line, what is the equation of this line? It's ax plus by equals to 2. This line is normal to this circle. This circle, the equation of this circle is it clear? What is its center? It's 0, 2. And what is its radius? Its radius is root over 2 square plus 6. That gives us root 10. Is it clear? I always, whenever a circle is given, I always find out its radius and center. Because whether, I don't know whether it will be required or not. But first of all, my task is to find out that. Now, the question is, you have to find out the equation of this line is given, but we have to find out the value of a and b. So there are two unknowns. If there are two unknowns, so definitely I need two equations to solve for it. Okay. Now, one thing I can easily see, that since it is, this line is a normal to this second circle, so definitely it is passing through its center. So the coordinate of the center must satisfy the equation ax plus by equals to 2. So if I put x is 0 and y is 2, we are getting 2b is 2 implies b equals to 1. So straight away I got my b equals to 1. Okay. So one unknown we have known. Now we have to know the second unknown, which is your a. For that, I will use this same property as I have discussed. Whenever there is a tangent, all I will do is I will simply join the center with the point of contact. And when you join the center with the point of contact, this will be the radius of that circle. What is its center? Its center is 1, 0. So what is the perpendicular distance from the center on the tangent? It's a plus 0 minus 2 divided by root over of a square plus b square. This is the perpendicular distance from the center of the first circle on the tangent, and which is nothing but your radius. The value of b we got as 1. So it is coming like a minus 2 divided by root over of a square plus 1, which is equals to 2. So now let me square both sides to get the value of a. A minus 2 whole square is 4a square plus 1. So a square minus 4a plus 4 equals to 4a square plus 4. So let me just cancel 4 from both sides. So we are getting 3a square plus 4a equals to 0 implies a times 3a plus 4 equals to 0. Therefore, either your a is equals to 0 or a equals to minus 4 over 3. But in the given condition, they have already said that a is not equals to 0. Therefore, we are rejecting this value. Thus, the value of a is minus 4 over 3 and the value of b is 1. Is it clear to all? So, the value of a is minus 4 over 3 and b as 1. Okay, I hope you have understood this problem. Pretty simple one. Only I have applied the basic funda of normal. That a normal always passes to the center. And what we have used here, the very basic property again. Whenever I find tangent, I always join the point of contact with the center. Then this length is always, I find out the perpendicular length, and this length is always equal to the radius of the circle. Simply by using these two properties, I have done this sum. Is it clear? Okay. Now let us come to this problem which came in JEE 2019. The question is the tangent and normal lines at the point root 3, 1 to the circle x square plus y square equals to 4. So let me draw the circle first. So one circle is there whose radius is 2 and center is at origin. Okay, center is at origin and radius is 2. And they have said that a tangent and normal lies at the point root 3, 1. Just 1 second. Let me just do it little neatly. Okay. So let me just draw a line first in a proper way. So this is the line, and let us say I have drawn a tangent over here. I have drawn a tangent over here. Okay. So if it is a tangent at the point of contact, this is the point of contact. And this point is nothing but root 3, 1. We can easily see that root 3, 1 actually is lying on the circle, right? Because it is satisfying. So this length is nothing but, its radius, which is equals to 2. Yes or no? This is basically the radius. And this is the circle whose center is at origin and radius is 2. So it is basically this circle. I have to draw it because they have said that the triangle formed with the x-axis. So I have to do it. So well, this is the tangent and definitely this is the normal, right? This is the normal. Why? Because it is perpendicular to the tangent, hence it is normal, means it is passing through the center of the circle. In this case, it is the origin. Now they have said that this tangent and normal form a triangle with the x-axis. That we can easily see. Can't we see that? This is the triangle which is formed. This is the triangle which is formed by the tangent, normal and the x-axis. The question is you have to find out the area of this triangle. As simple as that. As simple as that. So how to find out that? How to find out the area of this triangle? See, there are a lot of ways of doing this sum. Lot of ways are there. But the easiest method which I feel is that you simply find out the equation of the tangent. You find out the equation of the tangent at root 3, 1. So as this point is on the circle, so I can apply the Cartesian form. So it will be root 3x plus y equals to 4. So this is the equation of the tangent. Clear? Now, where it is touching the x-axis, so simply put y equals to 0. So from here we are getting that x is nothing but 4 over root 3. Therefore, this point, the coordinate of this point will be 4 over root 3, 0. Am I correct? So what is this length? What is the length of the base of this triangle? It is 4 over root 3. This is the base. And what is the height? What is this height? As this point is root 3 comma 1, therefore this height will be nothing but 1. So what will be the area of the given triangle? It is nothing but half into base into height. So that gives us what? 2 over root 3. That's it. That's it. That's the area of the triangle formed by the tangent and the normal and the x-axis. Hence option C is correct. Is it clear? See, I have done nothing. I have done nothing. The moment you draw the figure, you can easily understand what you have to do. Here we can see that a triangle is forming and we have to find out the area of the triangle. So without thinking anything else, we know that the area of the triangle is always equals to half into base into height. Height I know, this is 1. So base I have to find out. So for that I got the equation of the tangent and then I saw where it is intersecting the x-axis. So now I got the length. Is it clear? So that way you can do it. Or you can do it in another way also. You can find out the slope of this normal. You will get this angle. The moment you see this angle is 90 degree. What will be this angle then? This angle will be the slope of the normal, which is nothing but 1 over root 3. That's your tan theta, if this angle is theta. So your theta is coming to what? 30 degrees, right? If this is 30 degree, this is 90. So this angle will be 60 degree. So now by using this triangle, you find out what is the length of this base. And using this triangle, you find out what is the length of this. Add these two to get the base. So now you know the base, you know the height, you can find out the area. There are a lot of ways of doing this sum. But I think it is better way to do it. Is it clear? Okay. So let me just reveal the answer. Yeah, it's C. Okay, let us move for the next problem. See this question. It came in 2023. What is the question? They have said that there are two tangents drawn to a circle. There are two tangents drawn to a circle. Let us say this is the circle and two tangents are drawn. Two tangents are drawn. Let us say this is my one tangent and let us say this is my other tangent. Okay, that's the thing. Then what they have said, this point is A, which is your 4 comma minus 11, and this point is B, which is your 8 comma minus 5. Is it clear? These are the 2 points on the circle. What is the circle? The circle is x square plus y square minus 3x plus 10y minus 15 equals to 0. So what is its center? As I told you, I always find out the center and radius. So the center will be 3 by 2 and minus 5. Okay. And what is its radius? Root over 9 over 4 plus 25 plus 15. So it's coming like root over 9 over 4 plus 40. So it's coming like root over of 169 over 4. So that's coming like 13 over 2. So that's the radius of the circle. Now what's the question? The question is, these two tangents intersect at the point C. So this is my point C. Then the radius of that circle whose center is C, listen it carefully, whose center is C, and the line joining A and B, that is this line, just 1 second. This line is basically what? It is the tangent to the circle. It is the tangent to that circle. Which circle? The circle having the center at C. Are you getting my point? So the circle is this. It is having its center at C. It's having its center at C, and AB is the tangent to this circle. Now, what is required to find out? You have to find out the radius of this circle. You have to find out the radius of this circle, right? Now, as you know, the equation of the given circle, this is the given circle, whose equation is this. And you know that point A is on this circle. So, can you find out the equation of the tangent AC? Yes. How? By using Cartesian form, it will be, am I correct? So, if I multiply with 2, what you are getting? 8x 22y minus 3x minus 12 plus 10. So, it will be 10y minus 110 minus 30. So, you are basically getting what? 5x minus 12y, and then we are having 30, 42, 52, 152 equals to 0. So, this is the equation. This is the equation of AC. This is the equation of AC, right? Okay, so can we find in the similar way the equation of the tangent BC? Yes. How? This point is on the circle, so I can use the Cartesian form in the same way. Let me just use it. X1 minus 5y, 3 by 2x plus 8 plus 5, y minus 5 minus 15 equals to 0, right? So it's 16x, 10y, 24, 10y, 50, 30, right? So you are getting 16, 13x. Oh, this y goes off. Fantastic, fantastic. So it's coming like 13x, then we are having 104. So directly we are getting x as 104 divided by 13, that is coming to 8. Okay, so x is 8. This is basically the equation of, this is x equals to 8 is basically the equation of BC. Okay, so now you got the equation of AC. Now I got the equation of BC. Now if I solve this too, if I solve this equation and this equation, we are going to get the center of the new circle or the formed circle, okay, whose center is at C. So what will be the values of x and y or the coordinate of C? Let me solve these two equations. If I put x equals to 8 over here, we are getting 12y equals to 40 minus 152. So that gives us 112 minus 112. So y is coming to minus 112 over 12. Am I correct? Am I correct? So if we cancel it, we are getting minus 28 by 3, right? Therefore, the coordinate of C is, what? Coordinate of C is minus, I'm sorry, 8 minus 28 over 3. That's it. That's the center of the circle, of the formed circle whose center is at C. Clear? Now, I have to find out its radius. Now, this AB, what is equation of AB? What is equation of AB? Simply use 2-point form. So we are getting simply cross multiply. So 3x minus 2y is equals to 34, right? So this is the equation of AB. Now, if you want to find out the radius, what I will do, I will simply draw a perpendicular on the tangent, and that will be the radius of the circle. Clear? So the perpendicular will be drawn from the center of the circle, whose center is at C, and whose coordinate is 8, comma, minus 28 by 3. So what will be the radius of the required circle? So let me just find it here. Divided by root over of 3 square plus 2 square. That's it. So what you are getting, let me just calculate it here. 24 plus 56 over 3 minus 34 divided by root 13. So we are getting basically 72 plus 56 minus 102, right? Divided by 3 root 13. Okay. So how much you are getting? 72 plus 56, that gives us 128 minus 102, that gives us 26. So it's basically 26 over 3 root 13. I'm writing it here. So we are getting 26 by 3 into root 13. So let me just rationalize it. So 26 into root 13 divided by 3 into 13. So that gives us 2 root 13 over 3. Is it clear? Hence option D is correct. See how simple sum it is. Simple sum, yeah, little calculation is involved. That's true. Little calculation is involved. But the sum is easy. That is why I always say that coordinate geometry will never betray you. Other chapters can betray, but coordinate geometry will never ever betray you. But the only prerequisite is that you have to remember little formulae and you have to remember the shortcut tricks, nothing else. Okay, so let's move for the next problem. This question is a wonderful sum. Please see this. They have said that t and m belongs to any real value. They are the variables such that this condition is given to us. The question is, show that the line, this one, touches a fixed circle. The lines, this one, why they have said lines? Because t and m are the variable. For different values of t and m, you are going to have different lines. So that is why they have said lines. Touches a fixed circle, find its center and radius. Means you have to find out the center and radius of that fixed circle. Okay, so let us say the circle is, let us say this is that circle, and the line which is given to us, let us say this is that line. Okay, now let us say the center of this circle be alpha comma beta, and the radius b r. This is the radius I have joined. This is actually the normal because I have joined the center with the chord of contact. I am sorry, this point of contact. Okay, so the moment I have joined this, so this is my radius r. So, and the equation of this line is tx plus my plus 1 equals to 0. Clear? Now, the same rule, the same funda I am using here. T alpha plus m beta plus 1 divided by root over of t square plus m square. This is what? This is the perpendicular distance from the center of the circle on the tangent, and which is nothing but your radius r. So, if I square both sides, we are going to have this square equals to r square into t square plus m square. So, this condition should hold true when tx plus my plus 1 equals to 0 is a tangent to the given circle whose center is at alpha beta and radius is r. Now, how to get this relation? We will get this form only from the given condition, because we cannot find out otherwise, isn't it so? That is why this condition is given. So from this condition, we will try to form an expression like this. And then we will simply compare to say what is alpha, what is beta, and what is r. That's it. That's exactly what we require. So what I'm doing here is I can write this thing as 3t square plus 6t plus 1 is 6m squared. Now, if you see this expression, you will find that you are having m square in the right hand side. At the same time, you are having t square with r square common. So naturally, what I will do to get this form, I will add 6t square both sides. Hello? I will add 6t square both sides. So the left hand side, we are getting it as 9t square plus 6t plus 1. But if you observe, you will find that you are getting the form which is in the right hand side. That is r square into t square plus m square. T square plus m square we got. And the left hand side can be written as 3t plus 1 whole square, which is equals to 6 times m square plus t square. Am I correct? Am I correct? Now, if I compare this equation with this one, we can easily see that your r square is coming to 6. That implies r is root 6. That is, the radius of that fixed circle is root 6. Moreover, if I compare this part with this part, we can easily see that your alpha is coming to 3 and beta is coming to 0. क्योंकि मेरा लेफ्ट हैंड साइड में कोई भी m नहीं है. In this one, you are having m beta. But here we are not having any m. So what you will write? M into 0. Clear? Therefore, your beta will come to 0. Therefore, what is the center of that fixed circle? It's 3, 0. Am I correct? It's 3, 0. And what is the radius of that circle? It's root 6. Finished. And that's exactly what they want. They want the center, they want the radius. That's exactly what we have done. Is it clear to all? It's a very nice sum. You have to understand and you have to opt the method that I have done. Okay. Again, there is no high funda thing has been introduced here. Nothing. The same conception from the center, join the point of contact on a tangent. It will be always the normal, that is the perpendicular, because that will be the normal of the given circle, and this length will be nothing but the radius of the circle. That funda बार बार हम use कर रहे हैं और यही चीज हम करेंगे throughout your circle chapter, and that exactly what you people will also do. ये फंडा को यूज कर दो, टेंजेंट होगा तो सेंटर से पॉइंट ऑफ कांटेक्ट ज्वाइन करो और उसको रेडियस का साथ इक्वल कर दो. You will definitely get your answer. Okay? Now let us take another problem. See, it's the same kind of question. It is said that now two relations are given. One is this one, another one is this one, where A, B, D are fixed real numbers. And they have said that this line touches a fixed circle. So which of these four options are correct? This is a multiple option correct. One or more than one option correct. So what I will do, I will use the same method. I'm going to draw a circle. Let us say this is my fixed circle. Let me draw it here. This is my fixed circle. And we are having the tangent. Okay. This is the center of the fixed circle. Let us say this is alpha comma beta. And let me join the point of contact with its center. This is nothing but the radius. And the equation of this tangent is tx plus my plus 1 equals to 0. So what is the perpendicular distance from the center? It's t square plus m square, which is nothing but this perpendicular length is nothing but its radius. So we can write t alpha plus m beta plus 1 whole square is r square into t square plus m square. Am I correct? Okay. So now what we will do, we will try to find out this relation from the given conditions, because we don't have any other way to find out this condition. Only with the given condition we will find out. Okay. So the right hand side we are having t square plus m square. So I need m square in the right hand side and t square in the right hand side with a common term r square. So for that, I'm writing at square plus 2 dt plus 1 equals to bm square. See, the right hand side we are getting m square with some common term b. So what I will do is I will simply add the common term b with t square both sides. So the left hand side becomes, if I take t square common, it's coming something like this, which gives us b times m square plus t square, correct? Now, a plus b is nothing but d square, which is given. So it's d square t square plus 2 dt plus 1 is b m square plus t square. So it is coming like dt plus 1 whole square is b times m square plus t square. Now, if I simply compare this and this, we are going to have your r square as b implies r is root b. That is, the radius of the given circle is root b. So I can easily see that this option is absolutely wrong, because here they have said the radius is b, but no, the radius is actually root b. Okay, if I compare the left hand side, what we are going to have? We are going to have alpha as d and beta as 0. Yes? Therefore, its center is at d comma 0. That is, the center is on the x-axis. The center of this circle is on the x-axis. The center of this circle is at the on the x-axis, right? So this is its center, and this is my x-axis. Now, one thing you must remember here, again, if possible, make a note that whenever a line is passing through the center, that is any normal, because normal always passes through the center of the circle. So for any normal, we will always say that it cuts the circle orthogonally. What I have said, any line or any normal, because normal always passes through the center of the circle, any normal is always orthogonal to that circle. Is it clear? Any normal, any line which is a normal that is passing through the center is always orthogonal to that circle. Orthogonal means the angle between that line and the circle is 90 degrees. Okay? See, at this point, if I draw a tangent, then this line and this normal with the tangent, they will always make an angle 90 degree. That is the reason why they say that any normal is orthogonal to the circle. Is it clear? So now you see the first option given, which has been said, which cuts the x-axis orthogonally. Yes, this is true. Why? Because the center is at d comma 0, means it is on the x-axis. That is, your x-axis is passing through its center. That is, your x-axis is orthogonal to this circle. Is it clear? Hence, option A is absolutely correct. Option B is no, it's not. Acha. So we have to, since it's a more than one option correct, so definitely I have to see option C also, on which the tangent of the length of the tangent from origin is this. Now, can you please tell me what is the equation of this tangent? We know its center, we know its radius. So what will be the equation of the circle? I'm writing it here. What will be the equation? It will be this is equals to B. Yes or no? Now, origin is a point which is outside the circle. Origin is a point which is outside the circle, right? Now, they have asked to find out, but the option is that the length of the tangent from the origin is this. Now, how to find out the length of the tangent? We will simply find out what is its power of the point, and we will simply take its root. So, what is the power of the point of 0, 0, that is the origin with respect to this given circle? Your S1 will give us 0 minus d whole square, that is d square. This is 0 minus b. So your S1 is coming to d square minus b. Therefore, the length of the tangent is root over of the power of the point. That is root over of d square minus b. Is it clear? Hence, option C is also correct, because the length of the tangent drawn from the origin to the circle, to that fixed circle, is of length root over d square minus b. Hence, option A and C for this sum are correct. Is it clear to all of you? Is this clear to all of you? If you have a single question, you can ask me in the chat box. I will definitely get back. Okay? Okay. So let us now move for the next one. So now we are coming for a new conception which is called your chord of contact. What do you mean by chord of contact? Suppose a circle is given to us and there is a point outside this circle which is x1, y1. And from there we have drawn two tangents PT and PT dash. Now T and T dash is basically the point of contact. Now the line joining the point of contact T and T dash is what called your chord of contact. That's it. Is it clear? So from any point outside the circle, when you draw two tangents to a circle, the points where it is intersecting the circle are called the point of contact. And if you join that point of contact, you are going to get a line which is called chord of contact. Is it clear? Now, for a time being, let us assume that the coordinate of t is x dash y dash and that of t dash is x double dash y double dash. Now, we have to find out, our main target here is to find out what is the equation of the chord of contact, right? Now, equation of the tangent at t, equation of tangent at t, that is x dash and y dash, is what? As x dash y dash is on the circle, so we can use the Cartesian form. Equation of the circle is x square plus y square equals to a square. So we can write this thing as x dash plus y dash equals to a square. This is the equation of the tangent PT. Is it clear? Now, similarly, what will be the equation of the tangent PT dash? What is the equation of tangent at T dash, which is x double dash y double dash? Again, this coordinate, this point is very much on the circle. So I can apply the Cartesian form to find out the equation of the tangent PT dash, which will be nothing but x double dash plus y double dash equals to a square. Am I correct or not? So these are the equation of the two tangents PT and PT dash respectively, right? Now look it very carefully. Both these tangents are passing through the point x1, y1. Hence it must satisfy these two equations. So we can write x1 x dash plus y1 y dash is a square. x1 x double dash plus y1 y double dash is a square. Am I correct? Now what is our target? To find out the equation of the chord of contact. Now, chord of contact is a line which is passing through both these point of contacts, isn't it so? That is, the equation of chord of contact is definitely going to satisfy both the points x dash y dash and x double dash y double dash. So simply by observing these two equations, can we write that the equation of chord of contact is nothing but x1 plus y1 equals to a squared. Why it is so? Because as I told you, the chord of contact is going to pass through 2 points t and t dash. So it must satisfy that. Now in place of x and y, if I put x dash y dash, you see this condition will satisfy. Why? Because it has already been given here. This condition is true, means x dash y dash is going to satisfy this equation. Yes. Now similarly, it is passing to the point x double dash y double dash. Hence it must satisfy this. So in place of x and y, if I put x double dash y double dash, again you see it is going to satisfy this equation because this condition is true. Therefore, this is an equation which is passing through both the points t and t dash. Hence we can say this is the equation of the chord of contact. Is it correct or not? Now, can you observe one thing? When we have done the Cartesian form of tangents for this curve, the equation was exactly the same as the equation of chord of contact. It was x1 plus y1 equals to a squared, right? This equation and this equation, they are same. So now the question will come, sir, then chord of contact and the tangent, are they same? Definitely they are not same. We can see it from here itself. Chord of contact is not at all the tangent to the circle. But how these two equations are coming to same equation? Now here there arises the confusion. But one thing we have forgotten. What is that? For the chord of contact, where does your x1, y1 lies? Your x1, y1 lies outside the circle. This is the point P which is outside the circle. In that case, the equation of chord of contact is this. But in case of Cartesian equation of the tangent, your x1 is y1 is on the circle. Don't get confused here. For the both tangent equation and chord of contact equation, they are same. I admit that. But for the chord of contact, the point is outside the circle. For tangent, the point is on the circle. Is it clear? Very good. So now onwards, what we will do throughout the conic section, what we will do? We will use a notation which is called T. T is what? T in this case, your T is xx1 plus yy1 minus a squared. Why T has been given? This notation has been given because this is, the equation of a tangent. If I put this T equals to 0, this becomes the equation of the tangent. And from there, this capital T thing comes into the picture. So what I will do, I will use the notation T. T means it is xx1 plus yy1 minus a square. This is for the circle x square plus y square equals to a square. If your S is x square plus y square minus a square, then your T will be written as xx1 plus yy1 minus a square, right? But if your S is x square plus y square plus 2gx plus 2fy plus c, in that case I will write my T as xx1 plus yy1 plus g times x plus x1 plus f times y plus y1 plus c. So accordingly, I will change what is your S. Depending on S, I will write T. Okay. So in this case, your T is xx1 plus yy1 minus a square. So what we got actually is the equation of the chord of contact for S equals to 0. What is S? S is this, which is x square plus y square equals to a square. So for S equals to 0, The equation of the chord of contact is T equals to 0. Is it clear? Now you can ask me one question, sir. You have taken the standard form of the circle. But if I take the general equation of the circle, in that case also your chord of contact will be T equals to 0. My answer is yes. In that case also your chord of contact, equation of chord of contact will be T equals to 0. But in case of the general circle, your T is this, not this. Is it clear? But always remember that whatever S you have, accordingly we will form T, and the equation of chord of contact is always T equals to 0. Is it clear to all? Is this clear to everyone? Okay, let me take some problem based on this conception. See this question. The question is the chord of contact of tangents drawn from a point on the circle this. So from this point, from a point on this circle, let me draw the circle first. So this is, I'm sorry, just one sec. This is my circle, right? This is my circle. What is its equation? Its equation is x square plus y square equals to s square. Now we are having a concentric circle, x square plus y square equals to b square. Now let me draw another concentric circle with a different color. Let us consider this is that circle, right? This is the concentric circle. This is what? The equation of this is this. The equation of this red circle is x square plus y square equals to b square. Now let me just first read these two lines. The chord of contact of tangents drawn from a point on this circle. So you choose any point on this circle. And from there you simply draw two tangents. You simply draw two tangents. Let me change the color. Which color will I take? Okay, let me take this color. Okay. So from this point, I have drawn two tangents on the circle x square plus y square equals to b square. Is it clear? Right? Now, what happened? It touches the circle. Which one touches the circle? The chord of contact. So let me join the chord of contact. This is the chord of contact. This chord of contact touches the circle x square plus y square equals to c square. Now x square plus y square equals to c square is definitely a concentric circle with a given circle. So how the circle will look like? The circle is concentric circle with this, and this chord of contact is a tangent to the circle. Am I correct? This thing is actually happening. This is your x square plus y square is equals to c square. Okay. Now they have said a relation is given to you. A relation is given to you. From there, you have to find out what is your m, n, and p. That is the exponents of b, a, and c respectively. Okay. So first, let us solve this. Now, let us say the point P is any point on the circle x square plus y square equals to a square. Let me say this point B, a cos theta, comma a sin theta, because this is any point on this circle. Now, from this point P, you have drawn two tangents. Now, what will be the equation of the chord of contact? What will be the equation of the chord of contact? To which circle? We are talking about the chord of contact. For which circle? For the circle x square plus y square equals to b square. Therefore, the equation of the chord of contact, is what? It is x1 plus y1 equals to b square. That is x1 plus y1 is equals to b square. So this is the equation of the chord of contact. Is it clear? Let me just give a name. Let us say this is A and this is B. Therefore, the equation of AB is this. Now it is a tangent to the innermost circle, which is x square plus y square equals to c square. So what is its center? Its center is at 0, 0. So now if I join the point of contact with the center of this circle, this is going to be the radius of the circle, which is nothing but c. If I join the center of the innermost circle with the point of contact of the tangent AB, then this length, let me give a name. This is O, this is a C. So your OC will be the length, the radius of the innermost circle, which is C. So what is the perpendicular distance from the origin on this line? The perpendicular distance will be root over of a square cos square theta plus a square sine square theta. This is the distance OC. This is your distance OC. And this distance is nothing but the radius of the circle. The radius of the circle, which is nothing but C. Is it clear or not? So what we are going to have? B square divided by, if I take a square common, it's going to give us 1 equals to C. So we are having B square equals to A into C. Look at carefully, I have removed the mod sign. Why? Because A, B, C, these are the radius of a given circle. So it cannot be negative. So your B square is coming to A plus C. If I compare this thing with B to the power M, A to the power N, C to the power P, we will write that M is 2, N is 1, N is 1, as well as P is 1. Okay? Therefore, your M plus N plus P plus 10, the value of this will be 2 plus 1 plus 1 plus 10. That gives us 14. Is it clear? Now, one thing I feel that here you must write that M, N, P, these are the least value of the natural numbers. Because if I don't give that, you can write this thing as B square equals to S. Somebody can write this thing as B to the power 4 into S square into C square. In that case, they will say, sir, M is 4, N is 2 and P is 2. But that is actually not happening. So here is what M, N, P are least natural numbers. Is it clear or not? Right? Therefore, your answer is 14. Your answer is 14 in this case. I hope it is clear to all of you. Absolutely. Okay, let's move for the next problem. What is the question? Find the coordinates of the point of intersection of the tangents at the points where the line, this one, meets the circle, this. Is it clear? Means what they are saying? Let me just draw the diagram first. This is the circle whose center is at 2 comma minus 3 by 2 and its radius is root over 4 plus 9 over 4 plus 1. So it's coming like root over of 18 over 4. Am I correct? No. Sorry. Great mistake. Just one sec. It's actually 26 over 4, right? 16 plus 9, 25. Oh no, 25 plus 4. That is 29. Sorry again. It's 29 over 4, right? So that is the radius. So it's root 29 over 4. If required, I will use. I don't know whether it will be required or not. Okay. So we know the center, we know the radius, and what they have said that there is a line. There is a line which is intersecting this circle at 2 points. Okay. And at these points, what we have done is basically we have drawn 2 tangents. 2 tangents we have drawn at these 2 points. Okay. Now you have to find out the point of intersection. That is, you have to find out this point. Let us say this point B. P, which is, let us say, alpha comma beta. And let us say this point is A and this point is B. Okay, and the equation of this line is 2x plus y plus 12 equals to 0. Okay, so how to find out this? See, those who have not done coordinate geometry properly, what they will think? They will give us, a normal solution. What they will say? They will say, sir, let us do one thing. Let me solve AB with the given circle. Now, if you solve it, we are definitely going to get these two values. The coordinates of A and B we will get. The moment we get A and B, the coordinates of A and B, we will find out what is the equation of PA and PB. And then we will solve PA and PB to get alpha and beta. Now, can you think the length of the sum that is going to take place? How much time it will consume to solve this sum? Can you understand that? So it's not, we don't do the problem in that way. We will do in some other way. What we do, please do remember, and if possible, make a note of it. Whenever this kind of things are given and we need to find out the coordinate of the point of intersection, what we do, we try to, you see, this AB is basically a chord of contact, and the equation of the chord of contact is given to you. Now, it is advisable, please make a note of it. You always try to find out the equation of AB in some other way. Okay? You try to find out the equation of AB in some other way. So if, I will show you how we are getting, but if we get the equation of AB in some other way, now what I will do, I have been already given the equation of the chord of contact. So simply I am going to compare their coefficients to get the value of alpha and beta. Easiest way I'm telling you. Right? Whenever this kind of things are given, always try to find out the equation of the chord of contact in some other way. And then compare the coefficients. That's exactly what we are going to do here. We know the equation of the circle and we know that the point outside the circle is alpha beta. Therefore, we know that the chord of contact, equation of chord of contact will be nothing but t equals to 0. T equals to 0 means it is going to come like alpha x, beta y, 2 times x plus alpha, y plus beta, minus 1 equals to 0. That's it. So this is what? This is the equation of the chord of contact AB. Right? Now let me write it in a proper way. Plus, if I take y common, we are having b plus 3 over 2y, and then we are having minus 2 alpha plus 3 over 2 beta minus 1 equals to 0. That's it. Is it clear or not? Now I have given a shape of a line. I mean, I've written it in a proper way. So the moment you get this is the equation of AB. Already you know the equation of AB. What is that? It's 2x plus y plus 12 is 0. That's exactly what they have given. Now this two equation represents the same straight line. Hence I can compare it. So alpha minus 2 over 2, that will be equals to beta plus 3 over 2 over 1, which is equals to minus 2 alpha plus 3 over 2 beta minus 1 divided by 12. Hello? Is it clear or not? Okay, so now if I solve this two, what we are going to have? We are getting actually alpha minus 2 is 2 times beta plus 3 by 2. So we are having alpha minus 2 is 2 beta plus 3. So we are basically having alpha minus 2 beta is 5. So this is one equation we got. This is one equation we got. Now what is the other equation? Let me just multiply this with this. I mean, I'm taking this 2 and I'm solving it. So what we are getting? 12 beta plus 18 equals to minus 2 alpha plus 3 by 2 beta minus 1, right? So it will give us something like this. 24 beta, 36 minus 4 alpha plus 3 beta minus 2. Okay. So from here we are getting 4 alpha plus 21 beta is equals to minus 38. Is it clear? So this is our second equation. So if I solve this too, we are going to have the coordinate of point P. So for that, what I'm doing, I'm multiplying first equation with 4 alpha. And the second equation is 4 alpha plus 21 beta is minus 38. So let me just subtract this two. We are going to have so from here we are getting beta is nothing but minus 2. Am I correct? Beta is nothing but minus 2. If beta is minus 2, we can easily see from the first equation your alpha is, so 5 minus 4, that gives us 1. Therefore, the coordinate of point P is nothing but 1 comma minus 2. Am I correct? Let me reveal the answer. Yeah. Is it clear to all? So it's pretty simple. So what we have done, what we have learned from this sum, we have learned that whenever this chord of contact type is given to us, we will try to find out the equation of chord of contact in a different way. And after getting the equation of chord of contact, I will simply use, because these two lines, the given line and the chord of contact that we got are the same. Hence, we can compare their coefficients to get the value of alpha and beta, which is nothing but the coordinate of the point which is outside the circle. That's it. Okay. Let me move for the next problem. This question came in JEE Main 2023. What is the question? A circle with center 2, 3 and radius 4 intersects the line x plus y equals to 3 at the points P and Q. So let me just draw the diagram first. So we are having a circle. This circle is having its center at 2, 3 and its radius is 4 units, right? Now it intersects a circle, a line which is x plus y at P and Q. So this is my point P and this is my point Q, and the equation of this line is x plus y equals to 3. Now what we have done? We have drawn two tangents here at P. Okay, let us say the tangent is somewhere here. Okay, let me draw it here. Achha, okay. Let us say this is the tangent and the other tangent at Q, which is here. Okay. Now they intersect at a point. Alpha comma beta. Okay. Now you have to find out. The coordinate of alpha and beta. You have to find out the coordinate of S. That is, you have to find out alpha and beta. See, same type of question. What is your PQ? PQ is basically the chord of contact. Now I will try to find out the chord of contact in a different way. How? We know that this point outside the circle is alpha comma beta. So if we know the point outside the circle which is alpha comma beta, we can easily find out the equation of PQ, which is the chord of contact, provided we know the equation of the circle. What is the equation of the circle? We know its center, we know its radius. So simply use the center radius form to find out its equation. So if we open, what we are going to have? Is it clear? So we are having, so it's 9 plus 4, that is 13, minus 16 minus 3 equals to 0. That's it. So this is the equation of the circle. So what will be the equation of chord of contact? What will be the equation of chord of contact? It will be x alpha, y beta, because chord of contact is what? T equals to 0. So x plus alpha, y plus beta, minus 3 is 0. So this is the equation of the chord of contact, which is again given to be x plus y equals to 3. See how simple it is. Simply by applying this method, you can solve any kind of question involving chord of contact. Only remember this funda. You have to write down the chord of contact in a different way, and then you compare the coefficients. That's it. So that's exactly what I'm going to do here. Beta minus 3y minus 2 alpha minus 3 beta minus 3 equals to 0. Okay. So now let me compare this equation, because this is the chord of contact. At the same time, this is also the chord of contact. So let me compare the coefficients. We are having x alpha minus 2 by 1 is beta minus 3 by 1 is minus 2 alpha minus 3 beta minus 3 divided by minus 3. So actually we are having x minus alpha minus 2 is beta minus 3 is 2 alpha plus 3 beta plus 3 divided by 3. That's it. So let me just take this two equation. We are getting alpha minus beta is minus 1. This is one equation we got. And the second equation, let me take this two. So we are having 3 beta minus 9 is equals to 2 alpha plus 3 beta plus 3. So 3 beta goes off. Fantastic. So from here we are getting 2 alpha is minus 12. So alpha directly we got at minus 6. Alpha we got as minus 6. If alpha is minus 6, what is beta? It's minus 6 plus 1, that gives us minus 5. Are you with me? So we got alpha, we got beta. Then what is the value of what they have said? 4 alpha minus 7 beta. That gives us minus 24 plus 35, which gives us actually 11. And 11 is the answer for this question. Is it clear to all of you? Absolutely clear. See, the same method I'm using and same method you people have to use every time. Whenever the chord of contact is given to you, try to form the chord of contact by using other method, and then you simply compare the coefficients to get the value of unknown coordinate alpha beta, right? Which is the point outside the circle. Okay, let us take another problem. What they have said the tangents are drawn from the point HK to the circle x square plus y square equals to a square. Let me draw the circle first. So this is the circle whose center is at 0, 0, whose center is at 0, 0 and radius, center at 0, 0 and radius is A. Okay. Now there is a point outside this circle. Let me say the point be this. Let us denote this point be P, which is H comma K. And from here you have drawn two tangents. From here you have drawn two tangents. One is this, another one is this. Yes or no? So these are the two tangents we have drawn. Now what is the question? The question says that the area of the triangle formed by these two tangents and their chord of contact, this chord of contact, you have to find out the area of this triangle. You have to find out the area of this triangle. Okay. How to do this? You have to prove that the area is this. It's okay. But to us, I will simply find out the area of the triangle PAB, where AB is the chord of contact. How to do this sum? How to do this sum? See, there are several ways of doing this sum. There are several ways of doing this sum. So what I'm trying to do, let me do one thing. Let me just join P with the center O. I mean the origin. Okay. Now, let us say this angle be theta. If this angle is theta, let me just join this also, as well as this. Okay. Now, if this angle is theta, the radius is A. The radius is A and this angle is theta. Now, what is your PA? PA is basically the length of the tangent, which is nothing but root of S1. Okay. What is S1? S1 is nothing but h square plus k square minus s square. Let it be like that. I am writing it as only S1. So, PA is root of S1. Then what is your tan theta? Your tan theta is A over root S1. Tell me yes or no? Tan theta is, because this angle is 90 degree. So tan theta will be perpendicular by base, that is A over root S1. Is it clear? Absolutely. Okay. Now our task is to find out the area of APB. That is, my main motto is to find out this length, let us say this point where AB is intersecting the line joining PO, BQ. Now, if you observe in the triangle APQ, this angle is 90 degree. Correct? This angle is 90 degree. Then we can write your sine theta is nothing but AQ over AP. Sine theta is perpendicular over hypotenuse. So it is AQ over AP. What is AQ? I don't know. What is AP? Your AP is root of S1. That is the length of the tangent into sine theta. But again, we don't know sine theta. Okay. But we know tan theta. If I draw a right angle triangle and if this angle is theta, then this is A, this is root of S1. Then what will be its hypotenuse? Hypotenuse will be root over of A square plus S1. So what is sine theta now? Your sine theta is coming to perpendicular over hypotenuse. Is it clear? So AQ is nothing but A root S1 divided by root over of A square plus S1. Is it clear? Is this clear to all? Absolutely. Okay. Now, if AQ is this, what is your AB? AB is twice of AQ. So that gives us 2 times A root S1 divided by root over of S square plus S1. That is your length of AB. That is the length of AB. Now, can you please tell me what is the equation? What is the equation of chord of contact AB? What is the equation of the chord of contact AB? It is nothing but Hx plus Ky equals to A square. Am I correct? Then what is the perpendicular distance PQ? What is the perpendicular distance PQ? P is H comma K, and equation of AB we know Hx plus Ky equals to A square. So what is the perpendicular distance PQ? It is nothing but H square plus K square minus A square divided by root over of H square plus K square. This formula I have used. The perpendicular distance between a point and a straight line. Okay, so now you know PQ, you know AB. Then what will be the area of the triangle? What will be the area of the triangle APB? It's half into base into height. That's it. So that gives us half. What is AB? AB is 2 times A root S1 divided by root over of S square plus S1, correct? Into PQ. PQ is what? This is your PQ, which is H square plus K square minus S square divided by root over of H square plus K square. Clear? So what you are getting basically, it's coming to A root S1. What is S1? S1 is H square plus K square minus S square. So I'm writing it that H square plus K square minus S square divided by root over of what is S1 plus S square? It is nothing but H square plus K square, right? Into H square plus K square minus S square divided by root over of H square plus K square. So from here what we are getting? We are getting A times H square plus K square minus S square to the power 3 by 2 divided by H square plus K square. Am I correct or not? And that exactly what the answer we got. Is it clear? This is how we find out. This is how we find out the area of the triangle APB. Now, one thing I will just give you a little pain. It's not pain. The person who can take the pain ultimately gains. So there is a little pain. If you can remember, it will be a fantastic thing. What is that? Listen, I'm teaching you here. If possible, make a note of this. Make a note of this. What is this note? It states that in this diagram, we all know that the area of the quadrilateral, this we have already done. The area of the quadrilateral is A root S1. This we have already, I taught you. At the same time, I taught you that the angle between these two tangents is basically tan theta. Tan theta means this. If this, okay, I have written theta, so let me write this thing is also theta. So I have to write in this place 2 theta, okay? I have to write here 2 theta because this is actually the formula for the angle between the two tangents. It's tan 2 theta, what we know, A root S1 divided by S1 minus S square. Can you remember that? And now, if possible, please do remember this because you have already taken the pain to remember this. Now, if you can simply remember this, you can reduce a lot of step. That is the length of chord of contact. That is the length AB. What we got AB as this one, which is nothing but 2 times A root S1 divided by, not 2 times, yes, 2 times, sorry, 2 times A root S1 divided by root over of A square plus S1. That's it. Is it clear? Oh, sorry, I have missed this one. Here there will be 2. I'm sorry. So, if you can remember these 3 things only, it will be very easy for you to solve questions quickly. One is the area of the quadrilateral PAOB is A root S1. The angle between the two tangents is 2 times A root S1 by S1 minus S square. And the length of the contact, you see, it's almost the same with the angle between the two tangents. But there is a little difference in the denominator. It's 2A root S1, the same thing with the angle between the two tangents, divided by root over of S square plus S1. Simply remember that. Means in this case, if you can remember in this way, it will be also okay. For the denominator, there is a plus sign in between and there is a root sign. That's it. That's the only difference. So instantly you see a lot of steps can be reduced for even for this question. A lot of steps can be reduced if you know that the length of the chord of contact is 2 times A root S1 divided by root over S square plus S1. Okay, why I'm telling you repeatedly to remember this, because nowadays JEE mains are giving questions based on this figure. Okay, so this question, type of question is very important. You can expect one sum in your exam. So that is why in that case, if you want to really solve it quickly, please do remember this three formula. Is it clear to all? Okay. So let me just move for the next problem. Okay. Next is a conception, which is a new conception, which is the chord bisected at a given point. Chord bisected at a given point. What is that? An equation is given to you. An equation is given to you, and the equation is x square plus y square equals to s square. This equation is given, whose center is at 0, 0. And now I have to find out the equation of a chord to this circle, which the chord is bisected at the point D, according to this figure. The chord is bisected at the point D, and let us say the coordinates of the point D be x1, y1. So what will be the equation of the chord AB? That's the question. Okay, I think the question is clear to you. A chord AB is there, and the midpoint of this chord is x1, y1. This has been given. Now you have to find out the equation of the chord AB. In this case, the circle we have chosen is x square plus y square equals to s square. Now, again, I am telling you, whatever formula I am going to get from here, though it is written, don't see that one first. Whatever formula we are going to get from here, it is true for all circles. Whether it's a standard form or it's a general form, doesn't matter to me. This formula is valid for any type of circles. So what will be the equation of the chord whose middle point or which is bisected at the point x1, y1? See, pretty simple proof, pretty simple proof. What is the slope of CD? The slope of CD is y1 over x1. That's it. If the slope of CD is y1 over x1, as we have joined the center with the midpoint, CD is basically the line joining the center of the circle and the midpoint of this chord. So definitely they are perpendicular to each other. Therefore, slope of AB will be nothing but minus x1 over y1. So what will be the equation of the line AB? It is y minus y1, because we know one point through which the line AB is passing, and we know the slope also. So the equation of the line will be y minus y1 equals to the slope into x minus x1. So that gives us what? y1 minus y1 square equals to minus x1 plus x1 square. So from here we are getting x1 plus y1 equals to x1 square plus y1 square. Is it clear? Now what I'm doing is I'm simply subtracting. It is difficult to remember in this way, so it's better to remember in this way. So I'm subtracting a square from both sides. I'm subtracting a square from both sides. So this part I can denote it by t, and this part I can denote it by s1. So we will remember in this way that the equation of the chord bisected at the point x1, y1 is nothing but t equals to s1. Simply remember that. What was the formula for chord of contact? It was t equals to 0. What is the equation of the chord bisected at the point x1, y1? The equation is t equals to s1. Again I'm mentioning, it is true for all circles. It's not for the standard form only. Whether it's a general form or standard form, t equals to s1 is the equation of the chord bisected at the point x1, y1. That's it. Is it clear to all? Okay, let me do some problems based on this conception. This is a straightforward question. They have said find the equation of the chord of this circle which is bisected at -2, 4. इसका मतलब क्या हुआ? x1 is -2 here and y1 is 4 here. This is the midpoint of that chord. So what will be the equation of the chord? We know that the equation of the chord bisected at the given point is t equals to S1. So what will be the tangent equation for this circle? It is x1, that is minus 2x plus 4y minus 3 x minus 2 x plus x1 plus 5 times y plus y1 minus 9, right? This is your t, which is equals to your S1. S1 means just put minus 2 and 4 in the given equation, in the expression of that circle. So what you are getting? 4, 16, 12, 40 minus 9. That's it. So this is the equation of the chord which is bisected at the point minus 2 comma 4. So from here what we are getting, let me cancel this. So minus 2x minus 3x is minus 5x, 4y here, 5y here, so it's 9y, and it is simply a mere calculation. 6 plus 20. This sum I have chosen. Why? Because simply to give you that the idea of how we use the formula. So this 20, 60, 72, right? So we are actually having minus 5x plus 9y plus 26 minus 72 equals to 0. Yes or no? Please check it. Please check it. So we are actually having minus 5x plus 9y minus 46 equals to 0. So 5x minus 9y plus 46 equals to 0. Am I correct? So this is the equation of the chord which is bisected at the point minus 2 comma 4. So that's your answer. Is it clear? It's a straightforward question, simply to practice how to find out the chord which is bisected at a given point. So it is directly the application of the formula. Let me take the next problem. What is the question? The question is, find the locus of the midpoints of the chords of the circle this. Find the locus of the midpoint of the chords of circle this, which are perpendicular to the line this. Okay, now the chords, you have to find out the locus of the midpoint of that chords which are perpendicular to this given line. Let me just draw the diagram to give you an idea actually what is happening. This is the given circle, and let us say this is the given chord. Okay, this is the given chord, and the center of this circle which is given to us is basically 2 comma 3, and you have to find out the locus of the middle point, the locus of the midpoint of this chord. Let us say the h comma k be any point on the locus. The center is A, this point, let us say this is P. Now this chord is actually perpendicular to some chord which is having its equation like 4x plus 5y plus 10 equals to 0. Is it clear? So how to find out this? Simple thing, simple. You have to find out the locus of the point P. Now look it carefully. What is the slope of this line? It is, so y is coming to minus 4 over 5x minus 2. So the slope of this line is nothing but minus 4 over 5. So all the chords which are perpendicular to this line is basically 5 over 4. That is the slope of those lines. Is it clear or not? 5 over 4 is the slope of all the chords which are perpendicular to the given line. The slope is 5 over 4. Now, what is the slope of this line? What is the slope of AP? Slope of AP is k minus 3 over h minus 2. This is the slope of AP. And as P is the midpoint, so AP is definitely perpendicular to the given chord. The slope of the chord is 5 over 4 and AP, slope of AP is this. Therefore, the product of their slopes will be equals to -1. Why it is so? Because they are perpendicular to each other. So from here we got a relation between HK and constant. So we are having it's 4H plus 8. So we are having actually 4H plus 5K minus 23 equals to 0. Am I correct? Therefore, the equation of the locus is 4x plus 5y minus 23 equals to 0. That's it. This is the required locus of the given point. Is it clear to everyone? Is this clear to everyone? Okay. Let me take the next problem. See this question. The locus of the midpoint of the chords of the circle. Now, let me draw the circle first. Always in the coordinate geometry, try to draw the figure correctly. Okay, the moment you have the figure, you will have that feelings of doing the sum. So this is the circle, and this circle, the equation of this circle is x square plus y square equals to 4. It means what? Its center is at origin and radius is 2 units. Okay. Now you have to find out the equation, the locus of the middle point of those chords. Let us say this is that chord. Okay, this is that chord. So you have to find out the locus of the middle point of those chords which are making an angle, of 90 degree at the origin, which is subtending an angle 90 degree at the origin. Is it clear? So these 2 points, if I consider this point and this point, and if we join, let us say this is my origin O. So if I join these 2 points, we are going to have that this angle is nothing but 90 degree. Are you getting some feelings of this question? How to do this? How to do this? A pair of lines making an angle 90 degree at the origin. You people have all done these things in straight line. I have done it. You can see those videos given in this playlist named straight lines. So there I taught you one thing which is called homogenization method. I taught you, and at the same time I taught you how to homogenize any curve with respect to a line. Is it clear? So first of all, let me find out. Let us say h comma k be any point on the locus. Then what will be the equation of this chord? It is t equals to s1. What is t? T is basically hx plus ky equals to, sorry, just 1 second. T means -4 equals to s1. S1 is what? h square plus k square minus 4. Therefore, the equation of the chord is hx plus ky equals to h square plus k square. Now you have to homogenize the equation of this circle with respect to this line, with the help of this line. How to homogenize? It is hx plus ky divided by h square plus k square equals to 1. Why this homogenization? Homogenizing this equation came into my mind because the moment I see that a pair of line is making an angle at the origin whatever the angle is. In this case, the angle is 90 degree. The moment 99.9% case wave, whenever you get this kind of problem, they will always say that they are making an angle 90 degree at the origin. But even if they don't make it, doesn't matter to me. We know how to find out the angle between a pair of lines. That I'm not going to tell you right now. We have already done this thing. 2 root over h square minus ab divided by a plus b. This all we have covered in straight line lectures. So the moment the lines are joining the origin, the first thing that will come in my mind is homogenization. Straight away, nothing else. So how to homogenize this equation? X square plus y square is 4. 4 means it's into 1 square. So I will write this thing as 4 times hx plus ky divided by h square plus k square whole square. So again, I have already homogenized it. So let me just cross multiply. Equals to 4 times h square x square plus k square y square plus 2 hkxy. Am I correct? Now what I taught you, that whenever this line is making an angle 90 degree at the origin, then what we do after homogenizing, you will equate the sum of the coefficient of x square and the coefficient of y square equals to 0. This we have already covered in straight line chapter, as I told you. So what is the coefficient of x square? It is h square plus k square whole square minus 4h square. Am I correct? And coefficient of y square is h square plus k square whole square minus 4k square. Now, according to the question, since it is making an angle 90 degree at the origin, so we will say the sum of the coefficient of x square plus the sum of the coefficient of y square is equals to 0. So what you are getting? 2 times h square plus k square whole square minus 4 h square plus k square equals to 0. Let us take h square plus k square common. So we are having 2 times h square plus k square minus 4. Is it clear? Is this clear or not? So either h square plus k square is 0, which is not possible. Therefore, 2 times h square plus k square equals to 4 implies h square plus k square is 2. Therefore, the equation of the locus is x square plus y square comes to 2. That's it. Hence, option C is correct. Is it clear to all? Is this clear to all? Absolutely. Now you see, those who are thinking of not doing straight line first, they are really, staying in the foolish world, because everywhere your conception of straight lines will come. So you must know straight lines before doing circle, right? Okay, so what we have done here is basically, whenever you see everywhere this conception is coming, we have already done this homogenization in straight line. Now you see that thing is coming over here. So whenever the question of, I'm telling you, I'm just giving you a little quick revision, that whenever in the question they ask you that the pair of lines is making an angle, blah, 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 whatever, 90 degree means you are a blessed person, because if it is 90 degree, we will directly get the answer. But even if it is not, doesn't matter, because we know that the angle formed at the center is tan theta equals to this. We have already done. tan theta is 2 root over h square minus ab divided by a plus b. That is the angle. So whenever the two lines are making an angle at the origin, we will simply homogenize it and we will equate the angle which is given to us with this one. But if the angle is 90 degree, which is actually will come in the exam, because 99.9% केस में वो लोग always देते हैं कि the angle made at the center, I'm sorry, at the origin is 90 degree. So in that case, what we will do, after homogenizing, equate the sum of the coefficient of x square and the sum of the coefficient of y square equals to 0. So you will get your required or desired answer. Is it clear to all? Absolutely. Okay. So let us move for the next problem, which is this. What is the question? Find the locus of the middle point of the chords. Okay. Okay. So let me draw the circle. This circle is x square plus y square is a square. That is, the center is at the origin and radius is a units, right? Radius is a units. Okay. So this is my circle. The equation of the circle is what? X square plus y square equals to a square. Okay. Now, see this question very carefully. Find the locus of the middle point of the chords of the circle this, which subtend the right angle at this point. Now, the point is not the origin. This point is somewhere else. Okay? Okay, okay. So, what we will do is, let us say we are having the chords like this. Let us say the chord be like this. This is my chord. Okay, just one sec. This is my chord, let us say. Okay. Now, we have to find out the locus of the middle point of those chord, of this chord. Okay, which is subtending an angle c comma 0. C comma 0 is a point somewhere on the x-axis. So let us say the point be this point. You can take this point outside, no problem. You are going to have the same thing. So this point is c comma 0. Now in this question, you should not think of homogenizing, because we always homogenize when the lines are subtending at certain angle at the origin. Then we go for homogenizing. So for this question, we are not thinking about homogenizing. Is it clear? Okay, so what to do? How to find out? We have to find out the locus of this middle. But let us say this point h comma k be any point on the locus P. Let P be the any point which is h comma k. We have to find out the locus of this point. Now, my first question is, what is the equation of, let me give a name. Let us say this is A and B. What is the equation of AB? The equation of AB will be xh plus yk t equals to s1, right? So minus s square equals to h square plus k square minus s square. So s square goes off. So it is hx plus yk is h square plus k square. This is the equation of this chord bisected at the point h comma k. Now, what to do? Now, if I join these two lines, this angle, what they are saying is basically 90 degree. That is, they are saying that this angle is 90 degree. Now, how to find out? How to find out a relation between h and k with constants given? How to do it? Okay. Now, let me do one thing. From the center, if I join this line from the center, it will be definitely perpendicular to it. Yes or no? Because what I am actually thinking, I am thinking about finding out a relation between hk and constant. Okay, so this angle is 90 degree. What to do? This angle is 90 degree. So this is the origin O. Now, what is my OP distance? OP is basically root over of h square plus k square, right? And let me join the point A with O. Let me join the point A with O. This is the radius. This is the radius. This is 90 degree. But this is the 90 degree. But OA is basically the radius, which is nothing but your A in this case. Am I correct? So somehow whether if we can find out AP, then we will use the Pythagoras theorem for the triangle OPA to get a relation between HK and the constants. But how to find out this AP? How to find out this AP? That's a billion-dollar question. Okay. Now, if we draw a circle, taking AB as the diameter, it is definitely will pass through the point C, 0. If AB is the diameter, if you draw a circle by taking AB as a diameter, it is definitely going to pass through C, 0. Why? Because we all know that angle in a semicircle is a right angle. Am I correct or not? So in this case, your AB is the diameter. AB is the diameter. And A, B, C, all these 3 points are on the circle. Therefore, your AP, listen it very carefully, your AP, PB and PC, they are all equal. Why? Because they are the radius of the same circle that we have drawn by taking AB as the diameter. Am I correct? Therefore, what is your AP? Your AP is nothing but your, let me just give a name of this. Let us say this is Q. Point Q is C, 0. So AP is same as your PB, is same as your PQ, which is the radius of the same circle. Am I correct? And therefore, your PQ will give us nothing but root over H minus C whole square plus K square. And that's exactly what AP is all about. Now I can use the Pythagoras theorem in the triangle OPA to say that OA square is equals to OP square plus AP square. OA square is basically A square, which is equals to OP square. OP square is H square plus K square, and AP square is H minus C whole square plus K square. Am I correct? Now here you got a relation between the constants and H and K. Hence, this is the equation of the required locus. This is the equation of the required locus. Is it clear? And what is that? It's x square plus y square plus, let me just open this one, x square minus 2xc plus c square plus y square equals to a square. So we are having 2 times x square plus y square minus 2cx plus c square minus a square equals to 0. That's it. So that's the equation of the locus. Is it clear to all? Is this clear to all? Let me just summarize what we have done actually. What I told you, that whenever we find that any 2 points, 2 lines are making an angle theta with the origin, the first thing that we will come in our mind is that for homogenization, for homogenizing that curve with respect to that line. But here in the question, they have said that it is making an angle 90 degree, but not at the origin, but at some other point. Okay, so in that case, what I have done, I have to find out the locus. So I have to find out a relation between H, K and the constants given. Here the constants are C and A. So to find out, I have used the Pythagoras theorem in the triangle OPA. So for that, I need the length AP, because OP we know by the distance formula, OA we know it's a radius of the circle. The only problem that was creating was the length of AP. So for that, I have used a special conception over here. Please try to remember the method, not the sum, but the method. What I have done, I have simply drawn a circle by taking AB as the diameter. If AB is the diameter, it is definitely going to pass through the point Q. Remember this thing, since the point Q is making an angle 90 degree with AQ and BQ. The angle between AQ and BQ is 90 degree. That is why the circle is passing through this point when we have taken AB as the diameter. Because we know that the angle in a semicircle is always a right angle. But if this angle would have been something else, then we cannot say that the circle which is taking AB as a diameter will definitely pass through Q. No, it will not. Because the angle is not 90 degree in that case. But in this case, the angle is 90 degree. So definitely the circle is going to pass through Q. Is it clear to all? So it is passing to the point Q. So the moment we have only considered this conception, now it is clear that P is the center of this circle. Therefore, PA, PB and PQ, they are the radius of the same circle. Hence, they are equal. Therefore, AP will be nothing but PQ. We know the coordinate of P because it is any point on the locus, and we know the point of Q. The coordinate has been given to us. So we got the distance. And then we applied the Pythagoras theorem in the triangle OPA to get a relation between HK and the constants. And we got the equation of the locus. Very, very important sum from that point. Please try to remember the method. Again, I'm telling you, please try to remember the method. This method will be required. Okay. I have taken this point as C, 0. Your IIT people can, this question selector, they will give you a point, something else, somewhere else. But yes, the angle made at the center will be, at that point will be 90 degree. Okay. So then here you have to apply this same conception. Is it clear to all? Absolutely. Okay. So let me take another problem. A long time back, it came in IIT JEE 2012. So what is the question? The question is the locus of the midpoint of the chord of contact. There is a circle. The locus of the midpoint of the chord of contact. Okay. So what we have done, we have drawn two tangents here. Right? We have drawn two tangents here. And they have said that this is a point. This point is somewhere. This is the chord of contact, isn't it so? This is the chord of contact. This is the chord of contact. Okay. Now, let me just give a name. This is, let us say, this is my A, this is my B, let us say this is my P. Okay. Now, they are saying that this point, point P, is lying on a straight line. It is lying on a straight line. A straight line is there. It is lying on a straight line. Okay. From this point P, what is the equation of this straight line? Let me write it here. And the equation of the circle is x square plus y square equals to 9. So from any point on this line, I have drawn two tangents, PA and PB. AB is the chord of contact. AB is the chord of contact. Now we have to find out the midpoint of this chord of contact. The locus of the midpoint of the chord of contact. Its center is where? Its center is at 0, 0. And what about its radius? Its radius is 3. That's it. That much information we have. Is it clear? So let us say, let me denote this as Q because P we have already taken. So let this point be Q, be any point on the locus and the coordinate be H, K. Is it clear? So now how to find out? See, P is any point on this line. Let us say, from here we can write 20 plus 5y. So x can be written as 20 plus 5y divided by 4, isn't it? So if I say that point P, it is any point on this line. So let me take this point B, 20 plus 5 alpha over 4 comma alpha. Am I correct? This is any point on this straight line. I have taken y as alpha, so your x will be 20 plus 5 alpha divided by 4. So this is any point on this line. P is any point on this given line, right? Now, with respect to this point P, what will be the equation? What will be the equation of chord of contact? It is nothing but, can you remember? The equation of chord of contact is T equals to 0. So it will be x1 plus y1 is equals to 9. Therefore, the chord of contact, the equation of chord of contact is plus alpha 4 alpha y is equals to 36. Isn't it so? So it's basically, I'm simply writing it here, 5 alpha plus 4 into x plus 4 alpha y minus 36 is 0. This is what? This is the equation of the chord of contact. Am I correct? Now, we can think in a different way, because as I taught you, that whenever this chord of contact is coming, try to think. Definitely in the question, they will give you some conditions through which you can form the equation of the same chord of contact in a different way. Now, I can easily see they have asked me to find out the locus of the midpoint of the chord of contact. And the midpoint, I have assumed this thing as h comma k, because this is any point on the locus. So can we write equation of the chord AB is same as T equals to S1? Yes or no? I can write the equation of AB. This is the equation of a chord whose midpoint is h comma k. So you can write down the equation of AB in this way, T equals to S1. So in that case, what will happen? Let me just write it. Have you understood this? I'm writing the same equation in two ways. In this question, I've written AB because AB is also the chord of contact. So I have first found what is the chord of contact. And now I'm using the same thing, I mean the equation of the line AB by means of the midpoint of this chord is h comma k. So by using the formula T equals to S1, you are again going to get the equation of AB. Now what will be the equation of AB in this case? Let us check. T means xx1 plus yy1, that is your ky minus 9. This is your T. And what is S1? It's h square plus k square minus 9. Am I correct? So it's coming like hx plus ky minus h square plus k square equals to 0. That's it. This is what? This is again the equation of AB. This is equation of AB. This is also the equation of AB. So what do we have to do? Same. See? Is the funda changes? No. The conception remains same. I'm writing equation of a straight line in two different ways, and then I'm simply comparing the coefficients. That's it. That's the funda I'm using. Whether it's a problem came in JEE Mains or JEE Advanced doesn't matter to me. I will always use this funda. So how we will write? We will write that I will simply comparing the coefficients. So alpha plus 4 by h is equals to 4 alpha by k, which is equals to minus 36 over minus h square plus k square. That's it. That's it. Minus minus goes off. So now if we take these two cases, what we are getting? We are getting alpha over k is 9 over h square plus k square. So from here we are writing alpha is 9k over h square plus k square. Okay. Now let me take these two equations. So what we are getting? 4 alpha h is equals to 5k alpha plus 4. So 4 alpha h, 5k alpha, 20k. So from here we can write that your alpha is basically 20k divided by 4h minus 5k. Am I correct or not? Now, both are equals to alpha. Alpha I don't need because alpha is not a constant. Alpha has been chosen by me. So I have to remove it. So what we got? Let me write it here. So both are alpha equals to alpha. So I can write this thing as 9k over h square plus k square equals to 20k over 4h minus 5k. Yes or no? Tell me yes or no. Okay. So let me just cross multiply. Now you see, this is an equation which involves h, k and the constant. So this is actually my equation of the locus. So let me just do it in the next page. 9k h square. It's 9k h square plus k square, which is equals to, let me just copy the sum once again. 9k h square plus k square, then 20k 4h minus 5k. I think I'm correct. 4h minus 5k. Yeah. So if I now cross multiply, what we are going to have? 9 4s are 36kh minus 45k square. That equals to, oh, one thing I can do, I can cancel k from both sides, right? So let me just cancel k. So it will be 9 4s are 36 h, 9 4s are 36 h, 9 5s are 45k, which is equals to 20 times h square plus k square. So equation of the locus is 20x square plus y square minus 36x plus 45y equals to 0. Is it clear to all? Is this clear to all? Hence our option A is correct. Hence our option A is correct. Yes or no? Option A is correct, right? Now let us reveal the answer. Yes. So what we have done so far? What we have done so far? You see, I'm using the same conception here. Same conception. I'm trying to write equation of a line in two different ways. And what I'm doing? I'm simply equating. I'm simply comparing their coefficients to get the values of unknown. That's it. In this question, the equation of the line AB is not given. So I'm forming the equation of AB in two ways. One by chord of contact. Another one is finding out the equation of the chord by using the midpoint thing, right? Where T equals to S1. So forming the equation of the line AB in two different ways. And then we have compared the coefficients to get the value of unknown. Or in this case, to find out the locus. Is it clear to all? Absolutely. Okay. Now let us move for the next conception. Now it's a very beautiful conception. Very, very important as well as beautiful conception. See this one. Let me just draw a circle. Now you tell me one thing. Very simple logic. Don't see what is written over there. See what I'm saying. Suppose this is a line. Suppose this is a chord. Okay. This is a chord. Now this is the center. I have said that this chord, not only this chord, infinite numbers of chord are passing through a fixed point. Let me say this fixed point be x1 comma y1. Okay, this is that point. Now through this point millions of straight lines are passing. You can assume a straight line like this. You can assume a straight line like this. Millions of straight lines are passing through this point, right? Now, my question is pretty simple. My question is pretty simple. What is that? These are all the chords. My question is pretty simple, is that which chord will have the shortest length? That is, which chord will be the shortest chord of all those chords which are passing through the point x1, y1? That's the question. Now, see one thing. Suppose this is a line which is passing through the point x1, y1. Now, if you draw a tangent from the center, if you drop a perpendicular from this point on this chord, then what will happen? What will happen? This chord, this length of this perpendicular, more we approach towards the origin, that is, more we are closer to the center of the circle, the longer the chord is. More you move towards the center, that is, this perpendicular distance, when it becomes less, when the perpendicular distance is less from the center of the circle on that chord, then the length of the chord will start increasing. Are you getting my point? Are you people getting my point? Let me explain again. What I'm saying is, more we come closer to the center of the circle, the longest is the chord. And that is why when a chord, passes through the center, that becomes the diameter, and diameter is the largest chord. That is, more we come closer to the center of the circle, the longest is the chord. And more we go away from the center of the circle, the shortest is the chord. Yes or no? Now, in the same way, we can say more we come closer to the center of the circle, the perpendicular distance reduces. The perpendicular distance reduces. So we will say that the perpendicular distance means the distance between the origin, the center and the chord. This distance, as this distance reduces, the chord becomes larger. In both the ways you can remember. Okay. Now, what will be that chord which is the shortest chord but passing through the point x1, y1? Think about it. It is that chord in which your x1, y1 is the middle point. Hello? Okay, let me just write it. If it is little confusing, let me just write it. I'm giving a name of this. Let us say this is my C and this is my P. As CP, इसका नाम दे रहे हैं हम लोग, chord का नाम दे रहा है AB. Let us say, as CP reduces, AB increases. Yes or no? As CP increases, AB reduces. Yes or no? Yes or no? Okay, so if we take that chord, I want to find out the shortest chord which is passing through x1, y1. If I take, say, this chord, in which this x1, y1 is the middle point. x1, y1 is the middle point. So this distance will be the maximum distance of all those lines passing through the point x1, y1. Because if this point is not the middle point, because if this is the middle point, then this angle is 90 degree, right? So this is the perpendicular distance. This distance is the largest among all the lines passing through the point x1, y1. Why? Because if suppose this point, for this chord, let us consider this chord, x1, y1 is not the middle point. So if you draw a tangent, what will happen? If you drop a perpendicular, what will happen? This perpendicular length will be smaller than this perpendicular length. If this, because this is the hypotenuse, this is the perpendicular. So this length is smaller than this length. As this length is smaller, it means what? The chord is larger. Are you getting my point? Try to understand, try to visualize the thing. Therefore, the chord will be shortest passing through a particular point. If that particular point is the midpoint of that chord. It's a very, very important conception you must remember. So whenever a bunch of chords are given to you passing through a fixed point, then the length of the chord will be shortest if that point which is given, in this case x1, y1, is the midpoint of that chord. Is it clear to everyone? Absolutely. So this conception you people must remember. Okay? Okay, let me take some problem now. So in this question, it's a straightforward question. They have said for a circle x square plus y square equals to 64, find the equation of the length of the shortest chord which passes through the point 5, 4. So just now we have learned the theory that this will be the shortest chord when 5, 4 is the midpoint of that chord. Therefore, the equation of the chord will be t equals to s1. Okay. So what is the equation then? 5x plus 4y minus 64, which is equals to 5 square plus 4 square minus 64. Correct? 64 goes off. So it is 5x plus 4y equals to 25 plus 16, that is 41. Okay. Therefore, the equation of that chord, which chord? The shortest chord. The equation is 5x plus 4y equals to 41. Okay. Now you see, this is the circle. What we have to find out? We have to find out the length of this shortest chord. Now we know that this is our equation. The equation of this is the shortest chord, let us say. So this is the center, which is 0, 0. And let me just draw a perpendicular on that. And let me join this one. Now, we have to find out the length of AB. We have to find out the length of AB. So for that, I am taking this right angle triangle OCB. Now, first thing is that what is the perpendicular distance OC? This is the equation of the line. So the perpendicular distance from the origin will be divided by root over 5 square plus 4 square, correct? Is it clear? So in that case, it is minus 41 divided by 25 plus 16. Again, we are having it's 41 over root 41, correct? So it is coming to root over of 41. So that is the length of OC, the perpendicular distance from the origin to that line AB, which is the shortest chord. Now, OB is basically the radius of the circle, which is your 8. Therefore, what is the length BC from the Pythagoras theorem? We will write it is root over of OB square minus OC square. What is OB square? That is 8 square minus OC is root 41 square. So we are having root 64 minus 41. So that gives us root over of 23. Is it clear? Therefore, the length of BC is root 23. But we need to find out the length of the chord AB. So AB is 2 times BC, which is 2 times root 23. Clear? Therefore, the equation of the shortest chord is 5x plus 4y is 41. And the length of the shortest chord is 2 root over of 23. Is it clear to all of you? Absolutely. No doubt. Okay. So what we have learned so far? in this conception, we have learned that among all the chords passing through a fixed point, which is inside the circle, the shortest chord will be that chord for which the point which is given is the midpoint of that chord. So that will be the shortest chord. Is it clear to all? Absolutely. Let us take a next problem. The question is, find the locus of the midpoint of the chord of a circle. A circle is there. A circle is there. The locus of the midpoint of this circle, the chord of the circle, we have to find out the locus of the midpoint of this chord. Let us say h comma k be any point on this chord, okay, whose center is at the origin and radius is 2 units. What is the radius? Radius is 2 units. Is it clear now? So now we have to find out the locus of this point such that the segment intercepted by this chord on the curve, this is a curve. I don't know how this curve will look like, and no need to know that. Suppose there is a curve like this. Let us say this is a curve. Okay, let me draw it properly. Let us say the curve is like this. Now, let me just draw it properly. Let us say it is like this. Okay, so in this case, now I know that it will be a parabola. That is why I am doing it. Even if you don't know the nature of the curve, it doesn't matter. It's a curve, and this chord is what happened. This chord is intersecting this given curve at 2 points. Let us say the point be A and B. Now see the question what they have said. They have said that this segment intercepted by the chord on this curve, on which curve? X square equals to 2 times x plus y. For this curve, this segment is subtending at an angle 90 degree at the origin. Can you understand what we have to do? This is the origin, let us say. Now it is subtending an angle 90 degree at the origin. So the first thing that will come in our mind is that we have to go for homogenizing. We have to go for homogenization. Yes or no? And we have to homogenize this curve, the given curve, with respect to this line. This line is what? This line is the chord of the circle. Okay, now what will be the equation of the chord? Equation of the chord. What is the equation of the chord? It is nothing but t equals to s1, and the midpoint is h comma k. Therefore, what is t? Hx plus ky minus 4 equals to s1. S1 is what? H square plus k square minus 4. So from there we are getting the equation of the chord as hx plus ky equals to h square plus k square, right? So now we can write this thing in this way. Which is equals to 1. Now this is the equation of the chord. From there I have written the equation of the chord in this form. Why I have written this form in this way? Because I have to now homogenize. You have to homogenize this curve. So what I will do? X square equals to 2 times x plus y into hx plus ky by k square plus h square. Am I correct? So let me just cross multiply. Equals to 2 times x plus y hx plus ky. So if I multiply this, we are going to have 2hx square plus 2kxy plus 2hxy plus 2 times ky square. Am I correct? Now, the coefficient of x square is what? It's h square plus k square minus 2h. And what is the coefficient of y square? Coefficient of y square is 2k only. Okay? Is it clear? Now, since the angle subtending at the origin is 90 degree, therefore, the sum of the coefficient of x square plus the coefficient of y square, that must be equals to 0. Therefore, the equation of the locus is x square plus y square minus 2x plus 2y equals to 0. That's it. So, can you see? If you remember how to homogenize an equation, and whenever in the question they are saying that these two lines are subtending at some angle at the origin, then we will always go for homogenizing that equation with respect to that line. And thing becomes very simple. Is it clear to all of us? Okay, so what is the locus? Let me reveal this. Oh my God, why this minus 10 came? Have I done anything wrong? Yes, I have done. Because when this y square will come in the left hand side, it will become minus 2k, isn't it so? So this one will be minus 1. Yes. So the locus is basically minus 2k, so minus 2y. Have you got this one? Have you understood the logic behind it? Absolutely. Okay, so let us move for the next problem. See this question, this came in JEE Main 2023. Let us try to understand the problem first. They have said that there is a circle whose center is at 4,5 and the radius of this circle, this is my C1 circle, is 2, right? What is the radius? Your radius is 2. Now in this circle, I have taken a chord. I have taken a chord which is subtending an angle pi by 3 at the center of this circle. This angle is pi by 3, that is 60 degree. Clear? Now, you have to find out the locus of the midpoint of this chord. Is it clear? We have to find out the locus of this midpoint of this chord. Let us say this point be h comma k. So what will be the equation? What will be the locus of the midpoint of this chord which is subtending an angle 60 degree at the origin? Is it clear? This is the midpoint. H comma k, let me give a name P. Let us say the origin be C. I mean the center be C. Then what is the equation of the locus of the point P? So how to do this one? This is such a chord. I'm not finding out the locus of that chord which h comma k, that is P, is the midpoint only. That is not the only criteria here. The criteria is midpoint to hogai. We have to find out the locus of that point. But at the same time, that chord is extending an angle 60, subtending an angle 60 degree at the origin. उस सारे chord का locus क्या होगा? That's the question. So for that, what I am doing, I am drawing a perpendicular. It will be a perpendicular. This is 90 degree, right? Now, if this angle, the angle subtended at the center of the circle is 60, so this angle will be 30 degree. Okay? and the radius of this circle is 2. The radius of this circle is 2. Then tell me, what is the perpendicular length CP? What is the perpendicular length CP? Now from the triangle CAP, look it carefully. This angle is 30 degree. So what will be your CP? CP over AC is cos 30 degree, right? That is root 3 by 2. So what is CP? CP is AC into root 3 by 2. And the length of AC, which is the radius of the circle, is 2. So it is coming to 2 times root 3 by 2. That gives us root 3. Okay. So length of CP is root 3. Then what is the locus of point P? What is your CP? By the distance formula, we can say this is equals to root over of h minus 4 whole square, k minus 5 whole square, and which is nothing but your equals to root 3. Is it clear? Therefore, the locus of the midpoint of those chords subtending an angle 60 degree at the origin, I mean at the center, is x minus 4 whole square plus y minus 5 whole square, that is equals to 3. 3 means it's basically root 3 whole square. So this is the locus of that point. That is the point P. Now we can clearly see that it is basically a circle whose radius is root 3. That is, according to the given problem, R1 in this case, because we have considered the first case, in this case your R1 comes to root 3. Am I correct or not? Okay. Now the same thing is happening for 3 cases. This is the first case I have considered when I have considered your theta 1 is pi by 3. Now for the second case, I don't know that angle. This angle has to be found. Now for the third case again, your theta 3 is 2 pi by 3. That is 120 degree, right? The case will be exactly the same case. The only difference is that this between angle is basically 120 degree. Tell me yes or no. This angle is 120 degree. That is, this angle will be the half of that angle will be 60 degree. Yes or no? So this is your third case. This is your third case. So what will be the locus? The locus will be exactly the same thing, root over h minus 4 whole square plus k minus 5 whole square. But in this case, what will be your CP? Think about it. What is CP? CP by AC is basically cos 60 degree. So what is CP now? In this case, your CP is half into AC. AC is basically the radius of the given circle, which is 2 in this case. Therefore, your CP is nothing but 1. So I can write this thing as 1. So again, what will be the locus for the third case? That is h minus 4 whole square plus, let me just write this thing as x only, because we know that this is the locus. So x minus 4 whole square plus y minus 5 whole square, that is equals to 1. Therefore, this locus is what? It's a circle whose radius is 1. That is, R3 is 1. Are you getting my point? R3 is 1 in this case. So now you know R1, you know R3. From this condition, we can easily find out what is my R2. R1 square is R2 square plus R3 square. So R1 square is what? It's 3. R2 square I don't know. And R3 square is 1. Therefore, we got that R2 square is basically 2. Implies your R2 is root 2. Tell me yes or no. That is the locus for the second case when it is making an angle theta 2 at the center of the circle. In that case, the locus will be again a circle whose radius is root 2. That much we have understood. Now we have to find out what is this theta 2. Okay, so let me consider this case again. The only thing is that now this length is what? This whole angle is your theta 2. So this much is how much? It's theta 2 by 2. Yes or no? This angle is how much? It is theta 2 over 2. Is it clear? Now again from the triangle APC, what you can write? What is cos theta 2 over 2? It is your CP over AC. So what is your CP now? What is CP? CP is basically AC. AC is 2. So 2 times cos theta 2 over 2. Are you getting my point? This is your CP, right? Therefore, the equation of the locus will be x minus 4 whole square plus y minus 5 whole square in the similar way. Only thing is that in this case of 1, I'm going to write 2 cos theta 2 over 2 whole square. That's it. Is it clear? Is this much clear to you? In this case, you will exactly use the same form. In the right hand side, you will write what? 2 cos theta 2 by 2, because that is the length of CP. So if I square both sides, we are getting the equation of the circle like this. Clear? Now, what is the radius of this circle? This is the locus of the second case. And what is the radius of this second circle? It is 2 cos theta 2 over 2. Now, by the problem, this is nothing but root 2. Therefore, your cos theta 2 over 2 is root 2 over 2. That is 1 over root 2. So, cos theta 2 over 2 is basically cos 45 degree. Yes or no? Therefore, theta 2 is nothing but 90 degree or pi by 2. Is this clear? Very simple sum. Though they have made this thing little bit not critical, I should say, because they are considering the same thing 3 times. First time the angle made at the center is pi by 3. In the third case, the angle made subtended at the center of the circle is 2 pi by 3. And in the second case, the angle which is made at the center, that they have not said. The question is, you have to find out that angle. But one relation is given. R1 square equals to R2 square plus R3 square. So from there we are getting the radius of that locus for the second case. And so after calculation, we are getting theta 2 is 90 degree. Hence your option D is correct. Now, if you have not understood this sum at first time, what I will request you, after the class, you rewind this part of the video and see it again. Then you will understand it. Is it clear now? Absolutely? Okay. So now let us come to the next point, which is called combined equation of pair of tangents. Combined equation of pair of tangents. No proof is required for this one. Simply remember how I'm doing. They have said that suppose there is a circle. This is my circle, which is already given here as your S equals to 0. This is your S equals to 0. Now, we are drawing 2 tangents from an external point. Let us say this is one tangent and this is another tangent. Now, we know how to find out the equation of these tangents. We know that if the external point, let us say x1, y1 is given, we know how to find out this equation because we have already done it. Now, what I want to do is, I want to write those tangents, equation of tangents is in one equation. So, it is what is called your combined equation of the pair of tangents. Now, you can do it very easily. After finding out the equation of the tangents, you can combine these two. That way you can do. But other than doing this, other than not finding the equation of the tangents, you can directly write that the combined equation will be S1 equals to T square. You know what is S, you know what is S1, as well as you know what is your T. So remember this, S1 equals to T square. This is the combined equation of the tangents drawn to the circle from an external point x1, y1. That's it. No proof is required for this. Simply remember this as a formula. Okay, let me now take a question. If a point 1, 2 is translated 2 units to the positive direction of the x-axis. What do you mean by that? There is a point, let us say a point is here somewhere, which is 1, 2. This point is, let us say 1, 2. Now this point has been translated 2 units to positive direction of the x-axis. That is, you have moved this point 2 units in the positive direction of the x-axis. This length is how much? This length is 2. So what will be the coordinate of this point? The coordinate of this point will be nothing but 3, 2. Is it clear? Now, from this point, now have you understood this? Then let me just erase this. So the point is basically 3, 2. Now there is a circle. What is that circle? The circle is x square plus y square equals to x square plus y square equals to 9. So this is that circle. Okay? This is this circle. Now where is the point? The point is somewhere here. It is 3, 2. Is it clear? Now what they have said, now the tangents are drawn from that point to this circle. You have drawn tangents to this circle from this point. So let me draw 2 tangents, like this one is the first tangent, let us say, and the second tangent is something like this. Okay. Now you have to find out the angle between these 2 tangents. You see, we already know how to do this one. We know how to find this one because we know that the angle between these 2 tangents, tan theta, will be what? It is 2 times, in this case, a root s1 divided by s1 minus r square. Yes or no? R square, if I write r, then I have to write r in the numerator also. Okay, so otherwise it's better to write a because I have already written a in the numerator. So it will be s1 minus a square. That's it. That's it. So that way you can find out. That's no problem with us. But what I will try to do here, I will try to use this combined formula to find it out. Though it may seem that it is little bit complicated, but here I am taking a simple example to illustrate the fact what we have said. Maybe in some problems it will be needed for us. Okay. So in this case, I will simply apply the combined formula for these tangents. And the combined formula we all know is your S1 equals to T square. Right? The equation of the circle is what? X square plus y square minus 9. This is your S. So what will be your S1? Simply in place of this expression, you put 3 and 2 in place of X and Y. So it's 9 plus 4 minus 9 equals to T square. T square is the form of the tangent. So it will be 3x plus 2y minus 9 ka whole square. So it is basically coming to 4x square plus y square minus 9 equals to 3x square plus 2y minus 9 whole square, right? This is the combined formula. This is the combined formula for these 2 tangents. This is not square. Am I correct or not? Okay. Now, sir, what to do? See, this is basically, since it is the combination of 2 tangents, means it represents a pair of lines. And we know that the angle between 2 pair of lines when it is given by the general second degree equation form, we all know that the angle between them is nothing but 2 root over h square minus ab divided by a plus b. Again, this I have completed in your straight line lecture. So tan theta is 2 root over h square minus ab. What is a? This is the coefficient of x square. A is the coefficient of x square. B is what? Coefficient of y square. And what is h? H is basically the coefficient of xy divided by 2. That is your h. Am I correct? So now, how to find out the coefficient of x square? Don't try to open the thing because that will consume a time. Simply you find out what is the coefficient of x square. In the left hand side, we are getting 4. And from the right hand side, if we open, we are going to have 9. So when that 9 will come in the left hand side, it will be minus 9, which is nothing but the coefficient of x square only. What about the coefficient of y square? In the left hand side, we are having 4. And in the right hand side, we are having again 4. So when it comes in the left hand side, it will become minus 4. So it's minus 5 and this is 0. And what about your h? H is the coefficient of xy. Coefficient of xy you are going to have from this part only. Twice AB means it's 2 into 3x into 2y. So it is coming to 12xy, right? When it comes in the left hand side, it will become minus 12xy. So what is the coefficient of xy? It's minus 12 divided by 2. So it's minus 6. Am I correct? So A you got, B you got, H you got. So what will be the angle between these two lines? I will use this formula, this one. Tan theta will be 2 times root over of h square minus AB, which is 0, divided by A plus B. A plus B. So that gives us minus 12 over 5. Is it clear? इसका मतलब क्या हुआ? Your tan theta is coming to negative means this angle is basically an obtuse angle. This angle is an obtuse angle. Okay. So if tan theta is minus 12 by means theta is an obtuse angle. So theta by 2 will be guaranteed an acute angle. If theta is an obtuse angle, so theta by 2 is definitely an acute angle. Okay. So tan theta, we know from the basic trigonometry that tan theta can be written as 2 tan theta by 2 divided by 1 minus tan square theta by 2. You can leave your answer over here also. There is no harm. But if we try to get the answer in positive value, that is why I'm trying this one. So tan theta is 2 tan theta by 2 by 1 minus tan square theta by 2. Tan theta is basically minus 12 over 5. So 2 tan theta by 2, 1 minus tan square theta by 2. So let us cancel this 2 and 2. So it's coming like minus 6 over 5 is tan theta by 2 divided by 1 minus tan square theta by 2. Let me cross multiply. So what we are getting? Minus 6 plus 6 tan square theta by 2 is equals to 5 tan theta by 2. Now let me take this thing in the left hand side. So we are having okay. So let me factorize this. 6 6 is 36. So minus 9 tan theta by 2 plus 4 tan theta by 2 minus 6 is 0. So if we simplify this, 3 tan theta by 2, let me take common. So it will become 2 tan theta by 2 minus 3, right? Plus if I take 2, so it is tan theta by 2 minus 3 equals to 0. So it is 2 tan theta by 2 minus 3, 2 tan theta by 2 plus 2 equals to 0, correct? So either your tan theta by 2 will be 3 by 2 or your tan theta by 2 will be minus, I think it's 3. Okay, so minus 2 over 3, right? But as we know that theta by 2 is an acute angle, hence tan theta by 2 cannot be minus 2 over 3. Therefore, your tan theta by 2 is coming to what? 3 over 2. Therefore, theta is coming to what? 2 tan inverse 3 by 2. That's it. This is simply an answer getting in the positive value. Otherwise, you would have written the answer, you have lived the answer over here only, minus 12 over 5. Is it clear now? So the answer, the angle between the tangents is 2 tan inverse 3 by 2. So what we have done actually, we have learned a different way of finding out the angle between the two tangents drawn from a point which is outside the circle. This is one way of doing. You see, we have to know all the methods because I don't know which one will be applied when. Getting my point? So you must know the method. You can say me, "Ki sir, this method is long method. Why should we go for this? We know the easy method." I accept your all things, but still I'm telling you, do remember this method because it may so happen that in some cases, because I don't trust IIT Advanced, because advanced questions will be like that, where maybe, I don't know, maybe we won't be able to find out the equation of the tangent in a simpler way. But again, we have to find out the angle between those tangents. So in that case, we will use this method to do it quickly. That's the reason why I told you, please do remember this method. Is it clear? So that's all about this lecture. So I will see you in my next lecture with the next part of the circle very soon. Till then, stay tuned to us and subscribe, share, and like the video. Thank you so much.
Well, today we are going to start with our first class of circle. I have already completed straight lines, which you people, if you have not seen, you can see the videos in my playlist, in that playlist named Straight Lines. So you can check it there. So today we were going to start with circle. And in this class, we are going to cover the basic things of circle. And they are, first, the definition, then different forms of circles. Center radius form, standard form, general equation, concentric circles, diametric form of circles, and last but not the least for this lecture is the parametric form. So let us start our class with the definition. Now, what is a circle? A circle is basically a moving point moving in a plane in such a way that it always maintains a fixed distance from a fixed point. This we all know from very childhood. We all know from very childhood that a circle is always having two things. One is its center, another one is its radius. And this radius is fixed for a particular circle. So in our higher classes, in class 11, we are defining this in terms of locus. It is basically a moving point moving in a plane in such a way that it always maintains a fixed distance from a fixed point. And this fixed point is what called the center of the circle. And this fixed distance is what called the radius of the circle. So for a circle, whenever we are discussing circles, even in the problems when we will do afterwards, we will only concern about two things. Always remember, we are always concerned about two things. One is its center, another one is its radius. Okay? So now let us come to different forms of circles. First is, which is called your center radius form. Now we are going to find out the equation of the circles, right? Now, when the center and radius is given to us, this is a very basic form of the circle. Whenever your center and your radius is given, how to find out the equation of the circle? Suppose the center given is alpha comma beta, and let us say the radius is say r. So how to find out the equation? We will say let h comma k be any point on the locus. Locus का मतलब क्या है? यहाँ पर we have to find out a relation which contains hk and the given constants. So for this, if I find out what is the distance from the center to that point, it will be under root h minus alpha whole square plus beta minus k whole square, right? This is by using the distance formula. And this is exactly which is equals to your r. Because r is the distance between this center alpha beta and the variable point hk. Therefore, the equation of the locus becomes x minus alpha whole square plus y minus beta whole square, which is equals to your r squared. So this is what is called your center radius form. Again, I'm telling you, this is the very basic form of a circle. Okay, when we know the center and when we know the radius. Okay, and the second form is a standard form. What is a standard form? Standard form is that we always consider the center to be at the origin. And let us say the radius be a or r, whichever way you take. Therefore, the equation of the circle will be x square plus y square equals to a square. That's it. So this is the standard form of any circle. Standard form means we always consider that its center is at the origin and radius is a units. Is it clear to all, everyone? Center radius form and standard form. These are the two forms we have learned so far. Okay, let us take some problems on that. See this question. The question is find the equation of the circle having 1 comma minus 2 as its center. So now you know its center. And as I told you that whenever you are solving circle problems, always remember two things. Always remember two things. One is your center and another one is your radius. Always try to find out these two things. So center we know. And it is saying that it is passing through the point of intersection of these two straight lines. Now quickly, if I solve these two equations, what we are going to have? So if we subtract so y is coming to 1, and if I put y in the first equation, we are getting So x is coming to 13/3. Is it clear to all? Oh, I'm sorry. I have done one mistake over here. I'm multiplying this with 3, right? Not 2. I'm multiplying this with 3. So here I have done a little mistake. This calculation mistake. Just 1 second. So if I multiply that with 3, we are getting, because I have multiplied this with 2 to get the first one, and the second one is, right? Now, if I subtract, we are getting minus 13y equals to, we are having minus 26. That gives us y is 2, right? If I put y over there, we are getting 3x as, so x is coming to 4. Therefore, the circle is passing through the point 4, 2, and its center is 1, minus 2. Therefore, its radius will be, root over 4 minus 1 whole square plus, so that gives us 5. So radius is 5 and center is 1, minus 2. So naturally, we will find out the equation of the circle by using our center radius form. X minus 1 whole square plus y plus 2 whole square equals to the radius square, which is your 5 square, which is 25. So if I expand this little bit, so we are getting x square plus y square minus 2x plus 4y minus 20 equals to 0. Is it clear? Pretty simple sum, but very good sum for initial practice. So I hope you have understood this center radius form of a circle. Let me take another problem of this kind. They have said if the two diameters of the circle lie on the line x minus y minus 9 equals to 0 and x minus 2y minus 7 equals to 0. These are what? The equation of the diameters. The equation of the diameters of the circle, right? And we all know that for any circle, diameters means what? It is passing through the center. It is passing through the center. Isn't it so? So these are the two diameters. Now think about it. If I solve these two diameters, I mean the equation of these two diameters, what we get? We get the center of the circle, right? We get the center of the circle. So let me just quickly solve these two equations. I mean the equation of two diameters. So what we are going to have? And x minus 2y minus 7 is 0. So simply subtract. So you are going to have y minus 2 equals to 0 implies y is 2, right? If y is 2, you are getting x as 11. Therefore, the center of this circle is at 11, 2. Okay. Now what we need? We need the radius. We need the radius of the circle. And for that, if you see, we have been given a second condition that the area of the circle is 38.5 square units. We know that area of any circle is pi r square. So pi r square is basically 38.5. Therefore, your r square is coming to 38.5 divided by pi, which can also be written as, okay? So now we can write this. It can be written as 385 over 10 into 7 over 22. Okay. So now if we divide 385 by 11, we are getting 35. So that's 2. This is 35, right? So we are actually having uh, 20 here. 35 into 7, don't multiply this. You can write this thing as uh, 7 into 7 into 5. So cancel this one, again 4. So it's basically 7 over 2 whole square, right? Therefore, our R comes to 7 over 2. Your R is 7 over 2. So two things we need. We got two things. We got the center, which is 11, 2, and we got the radius 7 over 2. Therefore, the equation is the center radius form, which is your whole square. So we are getting what? This right after simplification, you are going to have this. So I'm not doing the calculation. You can do this calculation by yourself. Okay. So that is the equation of this circle. So have you understood this? Have you understood this? What I have done? Here, again, I'm telling you in these two problems, what we have mainly focused on. First of all, find out its center, and then you find out the radius. The moment you get the center and radius, you know the equation of the circle. As simple as that. Throughout this whole circle chapter, we will do exactly this thing. We will try to find out its center and we will find out its radius to get the equation of the circle. Right? That's exactly what I have done here. Again, I'm telling you the calculation I have not done. You can do it by yourself. Okay. So now let us come for another form, which is called your general equation of a circle. We will learn general equation of a circle. Right? See, the general second degree equation, we have already learned this thing in straight line chapters. So there we have learned that general second degree equation is of the form okay. Those who have not revised straight line, please revise straight line. So this is the general second degree equation, and this general second degree equation will represent a circle. This will represent a circle when A is equals to B. This is the first condition, that your A has to be equals to B. What is A? This is coefficient of x squared must be equals to coefficient of y squared. This is the first condition. And the second condition is that there should not be any term containing xy. There should not be any term containing xy. That is, your h has to be equals to 0. So these are the two conditions we have to remember. First is what? Your coefficient of x square and coefficient of y square, they must be same. And what is the second condition? There should not be any term containing xy. Is it clear? So now, this general second degree equation will transform into, for the simplicity of the problem, let me take A equals to B, because A has to be equals to B if it represents a circle. Let us take A equals to B equals to 1. Okay. So this general second degree equation will transform into x square plus y square plus 2gx. plus 2fy plus c equals to 0. And this is what is called the general equation of a circle. This is what is called general equation of a circle. Clear? It is called the general equation of the circle. Now the big question, what is its center and what is its radius? So what I will do here is, I will transform this equation into center radius form. And for that, I'm doing a simple calculation. Please check this one. So let me just add g square and f square in the left hand side. Similarly, g square plus f square in the right hand side. So we are having this as x plus g whole square, y plus f whole square equals to root over g square plus f square minus c whole square. Is it clear? So now this form is your, which form? This is your center radius form. And from this form, we can say that the center of the circle is minus g and minus f. How I'm saying that? You simply put x plus g equals to 0. From here, we are getting x is minus g. And you put y plus f equals to 0. From here, we are getting y as minus f. And that is the reason why I told you the center will be minus g minus f. Let us just refer to the previous slide. Say in this, the equation was this. This is the center radius form. What is its center? Its center is, if you put x minus alpha is 0 and y minus beta is 0, we are getting x as alpha and y as beta. That's exactly what we got here. And what is the radius? Radius is whatever there is in the right hand side, uska jo square. Here r square is there, so radius will be only the r. Right? So same thing here also. Same thing in this also. So here we got the center as, by putting x plus g equals to 0, we got minus g and minus f. And what is its radius? Its radius will be whatever there is in the right hand side, uska square. Matlab, your radius is basically root over g square plus f square minus c. That's it. That's it. So whenever this general second degree equation is given, its center will be always at minus g comma minus f, and radius will be root over g square plus f square minus c. Now a question will come, sir, if general equation of a circle is given to us, so every time do I have to go for all this thing to convert that thing in radius, center radius form, and then we can predict about its center and radius? Answer is no. Simply by observing this result, you can find out its center and radius instantly. The moment you see the general equation of the circle is given, you can easily find out its center and radius without converting it in the center radius form. How it is? Please observe this result. What is your g? G is basically the coefficient of x divided by 2. So how we will remember to find out the center? Its coefficient of x divided by 2, and plus sign was there and here it is minus sign, so change the sign. Remember in this way. the abscissa of the center will be coefficient of x divided by 2, change the sign. Similarly, coefficient for the ordinate of the center, coefficient of y divided by 2, which gives us f, because coefficient of y is 2f, divided by 2 gives us f, and change the sign. So its center will be minus coefficient of x divided by 2 minus coefficient of y divided by 2. But remember one thing, it is only possible when the coefficient of x square and y square is 1. कोफिशिएंट ऑफ एक्स स्क्वायर एंड वाई स्क्वायर जब 1 होगा तभी ये शॉर्टकट फॉर्म हम यूज कर सकते हैं. यू कैन यूज दिस फॉर्म only when the coefficient of x square and y square is 1. Now the question will come, sir, if the coefficient is not 1, then what to do? If you find that the coefficient of x square and y square is not equals to 1, forcefully make it 1. Forcefully make it 1. How I will do that? Suppose if the question was 5x square plus 5y square. What I'm saying is, if the equation would have been in this form, now here what we can see, the coefficient of x square and y square is not 1. So we cannot find out the center by using this shortcut way. We cannot use this formula. So what I have to do, I have to make the coefficient of x square and y square equals to 1 to use the form. Okay, so what I'm doing here is I'm simply dividing by x by 5. So if I divide by 5, both sides of the equation, we are going to have okay. Now you can predict about its center. Its center will be coefficient of x, that is 2g by 5, divided by 2, which gives us g by 5, and change the sign. So it will be minus g over 5. Similarly, coefficient of y, which is 2f by 5, divided by 2, which is f over 5, and change the sign. So it will give us minus f by 5. Is it clear? So what we have learned, we can use this form. We can use this shortcut method of finding out the center if the coefficient of x square and y square both are equals to 1. And if it is not, forcefully, as I shown you here, forcefully you have to make it 1. And then you can find out its center. Now, finding out its radius is pretty simple if you observe it. We see that your center is minus g minus f. So how you will find out radius? Remember in this way. You will simply write whatever coordinate, whatever abscissa you got for the center, uska square, matlab minus g ka square. So that will give us g square only. Then plus ordinate of the center ka square, matlab minus f ka square, which gives us f square. Is it clear? सेंटर जो आया, जो कोऑर्डिनेट आया, उन दोनों का स्क्वायर करके सम करो and minus the constant term given in the equation of the circle. Right? So now we know how to find out the center by using this shortcut form, and then we can easily find out its radius. Two things very clear to us. Okay, let me take a problem based on this, but before that, let me just discuss about the nature of circle. See, for the circle, for the general equation of a circle, we got center at minus g minus f, and radius is root over g square plus f square minus c, correct? Now, the moment you see that your radius is coming within something, root sign is coming, right? The moment this root comes, we are having three conditions. We are having three conditions. One is that if your G square plus F square is greater than C, if G square plus F square is greater than C, then we are getting a real circle. Isn't it so? Because under the root sign, you are having something positive value. So that root is defined. So you are getting a real circle whose center is at minus G minus F and radius is root over G square plus F square minus C. Now, if G square plus F square is equals to C, then what happens? Your radius becomes 0. But still you are having your center. Center is there, minus G minus F, but your radius comes to 0. It represents a point circle. So what is a point circle? A point circle is having its center, but it is having no radius. That is, the length of its radius is 0. That is what is called your point circle. Is it clear? So it is possible only when G square plus F square equals to C. And obviously, if G square plus F square is less than C, then under the root sign, you are getting some negative value. So you are not going to have real circle. Then it will be an imaginary circle. Is it clear? So nature of circle is clear. 3 things we have to remember. If G square plus F square is greater than C, you are getting a real circle having real radius. If G square plus F square becomes equals to C, you are going to have a circle whose radius will be 0 and it is termed as point circle. And if G square plus F square is less than C, then you will say no such circles are possible. So this kind of circle is what called your imaginary circle. No real circle possible if G square plus F square is less than C. Okay. So now let us find the center and radius of this circle. Look it very carefully. I told you that I can use my shortcut form if your coefficient of x and y, x square and y square, are 1. But here it is not 1. So what I will do, I will simply divide both sides by 36. So we are getting something like this. Yes? Now what will be its center? Apply the formula. Coefficient of x divided by 2, change the sign. Okay? Coefficient of x, which is your 1, divided by 2, which is half, change the sign. Minus was there and I've written plus. Coefficient of y, it is minus half, you can take. Divide by 2, so it's 1 over 4. Change the sign, so minus will get positive plus. So your center is coming to half, comma, 1 over 4. Now what will be its radius? How to find out radius? Root over 1 by 2 whole square, 1 by 4 whole square minus its constant. Constant is 11 over 36. So we are getting under root. Okay. So we can write this thing as, it's, let us say, 9. Don't do it in this way. Let me do one thing. Let me take the LCM of this. Let me take LCM of this. What we are getting. From here we are getting 4, 16 and 36. Let me take the LCM of that. 4. It's 1. Then coming to. So I can easily take, okay, 4. Okay. So it's 16 into 9, right? So let me take the LCM. 16 into 9. So this is coming to 36. This is coming to 9. And this is coming to Have I done anything mistake? This calculation error, 16 into 9 we are getting now. 16 into 9, yeah. 9 fours are 36, so it's 4. So it's coming to 44, right? And it's complete root. So we are actually having 45, so it's 1 over 4 into 3. That gives us 1 over 12, right? Therefore, the center is half, comma 1 by 4, and your radius is 1 over 12. Is it clear to all? Is this clear to all? Okay. So what we have learned, whenever the general form is given to us, we always check that the coefficient of x square and coefficient of y square should be equals to 1. If it is not, we will forcefully do that, and then we will straight away find out its center and radius, right? By using that formula. Okay, the shortcut form. Okay, now let us see this question. If the equation this represents a circle, now I told you that general second degree equation will represent a circle when it is fulfilling two conditions. One is coefficient of x square must be equals to coefficient of y square. In this case, coefficient of x square is lambda, which is equals to the coefficient of y square, which is 2 lambda minus 3, right? So first of all, the coefficient of x square must be equals to coefficient of y square. And second was what? There should not be any term containing xy. But in this question, there is no term containing xy. So don't consider this condition right here. So from here we are getting your lambda is coming to 3. Tell me yes or no. Your lambda is coming to 3. Then this general second degree equation will represent a circle. Now, if I put lambda equals to 3 over here, we are getting 3x square plus 3y square minus 4x minus 1 is 0. So simply divide by 3. Okay. Now we have to find out its radius. But before that, we have to find out the center. Where is it centered? Coefficient of x, which is minus 4 over 3, divided by 2, which is 2 over 3, and change the sign. So it will be plus 2 over 3. And there is no y, so the ordinate of the center will be 0. And what is its radius? Its radius will be root over 2/3 whole square minus of minus 1/3. So you are getting 4 over 9 plus 1 over 3. So it's coming like root 7 over 3. Yes or no? Okay. Hence option C is correct. Have you understood this problem? Absolutely. If you have any doubt, you can write in the comment box. So I will definitely get back to you. So therefore, your option is C. So what we have learned from here is that whenever a general second degree equation is given, as I have mentioned in the previous slide, that you must always see that the coefficient of x square and coefficient of y square, they're same, and there should not be any term containing xy. And after getting this, you can easily, because moment you have the equation of the circle, you can find out its center, you can find out its radius too. Okay, so that's exactly what I have done here. Okay, let us take another problem. See this question, very important question. Let me tell you one thing. I will do this problem. I will find out what is the area of the equilateral triangle inscribed in a circle. But I will request all of you to remember this result. To remember this result, very, very important, because this result will be needed everywhere. Okay, so let me just choose a right angle triangle. I'm sorry, equilateral triangle. So this is our equilateral triangle. And let us consider, already they have given the equation of the circle is x square plus y square plus 2gx, the general form. So from here we can say that my center is at minus g minus f and its radius is root over g square plus f square minus c. Okay, let us consider this is the center. Okay, now we have to find out the area of this equilateral triangle. We have to find out the area of this equilateral triangle. Now we all know that this angle is 60 degrees since it's an equilateral triangle. Now if I join these two lines, these two vertices with the center, so what we are going to have, this angle is 120 degree, correct? This angle is 120 degree. Now remember that if you want to find out the area of the equilateral triangle, I will use the formula which we have already know from very childhood, that the area of an equilateral triangle is root 3 over 4 into side square. So the moment you have the side, the moment you know the side, the question is over, right? So how to find out the side? How to find out the side of this equilateral triangle? Think about it. You know the radius, you know the center. How to find out the side of this triangle? Here I will use a pretty simple thing, which is from the properties of triangle. See, in this triangle, let me just give a name. Let me say this is my A, this is B, this is C. Now, in the triangle ABC, AB and AC, they are the radius. Let me denote this radius by R. So this is R, this is R. Now, if I apply the cosine formula, for this angle BAC, what we are going to have? Cos 120 cos theta is R square plus R square minus BC squared divided by 2 into R into R. Okay, those who know the cosine formula, they can understand what I'm doing. Those who don't know, please see properties of triangle chapter in trigonometry. There you will learn how to find out this cosine formula, because as I know that you have already applied this cosine rule in physics also, so you must know this. So from here we can write cos 120 is minus half, 2 goes off, minus R square is 2R square minus BC square. So your BC square is coming to 3R square, correct? So what is your BC? Your BC is basically root 3 into R. Clear? Abhi, what will be the area of this triangle now? Root 3 by 4 into side square. And side square is what? It is 3R square. So you are going to have 3 root 3 over 4 R square. R square is G square plus F square minus C. So this is the area of the equilateral triangle circumscribed by the circle given by this equation. Is it clear? So this question, you must know how I got that, and at the same time you must remember this formula. Treat this thing as a formula. Whenever your circle is given and an equilateral triangle is inside the circle, the area of the equilateral triangle will be, remember in this way, equilateral triangle will be, it is 3 root 3 over 4 into radius square. 3 root 3 over 4 into radius square. That's exactly what we got. If you can remember this form, it's okay. If you can't, you can remember in this way also. 3 root 3 by 4 into radius square. That's it. Is it clear? Okay. Now see this question which came in JEE 2019. What they have said, if the area of the equilateral triangle inscribed in a circle this is 23 root 3, then C is equals to what? Now, if you don't know the formula, you can solve this sum. But it will take more time to solve, because if you don't know the formula, you have to do the same method to get the area of the equilateral triangle is root 3 times root 3 by 4 into radius square. This you have to prove. If you don't know the area of the equilateral triangle inscribed in the circle beforehand. So that is why I told you, please do remember the formula. So area of the equilateral triangle inscribed in the circle, this is this, then find C. See how simple it is if you know the form. What is the area of the equilateral triangle? Area of equilateral triangle. What is that? 3 root 3 over 4 into radius square. Okay, and that exactly what they have said. This is equals to 27 root 3 that they have already given. So from here what you are getting, let me just simplify this. Root 3 goes off. So you are getting a radius square is 36. If radius square is 36, so what is your radius? It's 6. Okay, now for this given circle, the center is at -5, -6. And what is its radius? It's root over 25 plus 36 minus C. That's the radius. Yes, so I can write 61 minus C is 36. So your C comes to 61 minus 36. That gives us 25. Right? It gives us 25. Have you understood this or not? See how simple the thing will become if you know the formula. Otherwise, this you have to find out. This you have to prove sitting in the examination hall. That is why people used to say that your paper is lengthy. Right? So remember this and the thing will be easy. So your value of C is 25, hence option D is correct. Okay, understood? So what we have learned? We have learned that area of the triangle inscribed in a circle, okay, is 3 root 3 by 4 into radius square. Okay, remember in this way. Very good. Now, see this question. The question is, if the two vertices of an equilateral triangle, A and B are the two vertices given. Let me just draw the diagram. So what do you want? There are 2 points, A and B, minus A comma 0 and A comma 0. And the third vertex C lies above the x-axis in the equation of the circumcircle. Okay, so let me just draw the circle first. let me say this is the given circle. Okay, now this is my point A, which is your minus a comma 0. This is your point B, which is your a comma 0, correct? And the third vertex C lies above the x-axis, above the x-axis. So the third vertex will be definitely at this place. Okay, so because it is above the x-axis, let me just join this 2 points. Okay, so I've joined these 2 points. This point is basically C. So this ABC is an equilateral triangle. Clear? Now, equation of this circle. You have to find out the equation of this circumcircle. Okay. So, as I told you, to find out the equation, you need two things. बार बार हम एक ही चीज बोल रहे कि दो चीज तुम्हें चाहिए always. Remember, throughout your circle chapter, you need center and you need radius. That's it. If you give me these two things, I can do anything with the circle. Anything. So I need to find out its center. I need to find out its radius. Clear? So how to do that? Let us say the center is here. Now again, the same fund I am using, I am simply adding this. Simply join this one. Okay. Now, this angle is what? This angle is 60. So this angle will be what? This angle will be 120 degree, right? So this angle will be again 60 degree. Correct? Okay. So this is 60 degree. Then what? What is this length? What is this length? It's A. So from here I can easily find out what is this base. Let me just give a name. I can easily find out what is my dA, which will give us the radius. And we can easily find out what is your dm. So you will know the center. You will know the center. Yes or no? Okay. Now, how to find out the radius? Now, taking the triangle ADM. See the triangle ADM. This angle is 60 degree. This angle is 60 degree. And I need to find out, I know AM. I need to find out AD. So your A by AD is sine 60 degree. So your A over AD comes to root 3 by 2. Therefore, AD gives us 2A over root 3. AD 2A over root 3. That is, the radius of the circle is 2A over root 3. Is it clear? Now, what is your DM? By the way, please do remember this aim is nothing but the origin. This aim is basically the origin, isn't it so? Because this part is A, this part is minus A, comma 0. So definitely those A and B are on the x-axis. So aim is the origin. Please do remember. Aim is what? It is the origin. So you got AD, means you got the radius. Now I have to find out the center. For that, I have to find out what is DM. So again, DM over AM. DM over AM is cot 60 degree, right? So what is DM? It's AM cot 60 degree. And what is AM? The length of the side AM is A. Don't take minus A. It's A. Length cannot be negative. It's A into cot 60 degree. That gives us 1 over root 3. So it is A over root 3. DM is A over root 3. So what is the coordinate of D? It's basically, since it is on the y-axis, the coordinate of D will be 0, comma A over root 3. So now you know the center. You know the radius. So you know the equation of the circle. Center radius form. Open the brackets. So we are having 3x squared plus root 3y minus 9 whole square is equals to 4a squared. So let me open the brackets. We are getting 3x squared plus 3y squared minus 18 root 3y. Yes or no? 18 root 3y, which is equals to, am I doing it? Oh my God, it is not 9. It's basically a. I have written this thing as 9. It's okay. It's a actually. This is my a. So we will write this thing as, I will write this thing as 3y square minus 2 root 3ay plus a square is 4a square. So that gives us 3 times x square plus y square minus 2 root 3ay is 3a square. Is it clear? Hence option A is correct. Is it clear to all? Have you understood? See, again, बार बार हम एक ही चीज बोल रहे हैं. हम क्या कर रहे हैं? ऑब्जर्व करो. Every time my main motto is to find out the center and radius. Center और radius निकल गया, सब कुछ निकल गया of a circle. So whenever you are solving problems on circle, always you should have only one idea: how to find out its center and how to find out its radius. That's it. You will get all your answers. Trust me. Okay. Let us do another problem. Let the mirror image of the circle. So C1 is a circle given to us. C1 is a circle which is given to us, which is our C1. This circle is C1. Okay. Now I want to find out the image of this circle with respect to a line, given y is equals to x plus 1. Okay. So let us say the image of this circle will be somewhere here. This is the image. This is the image of that circle. Clear work? Right? Okay. So this is my circle C1. This is my circle C2. This is the image. Can you tell me? The image of this circle will have one thing common. What is that? That is its radius. Its radius. Radius of C1 must be equals to radius of C2 because they are the image. So their radius will be same. Their coordinates of the center will change, but not its radius. Okay. Now, what is the center of C1? From this, what you will say? What is its center? Its center is coefficient of x divided by 2, change the sign, it's 1. Coefficient of y divided by 2, change the sign, it's 3. Is it clear? And what about the center of C2? What is the center of C2? Your equation is what? So I will divide by 5. Yes. So what is its center? It's minus G minus F. That is, center of C2 is minus G minus F. Clear work? Is it clear to all? Okay. Equation of the line given to us is x minus y x minus y plus 1 equals to 0. Clear? So now the center of C2 will be the image of the point 1, 3 with respect to this line. So what will be its center? I'm using the image formula to find out the center of C2. Again, I'm telling you, those who have not done straight lines, they will face problem here. That is why I'm requesting all of you to please go through all the videos that I have uploaded in straight lines. Repeatedly, I'm telling you that. Otherwise, you will face problem throughout your coordinate geometry, not only in circle, in parabola, in ellipse, in hyperbola, everywhere you are going to face problem. So x minus 1, I'm not going to explain you how I'm doing this because the students who have already done this one, they can understand it better, why I'm doing this and how I'm doing this to find out the image of a point with respect to a line. So we are getting 2 goes off and this is only 1. So from here we are getting x is basically 2 and y is basically 2 also. Therefore, the center of C2 is 2, 2. It implies what? Your minus g is 2, implies g is minus 2. Similarly, minus f is 2, implies f is minus 2. Correct? G is minus 2, f is minus 2. So, the given equation, this equation becomes what? This equation becomes, we can write from here only, it is x square plus y square. Your g is minus 2, so it is minus 4x minus 4y plus 38 over 5, which is equals to 0. Clear? Now, what is its radius? Its radius is root over 2 square plus 2 square minus 38 by 5. So that gives us 4 plus 4 is 8 minus 38 by 5. That is root over of 2 by 5. That's it. Is it clear? Now, this radius, this is the radius of C2. This is the radius of C2, radius of C2, which is same as radius of C1. Yes or no? Radius of C1. Now, what is the radius of C1? It is root over. This is radius of C1. What is that? Root over of 1 square plus 3 square minus alpha. Yes? So you are getting what? Under root 10 minus alpha. So this must be equals to root over of 2 over 5. Therefore, 10 minus alpha gives us 2 over 5, implies alpha is 48 over 5. Alpha is 48 over 5. Is it clear? Therefore, we need to find out the value of alpha plus 6r squared. So it will be what? 48 over 5 plus 6. R means this is your R. Because R is the radius of R2, C2. So this is your R. Yes or no? This is your R, which is the radius of your circle C2, which is same as the radius of your circle C1. So your R is root over of 2 by 5. So 6r square will give us. So that gives us 48 plus 12 over 5. That gives us 60 over 5, gives us 12. So the required value of this alpha plus 6r square is nothing but 12. Is it clear to all? Absolutely? No doubt? Okay. Let's move for the next one. So we have already done 3 forms of circle. One is your center radius form. One is your center radius form. The another one we have done standard form, and then we have learned what is the general equation of the circle. So these 3 forms we have already learned. Now we are going for another form which is called your concentric circles. Concentric circle. What do you mean by concentric circles? Concentric circles are those circles which are having its center same. The center of all concentric circles, their centers are all same. See, these are all concentric circles. They're all centers are same. Their centers are same. So the only thing which is different for all these circles, because there will be infinite number of circles which are concentric to the given circle. Let us say this is our given circle. Let us say this is our given circle. And the equation of this circle is x square plus y square plus 2gx plus 2fy plus c equals to 0. Now, any circle which is concentric to this circle, its center will never change. Its center will remain same. Yes or no? Its center will remain same. Only thing that will change is its radius. Think about it. What is its center? Minus g comma minus f. This is not going to change for any concentric circle. And the radius of this circle is root over g square plus f square minus c. Now, as g and f are same for all the concentric circles differ by its radius only. So this c will get changed every time. For different values of c, you are going to have different equation of the circles which are having their center same as minus g minus f. These circles are what called your concentric circles. Clear to all? Therefore, equation of all concentric circles of one is this one. Any concentric circle of 1 is given by only this constant will differ. For different values of lambda, it is going to represent different concentric circles. Why I'm telling you concentric? Because their center is not getting changed. That is why it is concentric. Okay? Only the radius will differ. Is it clear to all? So now we know how to find out the equation of concentric circle of a given circle. Okay, great. So all we do is we write the same equation, only we change the constant of the given equation. That's it. Let us say this question. Find the equation of the circle concentric with this circle and passes through minus 2 comma minus 7. Okay. Any equation concentric to the given circle, equation concentric to the circle is given by x square plus y square. Everything remains same. Only this constant will be changed. Correct? Now, as it is passing through the point minus 2 comma minus 7, hence it must satisfy this equation. So put minus 2 in place of x and minus 7 in place of y. to get the value of lambda. So how much you are getting? It's 16, 4 plus 16, 20, 69 minus 42 plus lambda equals to 0. So 69 minus 42, that is going to give us 27. So lambda is coming to minus 27. Is it clear? Lambda is coming to minus 27. Therefore, what is its equation? X square plus y square minus 8x plus 6y minus 27 equals to 0. That's it. So that's the equation of the concentric circle of the given circle, which is passing through the point minus 2 comma minus 7. Is it clear? Is this conception clear? It is simply the application of the equation of the concentric circle. Okay. Now, let us come to another important thing, which is called important form of the circles, which is called the diametric form of the circle. What is that? We have been given a circle, and at the same time we have been given the extremities of the diameter. Suppose this is the diameter, and we are having the extremities of the diameter as x1 comma y1 and x2 comma y2. These are the extremities of this diameter. This is a diameter. It is passing through the center. Now the question is, you have to find out the equation of this circle. See, there are two ways of finding out. One, very boring method, and number two, the second method is very interesting method. But first I will tell you the first method. I told you to find out the equation of circle, you need two things. One, it's its center, and another one, its radius. Please try to observe this carefully. So what will be its center? As we know, the center is the midpoint of the extremities of this diameter. Therefore, the center will be x1 plus x2 by 2, y1 plus y2 by 2 by using the midpoint formula. Now you know the center. You know the other points on the circle. So you can easily find out, the distance between these two. So there straight away you are going to get the radius. So you know the center, you know the radius, you know the equation. Am I correct? This is one way of doing. This is method one. Okay, to find out the equation. You know the center, you know the radius. So easily by center radius form of the circle, you can find out its equation. Okay, but I will use method two. Both these methods you have to know. Methods you should know. Okay, so what I will do, I will simply take, let x comma y be any point on this circle. Let x comma y be any point on the circle, and I will simply join these 2 points. This one and this one. Is it clear? Now, how many of you can see that this angle is 90 degrees? How many of you can see that this angle is 90 degrees? Why? Because angle in a semicircle is always a right angle. So now to find out the equation, what I will do, I will simply find out the slope of this line. What is the slope of this line? It will be y minus y2 over x minus x2. And what is the slope of this line? It will be y minus y1 by x minus x1. Now, since the angle between them is 90 degree, so the product of these two slopes will be equals to -1. And you got the equation of this circle straight away. How I will write this? So we are having y minus y1 into y minus y2 equals to 0. That's it. That's it. So this is how we find out the equation of a circle when we know the extremities of its diameter. It's x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals to 0. That's it. What is x1, y1 and x2, y2? x1, y1 and x2, y2 are the extremities of the diameter. This is the extremities of a diameter. Is it clear? So the moment you know the extremities of the diameter, you know the equation of the circle. As simple as that. Okay? Good. Now I have written here a special observation. Very special observation. Can you see the equation of this circle when we know the extremities of the diameter? It's x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals to 0. And what is x1 and x2? These are the abscissas of the extremities of the diameter. And what is y1 and y2? These are the ordinates of the extremities of the diameter. Yes or no? Yes or no? So now, can you find a very interesting form? How many of you can see this? You people have all done this kind of things in quadratic equation. X minus x1 into x minus x2, it represents when a quadratic equation are having two roots, x1 and x2. If a quadratic equation, let us say x squared, whatever, plus say bx plus c, it equals to 0. It has two roots, let us say x1 and x2. So in that case, we can write x squared plus bx plus c is simply as your x minus x1 into x minus x2. Can you remember this form? So this is what we have learned. If in the question, listen it carefully, because JEE people have already given a question based on this. Whenever a quadratic equation is given in x, and we know that two roots are x1 and x2, then we can write this thing as x minus x1 into x minus x2. So the first form of this diametric form will be nothing but x minus x1 into x minus x2, which is same as the quadratic equation given to you in terms of x. Why I'm telling you why it is easier? Because here you don't need to find out what are the values of x1 and x2. I don't need it. Because the moment you have x squared plus bx plus c, I know that it will have two roots x1 and x2, which are the abscissas of the given coordinates of the extremities of the diameter. So why to multiply? Why to find out x1 and x2? I will simply straight away write in place of this x squared plus bx plus c. That's it. Similarly, whenever an equation is given to us in y, and they have said that these two roots are y1 and y2, where y1 and y2 are the ordinates of the extremities of the diameter, then why to find out y1 and y2? I will simply write in place of this quadratic expression. That's it. Getting my point? So it's a special observation you people must remember. I have written over here. Please see this one. What I have said, that a quadratic equation whose roots are x1 and x2. What is x1 and x2? These are the abscissas of the extremities of the diameter. And what is your y1 and y2? They are the ordinates of the extremities of the diameter. Therefore, the equation of the circle will be the quadratic equation whose two roots are x1 and x2. That is this expression I will write, or the expression which is given to us, I will write it. And a quadratic equation whose roots are y1 and y2, I will simply write that expression to get the complete equation of the circle. Is it clear to you? Let me take one example related to this. Let me take first this example. Let me take this example. No, not this sum. See this sum. This sum actually came in JEE Main 2022. What they have said? What they have said? They have said, let the abscissa of the 2 points P and Q on the circle be the roots of this. Listen it carefully. The abscissa of 2 points P and Q of a circle be the roots of this. And the ordinates of P and Q are the roots of this. If PQ is the diameter of this circle, then find the value of this. This is the question came in JEE 2022. Now, if you have a proper observation on the thing that I taught you right now, where it is, this one, okay? So, what you will write? A quadratic equation whose roots are x1 and x2. What is x1 and x2? Abscissa of the extremities of the diameter. And what is y1 and y2? The ordinates of the extremities of the diameter. So in this question, we have already been given this circle is given and this diameter is given, whose extremities are, let us say, it is x1, y1, and this is x2, y2. Now, to find out the equation of the circle, because you have to find out the equation of the circle, until unless you get the equation of the circle, you cannot compare with this one to get the values of A, B, and C. So now if you want to solve for x1 and x2, you have to solve this equation to get x1 and x2. You will solve this equation to get y1 and y2. See how lengthy the sum will become. And you can easily see that these values are not very comfortable one. Because here you have to use Sridharacharya's method to get roots of y, which will be an irrational one, isn't it so? So it will make unnecessary the sum complicated. But if we know the basics, what we will do, we will simply write equation of the circle is, equation of circle is, I will simply write x square minus 4x minus 6 plus y square plus 2y minus 7 equal. That's it. That much simple it is. So x square plus y square minus 4x plus 2y equals to 0. That's it. So this is the equation of the circle whose extremities of the diameter PQ are x1, y1 and x2, y2. Now, according to the question, they have given that this is the equation of that circle. So I can compare. So I can write 2a is minus 4 implies a is minus 2. And 2b is 2. From there, we are getting b as 1. And comparing, we get c as minus 13. So what will be the value of a plus b minus c? It is minus 2 plus 1 plus 13. That gives us 12. So option A is correct. Yes or no? That much simple it is if you know the basics. That is why I told you, always try to remember the shortcut tricks that I am always give in my lectures. So make a note of it, because this shortcut methods will be highly useful while you will be solving problems, even in the IIT advanced level. Okay? Chalo. So now we have understood the fact that when it is a form given in this diametric form, and if the quadratic equation is given to us, we are not going to solve for x1 and x2, neither for y1 and y2. We will simply write down those equations to get the equation of the circle whose extremities of the diameter is known to us, right? Okay, let us take this question. Find the equation of the circle passing through the points So what is the question? The question is that a straight line, a circle is passing through the point, this origin 0, 0, and 2 points A, comma 0 and 0, comma B. Okay, now we have to find out its equation. We can easily see one very interesting thing here. We all know